Right. So Javon, if you have a circle, you have two formulas for a circle. You have x squared plus y squared plus 2fx plus 2gy plus c is equal to 0. Right? This is the general form. You also have the standard form. And the standard form is x plus f squared plus y plus g squared is equal to r squared. And if you are given the general form and you want to find for r would be equal to the square root of f squared plus g squared minus c. All right. So those are some of the basic things you need to remember. And in either form, you could let me just say they give you an equation like x squared plus y squared plus 4x plus 8y plus 9 is equal to 0. Using this, I could figure out for f and g. Notice something. This and this is in the same form. You noticing that?
Yeah.
So if I equate both equations, I could make the observation that 2f is equal to 4 and 2g is equal to
8.
right. And I could find for f and I could find for g. That being said, you don't need to find for the center. To find for the center is given by minus f comma minus g. So the center for this particular circle would be minus 2 comma minus 4. That being said, if you wanted to find for the radius, it would be equal to the square root of f squared. F is 2, so it'll be 2 squared plus g squared is 4 squared minus c. And in this case, c is what?
9.
9. So 4 plus 16 is 20. 20 minus 9 is 11. So r is equal to the square root of 11. So that being said, if I wanted to write that in the standard form, I would say x plus f, so x plus 2 squared plus y plus 4 squared is equal to the root 11 squared. There's a quick recap as fast as possible of circles. Let me know if you understand.
Yeah.
Okay, good. Right? That being said, let's move on to our question. I'm not doing a simple question, I'm doing a difficult question. So in 2021, question 3a, they are saying that the coordinates for the center of a circle is 2, 1, and the coordinates for a point on its circumference is 3, 3. Determine the equation of the circle in the form x squared plus y squared plus ax plus by plus c is equal to 0. So in this question, they are giving you the center. So they're saying that the center is 2, 1. Remember, what do we call the center? The center is given by?
2f x 2gy.
No, the center is given by minus f comma minus g.
Oh yeah.
So if they gave us the center, and we know that the center is minus f comma minus g, minus f would be equal to what?
-2 and
No.
-1.
Now, the center is given by minus f comma minus g. So minus f literally is 2, and minus g quite literally is 1. So I feel like I make that mistake.
Oh, no, I thought you asked for f.
Okay, okay. All right, so minus f is equal to 2. So f would be equal to minus 2. Minus g is equal to 1. So g would be equal to minus 1. Right. They also give me a coordinate for a point on its circumference. So that being said, you could imagine we have this diagram here, and we have the center. So let's just say that this is 2, 1. Again, this is not very accurate, but it's just a quick representation. And this could be 3, 3. So if I have a point at the center and I have a point at the circumference, what could I do? If I connect those points together, what would I get?
A radius.
Radius, right? When we are doing coordinate geometry and I have 2 points, is there a formula I could use to find length given 2 points?
Yeah. Root x x 2 minus x1 squared plus y2 minus y1 squared.
Perfect. Fun fact, I got that from the Pythagoras theorem. That's Pythagoras theorem, in case you didn't know.
Oh.
X2 minus x1 squared plus y2 minus y1 squared. By the way, if you ever get confused and you swap the order, it don't matter because you're squaring it. So it could be x1 minus x2, it could be y1 minus y2, it could be anything, you'll get the same answer. That being said, we pick one for x1, y1, and we need to pick one for x2, y2. I'm going to pick this as x1, y1, and I'm going to pick this for x2, y2. So that'll be equal to the square root of, right? So x2 is 3, that'll be 3 minus 2 squared plus y2. Y2 is 3 minus 1 squared. 3 minus 2 is 1, 1 squared. And 3 minus 1 is
2.
squared. So 1 squared plus 2 squared is 5. So in odd maths, we typically leave the answer in third form. So that'll be root 5 units. And that's not just any length, that's the length of the radius, right? So anytime you
Yeah.
have the center and a point at the circumference, you can find the length of the line, which will give you the radius. So let's look at what we have, right, Javon? We have the radius and we have f and g. So which form could we plug that into? Which form has f?
The x plus f squared plus y plus g squared equal to r squared.
That's correct. Right? So this is correct, right? Or should it be a minus sign in the middle?
No, I think it's plus.
Let me just verify real quick. Verify very, very quickly. Have everything in the formula sheets. Yes, it's plus. Cool. That being said, now we could substitute. So what is f and what is g? Remind me, what is f and what is g?
F is -2.
So plus minus 2. Plus by minus is minus. So that's going to be x minus 2 squared. And this is going to be y minus 1 squared. And r is root 5. So that'll be root 5 squared. Now, in the question, they wanted me to get this in the form x squared plus y squared plus ax plus by plus c is equal to 0. And you need to recognize that that form is the general form. So for me to get it in the general form, I would need to expand this out. So x minus 2 squared would be x minus 2 by x minus 2 plus y minus 1 by y minus 1. The square root of 5 squared is what?
5.
X by x is x squared. X by minus 2 is minus 2x. Minus 2 by x is minus 2x. Minus 2 by minus 2 is plus 4. Y by y is y squared. Y by minus 1 is minus y. Minus 1 by y is minus y plus 1. We're going to move across the 5 one time, right? Because in the form of in general form, it's typically equal to 0. So I'm going to move across the 5. So that'll be minus 5 is equal to 0. I'm going to start putting it in the form. So I see I have a y squared term, so I'm going to write it by the x squared. Minus 2x is minus 4x. Minus y is minus 2y. And let's look at the constants now. We have plus 4, we have plus 1, and we have minus 5. 4 plus 1 is?
5 minus 5 is 0.
Right. So your final answer is x squared plus y squared minus 4x minus 2y is equal to 0. Are you okay with that?
You need to put the plus 0, or it don't really matter.
You don't need to put the plus 0. Let me ask that question. If I had something like 5 plus 0, right? Does it make sense to write 0?
Nah.
I would just write 5, right?
Yeah.
Yeah. So take those things into consideration. Cool. And if you wanted to verify quickly, this is what you could do. Remember, in this form, anytime you're given the general form, you can find radius, right? And the radius is given by f squared plus g squared minus c. Do you recall that?
Yeah.
Okay, well, we found f to be, well, if we work out for f here, f would be equal to minus 2, so that'll be minus 2 squared. If we work out for g here, that'll be minus 1 squared, and c is 0. So let's see if it'll work out real fast. Minus 2 squared is 4, minus 1 squared is 1, 4 plus 1 is 5. Do we get back the same radius?
Yeah.
So we're good. Nice. All right, part 2. The circle intersects the x and y axis at 3 points. Right?
Yeah.
Circle intersects the x and y axis at 3 points. Determine the coordinates of the 3 points of the intersection. All right. So anytime we're talking about the x-intercept and the y-intercept, in case you didn't know that way was, that's where it is. If our graph cuts the x-axis, that's the x-intercept. If it cuts the y-axis, that's the y-intercept. So let's deal with the x-intercept first. Now, if something cuts the x-axis, what is the y value?
0.
Right, so for the x-intercept, y is equal to 0. So, and that means anywhere we see y in this equation, we're going to substitute what?
0.
Right, so you're going to say x squared plus 0 squared minus 4 by x minus 2 by 0 is equal to 0. You'd end up with x squared minus 4x, and that is equal to 0, right?
Yeah.
See anything in common here? Here?
Could probably do difference at two squares here.
No, I can't do difference of two squares.
Oh, no.
I can't do difference of two squares. If it was that, then yes, because I could have write 4 as 2 squared, and then I could have end up with 2x all squared. But it's not that case. So what does it have in common between that term and that term?
X.
So we could pull out the x. And remember the trick I show you, if you have trouble factorizing, you can do this. X into x squared is x, and x into minus 4x is minus 4, right?
Yeah.
Right? That being said, we can now say x is equal to 0. So x would be equal to 0, and x would be equal to
Plus 4.
plus 4. That being said, my points are 0, 0, and that corresponds to this, right? Remember, at the x-intercept, y is equal to 0. So the y value is 0. And over here now, we have x, y again. So the x value in this case is 4, and the y value is what again?
0.
Right. Cool. We found 2 points already. That being said, let's move on to the y-intercept. When we are dealing with the y-intercept, x is equal to
0.
So anywhere we see x, we put in,
0.
right? So that would be x squared plus 0 squared minus 4x minus 2 by 0. That'll be equal to 0. So that'll be x squared, right? Wait, what are you doing, buddy? Sorry about that. Yeah, sorry about that. Yeah, so anywhere I see x, I'm going to replace it for 0. So that's supposed to be 0 squared plus y squared minus 4 by 0 minus 2y, and that's going to be equal to 0. So if I simplify that, all the terms that we multiply by 0 would just end up being 0. So that's going to be y squared minus 2y is equal to 0. Again, you're seeing y here and y here, so you can factor out the y. If I factor out the y, what would I have on the inside?
Y minus 2.
Right? Y minus 2, that's correct. And so y would be equal to 0, and y would be equal to,
Plus 2.
right, so I want you to tell me the coordinates then.
0, 0, and 0, 2.
Right. So if you notice, we're getting the same points over here. So that counts as 1. Those two count as 1. So that's 1. And if you notice, these two are different. So this counts as 2, and this counts as 3. So do we get the 3 points that they're discussing that they're telling us about? Because it said it intersects the x and y axis at 3 points. Did I get 3 points?
You get 3.
Right? Yeah, we got the 3, right? So let's do part 3 now. Let's do part 3. So in part 3, they're saying determine the equation of the tangent to the circle at point 3, 3. All right. Whenever you have a question like this, you have to take something into consideration. So we got the center. What is the center again? Right,
1.
1, right? And they are giving us a point on the they say determine the equation of the tangent to the circle at the point 3, 3. So we have a point 3, 3 somewhere. So let me just see 3, 3 is over here, right? Now, if I connect those 2 points, I'll get the radius. And so, and I can find the gradient of the radius.
Yeah, I think I get 2.
And the gradient of the tangent will be what to the gradient of the radius?
The negative reciprocal.
Right. So whatever the gradient of the radius is, this will just be the negative reciprocal, right? So let me do that real quick. So let's find the gradient of the radius. So MR, and we typically call this the normal, right?
Yeah.
If you want to find the gradient of the normal will be given by again, y2 minus y1 over x2 minus x1. Right? Let's call this x1, y1, and let's call this x2, y2. So that'll be equal to 3 minus 1 all over 3 minus 2. 3 minus 1 is what?
1 over, wait, 2 over 1.
Let's verify. Yeah, 3 minus 1 is 2, and 3 minus 2 is 1. So you're supposed to get 2, right? You got 2, right?
Yeah, wait, so at the tangent is negative reciprocal and normal is just the normal gradient.
Yes. Yes.
Okay.
And I need you to understand why. So if you forget in the exam, it'll make sense. So Javon, when you are finding, and you have a center here and you have a point over here,
Yeah,
what's this line? And that's the radius,
yeah,
also called the normal. If I find the gradient, wouldn't that be for the normal?
yeah.
Right. So understand it intuitively. And if that's the case, then the gradient of the tangent would be negative reciprocal. And nowhere there's a confusion, because when we do differentiation, you find the gradient of the tangent, and it's find the gradient of the normal, you'd find the negative reciprocal. So you're thinking maybe it should be the same thing. No, different topic. Right?
Yeah.
Okay, so if I wanted to find the gradient of the tangent, which is tangential to the normal or the radius, I would have to find the negative reciprocal. So the negative reciprocal of 2 over 1 would be what?
Negative a half.
Negative a half, right? And do I know any points that did they give us any points that was part of the tangent?
Yeah, 3, 3.
Right. So whenever you're doing a question like this, you need to know the gradient and you need to know you need to know a point on the line. So you need to know gradient and point on the line. Okay, great. So we're going to use y is equal to mx plus c, right? That's the simplest approach. And remember, the point was 3, 3. So x is 3 and y is 3. That being said, I'm going to plug in everything and find for what? What am I going to find for?
Plus C.
Find for c. Right, so let's go. So y is 3. The gradient is negative a half. X is 3 plus c. So you're going to end up with 3. So c would end up being 3 plus 3 over 2. Reason I got that is because minus a half by 3 is minus 3 over 2. If I move across the minus 3 over 2, it's into plus. So 3 plus 3 over 2, that should be
9 over 2.
9 over 2. You got
Yeah.
that? So c is equal to 9 over 2. All right. So c is equal to 9 over 2. So tell me what y would be equal to.
Negative a half x plus 9 over 2.
And if they asked for it in a form with no denominators, what would you do? If they, yeah, so if they,
Just uh hmm,
so if they ask for it in this form, like they say ay plus bx plus c is equal to 0 or something like that, because they could do that. What would you have?
2
What
on the numerator.
you would need to multiply by 2 everywhere, right? You understand?
Yeah.
We have a fraction over 2, so we multiply by 2. So that's going to be 2y, and minus a half by 2 is minus x, and 9 over 2 by 2 is plus 9. So that if you want the answer in that form, you know how to do it as well. So that's that. We just did one of the trickiest circle theorem questions. Not circle theorem, according to geometry. You
Yeah.
understand?
Yeah.
Well, let's move on. 2016. The point M, 3, 2, and N minus 1, 4 are the ends of a diameter of a circle C. Determine the equation of circle C. Find the equation of the tangent to the circle C at point minus 1, 6. Again, this is another one of the trickiest questions. In this question, they gave you points at the end of the diameter. So let's do a quick sketch. So we have a circle here, and they're giving us points at the end of the diameter. Now, if I connect, so you notice it's saying at the ends of a diameter, right? So if I were to connect these 2 points, the middle of the point would give you the what?
The center.
Give you the center, right? So let me just say that this is minus 1, 4, and then we just say that this is 3, 2, right? So if I wanted to find for the center point, what would I have to do?
Hmm. Length of line. Um,
The center is a point.
midpoint.
Wait, so give me a second. Right, midpoint. So we need to use the midpoint formula. And you're supposed to know this formula from maths. To find the midpoint, it's just x2 plus x1 or x1 plus x2. You just add any two x values all over 2, comma, y2 plus y1 all over 2, right? So to find the midpoint, you just add the two x values, divide by 2, add the two y values, divide by 2. It doesn't matter the order. You understand?
Yeah.
So like I said, it really doesn't matter the order. You just add any two x values. But I'm gonna label it. I would just call it x1, y1, and we could call this x2, y2. So that's gonna be 3 plus minus 1 all over 2, comma, y2 plus y1. Y2 is 2, y1 is 4 all over 2. So 3 plus minus 1 is 2, 2 over 2 is 1, and 6 over 2 is 3. So the midpoint is supposed to be 1, comma, 3. Did you get that?
Yeah.
So we just found the center. And if we have the center, we automatically know for what and what. Or we can find for,
For F and G.
right? Because in the center of a circle, we know that the center is minus f comma minus g. So
Yeah.
f would be equal to,
-1,
g would be equal to.
-3.
All right, cool. So here what? They want us to determine the equation, right? We have f and g. What is the only thing we're missing, really? What are we missing? What are we missing?
The equation of the circle.
Yeah, we're missing that way we gotta find, right? That way we gotta find. But we have,
Yeah.
so typically with these kind of questions, you would always get the standard form, and from the standard form, you'd find the general form. So in the standard form, it comprises of f, g, and r. I have f and g. What am I missing?
Oh, R. The
R.
radius.
And we know that the radius is the length
Oh, yeah.
from the what to the what. What is the radius? Is the length
The center to the circumference.
a point on the circumference. So you could either find the length here to here, or you could find the length here to here, or you could find the length from here to here and divide by 2. Understand?
Yeah.
All right. So which one you want to do?
Um, you could do the 3 and 2.
Right. So to find the radius, you're saying you're gonna choose 1, comma 3, right? And 3, comma 2, right? That's what you're saying.
Yeah.
Right? Let me just call this one x1, y1. We call this one x2, y2. Right? And to find the radius, we're going to use the length line formula, right? And we know what the length line formula is by now. Is x2 minus x1 squared plus y2 minus y1 squared. Remember?
Yeah. Wait, the minus C is for which, for what?
Okay, so you're probably wondering, well, why I didn't use square root of f squared plus g squared minus c, hence?
Yeah.
Okay, do we know what c is?
No, we don't have a C.
We don't have c. So the only time you use that formula is when you are given the general form. Because and from the general form, you could find for f, g, and c.
Yeah.
Take a note of that one time. You could only use this formula. You could only use the square root of f squared plus g squared minus c only for the general form. So cool. Take note of that. Right. So let's find the radius, right? So the radius will be we are finding it using the length of line formula. So
Yeah.
That's going to be x2 minus x1 squared plus y2 minus y1 squared. X2 is 3. That's going to be 3 minus 1 squared plus y2 minus y1. That's 2 minus 3 squared. So 3 minus 1 is 2. That'll be 2 squared. And 2 minus 3 is minus 1. Minus 1 squared is 1 squared. So that's going to be equal to the square root of?
5.
Right. All right. 5. And don't forget to put units, right? Because we're finding the length of something. Is that clear?
Yeah.
All right. So we have F, we have G, and we have R. Nice. And we could write that in the standard form.
Yeah.
Right. So in the standard form is x plus f squared, right? Plus y plus g squared is equal to r squared, right?
Yeah.
Right? What is f?
-1.
And g is minus 3. So x minus 1 squared plus y minus 3 squared, and that's equal to root 5 squared. So you're okay with everything so far?
Yeah.
You should know how to expand that by now. So when you expand it, you're going to get x squared minus 2x plus 1. For the other one, you're going to get y squared minus 6y plus 9. If you move across the root 5 squared, you'll get minus 5, and that'll be equal to 0. Did I do anything that you feel like you can't do?
No.
Yeah or no?
No, no.
Okay. Now we need to group together the like terms, right? Well, more so, we want to group it in a form to get x squared plus y squared plus 2fx plus 2gy plus c is equal to 0. So I'm going to take the y squared, put it by the x squared. So x squared plus y squared. Then I'm going to put minus 2x. Then I'm going to put minus 6y. And we're looking at the constants now. So I have plus 1. What are constants I have?
1, 9 and -5.
1 plus 9 is?
10,
Minus 5 is?
5.
And that's supposed to be equal to 0. Again, if you want to verify, what we could do is we could use so you see and you see that now we have the general form.
Yeah.
Okay. From the general form, and we can figure out that f is minus 1 and g is minus 3,
Yeah.
right? And from the general form, what we found for c? What is c? C is what?
3. Oh, 5.
5, right? So then we just confirm that we get in root 5, right? Because we're supposed to get root 5 for the radius. So that'll be equal to f squared plus g squared minus c. So that's going to be equal to f. F is minus 1 squared. Minus 1 squared is 1. Minus 3 squared is 9. Minus 5. 1 plus 9 is 10. 10 minus 5 is?
5.
So are we doing everything correct?
Yeah.
Yeah. All right. So I trust that you understand this fully now. All right. Part 2. Find the equation of the tangent to the circle C at the point P minus 1, 6. All right. So they want us to find the equation of the tangent. Remind me again. So do we know what the center of the circle is?
Yeah.
We know what the center is. The center for the circle was?
1, 3.
And they're giving us a point outside, right? Minus 1, 6.
No, 4.
Now watch. Minus 1, 6. Find the equation
Oh,
of the circle C at point P minus 1, 6. Right? So they're giving us a point P. So we could put P anywhere. So let me just say P over here, right? Minus 1, 6. And so, hence we could find the gradient of what? We're going to find the gradient of first.
of the radius
Or the, what do we
or
call
the normal.
it? We typically do call it the normal. And if we want to find the gradient of the tangent, which is that, you would need to find the negative reciprocal of the gradient of the normal. Right? So let me just call this one x1, y1. We'll call this one x2, y2. Again, it does not matter the order in which is stated. Once you do the math correct. Right? Gradient is equal to y2 minus y1 over x2 minus x1. So that'll be 6 minus 3 all over minus 1 minus 1. So 6 minus 3 is?
3.
3 minus 1 is?
-2.
So that's the gradient of the normal, right? What would be the gradient of the tangent then?
Plus 2/3.
Plus 2/3, fine. So you find the negative reciprocal, cool. Do we know a point that is on the tangent?
Yeah, the 1, -6. The -1, 6.
Oh, mountain tiger, stay for a second, yes? Instead of saying, instead of saying -1 6, you say 1 - 6. You know how them guys say chicken curry,
Yeah, yeah.
right? So let me keep talking. So we have a point. We have a point, -1, 6. That being said, x is y, x is -1 and y is 6. So we're going to use y is equal to mx plus c. So y is 6, m is 2/3, x is -1 plus c. So if I find for c, I will end up with 6 plus 2/3. Why plus 2/3? Because 2/3 and -1 is -2/3. If I move across that, it will be 6 plus 2/3. 6 plus 2/3 is supposed to get 20 over 3.
Yeah.
20 over 3, nice. So what is my final equation for y?
Y equals to 2/3 x plus 20/3.
And if they ask for the answer in a specific form, meaning that there's no fractions, you multiply both sides by.
By 3.
Cool, cool. So we done with circle, we done with coordinate geometry / circle theorem.
Yeah.
You go with everything? I'm gonna feel okay.
Yeah, I think I'm good with everything now. Just vectors probably.
All right, let me do vectors now, fast. Vectors is very simple. Under vectors, you need to know how to find the dot product. The dot product, let me give a quick recap of that. Let me just say we have vectors. By the way, in AdMaths, we don't write vectors like we don't say like 2, 1 and thing. We don't say 2i plus 1j. So let me just say we have the vector 2, 1, right? That's the column vector format. And we have vector b, 3, 4. If we wanted to find a dot b, how do we find a dot b? To find a dot product, it's always the x components. You're multiplying the x components, right? And then you're adding the y components. So that's the dot product. So you'd say 2 by 3, right? And I'd say what by what then?
1/4.
Yeah, 1 by 4. And what would you end up with as your answer?
10.
Right? 10. Nice. Cool. Cool. All right. So you go with that, right?
Yeah.
Okay. The other thing you need to know is you need to know how to find the magnitude. By the way, if this was in the other vector form, it would be 2i plus 1j. And this would be what?
3i plus 4j.
And both of those are examples of position vectors. So you need to know is a position vector as well. A position vector is a vector that starts from the origin. So this is what I mean. You start at the origin and you go to some point, 0 to a. All right. Right? Wait. Javon, my phone rail going up, boy. I
For
see.
the
See,
crash course, the marathon.
yeah, you know how people like free thing. Yeah, right. So I see in that, we're gonna do real past papers.
Yeah, yeah. I think I might have a clock out a little early though. I don't like to go too late for
Nah,
exams.
nah, that is no problem. I'll ask all their questions, get the help, and go sleep whenever they want. I go in till whenever, but it's up to you to leave whenever you want. You can leave whenever you want. I'm not pulling on all your hostage and
All right.
you know dot product. And you need to know, you also need to know how to find magnitude. Magnitude is represented by vertical lines on either side, like that. And to find magnitude is quite simple. If I wanted to find the magnitude of A, that would be 2 squared plus 1 squared. So that would be equal to 5, root 5. If I wanted to find the magnitude of B, that would be equal to the square root of,
3 squared plus 4 squared, which would be 5.
yeah, well, the final answer will be 5, right?
Yeah.
Okay, so you need to know how to go from column vector form to the other vector form. You need to know how to find dot product. You need to know how to find magnitude. You need to know how to find unit vector. So what exactly is unit vector? A unit vector is a vector whose magnitude is 1. So to find the unit vector is denoted by a top hat. This is top hat, and it's given by the whole vector divided by the magnitude of the vector. So let's just say we have a, right? So if I wanted to find the unit vector of a, vector a is 2i plus 1j. And I would divide that by the magnitude of a. The magnitude of a is root 5. So my final answer is 2 over root 5i plus 1 over root 5g. Let me know if you understand that.
Yeah, that's for the unit vector.
Okay, this is a unit vector. And here we're saying again, right? Every unit vector should have a magnitude of 1. So if I find the magnitude of this, what am I supposed to get?
1.
Supposed to get 1. So what you're gonna do is tell me, how would I find the magnitude of this?
Um 2 plus 1 squared
2 over root 5 squared plus,
or plus 1 over root 5 squared.
right, so plug into the calculator and I'm gonna know what you get. So supposed to get 1. If you don't get 1, you do something wrong. Or we do something wrong.
I forget square sign.
Don't forget our square sign in the exam.
No, no. Yeah, I get 1.
Right. So I hope you understand the concept now. The unit vector is just a vector that has a magnitude of 1. Now, Ollie should also be able to know about direction vector. Let me ask you that question. And you can have vectors that are going in the same direction, but they're just different lengths. Look at this. I could have this large vector here, and I could also have this small vector here. Can you recognize that both of them are in the same direction?
Yeah.
Right. So if you want to figure out any vector, you'd need to find the direction vector. The direction vector, we typically use the unit vector and you would multiply it by the new vector you want to get. I'll show you more on that just now. But these are the basic concepts in vectors you need to understand, right? So you need to know dot product. Um, you need to know how to find the magnitude, the unit vector, and additionally, you should also be able to find the angle between two vectors. So let me just say you have these two vectors here. This is vector, this is vector A, this is vector B. You want to find the angle in the middle, you should be able to use this formula. Cos theta is equal to, um, let me just verify. So I think it was A dot B by the magnitude of A by the magnitude of B. Let me just double check that, make sure. Yes, that's correct. Nice, I remember it. Awesome. So cos theta is equal to A dot B over magnitude of A by the magnitude of B. So, Javon, I told you that these were position vectors, right? Meaning that it's starting from the origin.
Yeah.
So A would be, so it would be 2, and then it would be 1. So this would be A. And then B would be 3, 4. So that would be like 3, then 4. So this would be B. And you can realize I'd have an angle in the middle.
Yeah.
I wanted to find for the angle in the middle, I use this formula. So cos theta would be equal to the dot product over the product of the magnitudes. Do we know what the dot product of A and the dot product of B is?
Yeah.
So the dot product of A and B is 10, right?
Yeah.
And if I wanted to find the product of the magnitudes, we know that the magnitude for A is root 5 and the magnitude for B is 5. So that's going to be 5 root 5. 5 root 5. Not root 25, Javon, not root 25. You can only do that when you have a root by another surd by another surd. If I have 5, which is a regular number, I leave it as 5 root 5. What do you think is the next step to find the angle? How do you find angles?
The cos inverse, all of that.
Right. All right, and what is cos inverse of all of that?
I get 26.6 degrees.
So you see the diagram I draw here? That would be the angle in the middle. So we just did the entire of vectors in like what, 5 minutes? Yeah,
Yeah.
that's vector sphere. Vectors is very, very short. Right? So that's all the things you should need to know. And from maths, the reason why I didn't tell you, I didn't show it, but it's because you needed to know it in maths. And you know the triangular rule of vectors? Triangular rule of vectors. So
Um,
in other words, let me just say you want to go from A to B. To go from A to B, that'll be A to O plus,
O to B.
yeah, you're supposed to know this from maths, right? And A to O would be negative OA plus OB. So just keep everything I did here is everything you have to learn in odd maths for vectors.
That's only for position vectors.
Yeah, that's on, no. If let me just say I had a vector, let me show you something, right? Let me just say I had a vector A to C, and then I had a vector, and then they give me this other vector DC, right? Let me just say they asked me to go from, let me just say they want me to go from A to D, right? If I wanted to go from A to D, and that'll be A to C plus C to D.
Yeah.
Yeah, so the concept is remain the same, right? Just keep that in mind. It's the same kind of concept. In odd maths, vectors has come real easy, so I really don't anticipate they giving you something that isn't position vector. But we're gonna do some questions now and you can see how it's come, right?
Yeah.
Right. Given the coordinates of the point, okay, anytime they give you coordinates, they are what kind of vectors? Remember,
Position.
position vectors, right? Because remember, if you're plotting a point and you just start from the origin and then you'll count like 7 there and then 3 down,
Yeah.
right? So given that the coordinates of A and B are 7 minus 3 and 2, 1 respectively, say the position vectors corresponding to the points A and B in the form xi plus yj. Right. So in part 1, they want us to state it in the form xi plus yg. So vector A, and when you're writing vectors, you don't use, like, you see how we have A and B? If I want to describe vector A, I would write O to A. I could either write O to A or I could write common A. So O to A would be equal to what, Javon? In the form xi plus yg, it'd be equal to what? X is the horizontal.
7i minus 3j.
Okay, you know the thing. X is the horizontal component and y is the vertical component. So that'll be 7i minus 3j. And O to B would be what?
2i plus 1j.
Right? 2i plus 1j. That being said, they want us to find for A to B. If I want to go from A to B, how are we doing that? A to what?
A to O, then O to B.
All right, A to O and O to B. So you can recognize that A to O is the same magnitude as O to A, just in the opposite direction. You can see
Yeah.
that. So A to O is the same thing as negative O to A. Yes or no?
Yeah.
All right. So then we're going to say negative, and we know that O to A is 7i minus 3j, cool, plus 2i plus 1j. You expand this out, you're going to get minus 7i, continue fast.
Plus 3j plus 2i plus I.
Now that's j.
2i plus j.
Right? Let's look at the like terms real fast. We have minus 7i plus 2i. Minus 7i plus 2i is minus 5i, right? And 3j plus 1j is 4j. Yes or no? You good?
Yeah.
Cool. Okay. The last thing they want us to do is to figure out the scalar product AOA dot OB. Do we know how to do that?
Hold on. Yeah. You could do
Tell me what to say.
minus 5i
No.
over
No. OA dot OB is a dot.
oh,
So
okay, yeah. 7i over negative 3j.
nah, nah. The dot product, let's look at the dot product one more time. To find the dot product, you are taking the x components, multiplying them, and adding it to the y component, the product of the y components. So if you look at OA and OB, you're looking at the x components. So the x components would be 7 and 2, right?
Yeah.
And then you're adding it to the product of the y components. So what are the y components?
Okay, so 7 multiplied by 2.
So 7 by 2, that's the x components plus the y components.
Negative 3 by 1.
Right. That's it. That's it. That is it. Right? 7 by 2 is 14, right? Minus 3, answer is 11.
Yeah.
So easy. And that is 5 marks. That's 5 marks. Crazy. I see you understood everything here, right?
Yeah.
So again, dot product is just the x values, multiplying that, adding it, and then you're multiplying the y values, and you simplify. That's it. Real easy. I'm telling you that. So easy. Let's move on to 2022 now. And this was a question in 2024, right? 2022. The vectors O to x and O to y are such that O to x is equal to 4i plus j and O to y is equal to I minus 4j. Show that the vectors are perpendicular. All right. If two vectors are perpendicular, that means that the dot product is 0. Right? So make a little note about that. If two vectors are perpendicular, it means that dot product is equal to 0. So we need to prove that OX dot OY is equal to,
0.
you could believe that is 5 marks. You could believe,
Ever.
yes, it's 5 marks. And let me show you how we're going to do that, right? We know how to do it, right? So that'll be OX dot OY. And so that's going to be 4 by I. Well, you're not seeing it here, but what's the number that's understood to be in front of the I?
1.
1. So we have a value for 4 here and the value for 1 here. So that'll be 4 by 1. Add.
1 by negative 4.
You could believe that?
Nah.
Yeah,
Can't cut.
since the dot product is equal to 0, vector OX and OY are, yeah. So just keep that in mind. Anytime they talk about perpendicular vectors, anytime you see perpendicular, dot product is equal to 0. Keep that in your head. Dot product is 0.
Yeah.
Right. So I trust that you understand this. Easiest 5 marks of your life. Vectors is such an easy 5 marks. My God. 2023 now. The position vectors of A and B relative to an origin O are such that O to A is 3i minus j and O to B is 5i minus 7j. Determine the unit vector A to B. So to figure out the unit vector A to B, I first need to find for what vector?
A to O.
Not quite. That's not the answer I want to hear.
A,
So we want to find the unit vector of what? What do we want to find the unit vector of?
A, B. The root of,
Wait, no. Do we have, I'm asking that question, right? Do we have AB? Do we have AB?
no, we can't do that.
So we need to find AB. So what would AB be equal to? Look at what was given.
A to O, then O to B, plus O to B.
Right. And we know that A to O is the same thing as,
Negative 3i minus j.
right. You tell me the answer, but that's okay. Right. So in the next line, that will be equal to minus 3i plus j, and O to B is 5i minus 7g. So you're looking at the horizontal components. So the x components, that'll be minus 3 plus 5, and that minus 3 plus 5 is 2i, and 1j minus 7 is minus 6g. Right? So that's A to B. No. So Javon, no, you have A to B. So if you want to
Yeah.
find the unit vector for A to B, it's going to be equal to the vector A to B all over the magnitude of A to B. Remember, unit vector, to do any unit vector, you first need to obtain the vector. So you needed to find for A, B first. You have O to A and you have O to B, so that's very easy. Right, so to find a unit vector, you need the vector itself, and you need to find the magnitude of the vector. You can't find the magnitude if you don't have the vector to begin with. So now we have the vector. The vector is 2i minus 6g. Let's find the magnitude of that. So what's the magnitude of that? How would we find that?
Root 2 squared plus negative 6 squared
In brackets or not in brackets?
in brackets.
Right? Some more you guess.
I get 2 root 10.
2 root 10. Let me just confirm if that's correct. So that'll be 4. 4 plus 10. Yeah, 2 root 10 is correct. Right? So that's the magnitude of A to B, 2 root 10. And so if you want to find the unit vector of A to B, it's going to be equal to the vector. What was A to B?
2i minus 6j.
Right? So we're going to write back 2i minus 6g, and we're going to put that whole thing over the magnitude of AB. The magnitude of AB is 2 root 10. With me?
Yeah.
Now we're going to split it up. So if I split it up, that's going to be 2 all over 2 root 10i minus 6 all over 2 root 10g, right? And we could simplify that because the 2 and the 2 could cancel off, and it would leave us with 1 over root 10i. And the 2 could go into 6 3 times, so that'll be minus 3 over root 10g. Yeah or no?
Yeah.
All right, so that's your final answer there. And what is the magnitude of this supposed to be equal to?
Supposed to get 0.
No. If you hear a unit, what number do you think of? A unit.
1.
1. So the magnitude of all unit vectors is supposed to be 1. So you could find a way to find the magnitude for that. Remind me, how are we going to find the magnitude of that?
Root 1 over 10 squared.
Again, you're back with the guy and he's stuck. It's 1 over root 10.
Oh yeah. Yeah.
10 over 1. Oh God. Yeah.
Yeah. Root 1 over root 10 squared.
Wait, you said
Minus
root 1 now. It's 1 over root 10. Say it, 1 over root 10.
1 over root 10.
Right? What next?
Um Plus open brackets negative 3 over root 10 squared.
All right, so plug that in, and it's supposed to be equal to 1 because that's what the unit vector means.
Yeah, 1.
Right, so how that was it for vectors. That's all for vectors. You good?
Yeah, that was good.
Nice. Real easy, right? Like so easy. Right, so anybody else in class? Okay, I'm not sure if
I
anybody.
know join.
Aliyah, that's you?
Yeah.
Aliyah, were you there for the questions I did for on vectors?
No, I know join.
Okay, you want me to go it over or you good?
With vectors? No, I think I could because I do this with you already. So
All right, so just recapping, in vectors, you need to know how to find the dot product. You need to know how to find the magnitude. You need to know how to find the unit vector, and you need to know how to find the angle between two vectors. So let me do an example where I had to find the angle between the vectors, right? So this same question, let me just say they add up at 3. Find the angle between OA and OB. So Aliyah, help me with this fast. Aliyah, if I wanted to find the angle, what formula I would need to use?
You would have to use the cosine rule.
Cosine rule. The cosine rule. So it's wait, I think you mean it's not the cosine rule.
Well,
The
cos.
formula. Cos theta is equal to
A squared plus.
nah. If you have to find the angle between two vectors, you use this formula. So it's a dot product of the two vectors. In this case, we have O to A and we have O to B. So it's going to be the dot product of O to A and OB all over the product of their magnitudes. Aliyah, I promise, like this is so easy. Don't get scared. So Aliyah, let me find the dot product, right? So just a quick recap. If I want to find the dot product of OA and OB, what I'm going to do is I'm going to multiply the the coefficients for I and the coefficients for G. So tell me, let me start off with I. That'll be 3 by
3 by 5 by. Well, yeah.
no, you don't write I. Just put in the coefficients, right? And then I'm going to
Okay.
plus. So I multiplied the horizontal components. Then I'm going to add and multiply the vertical components, which is G. So tell me,
Minus 1,
multiply by,
minus 7,
right? So that'll be equal to 15. And what is minus 1 or minus 7?
positive 7,
So what is 15 plus 7?
22.
Right? So we have so the top would be 22. And now we need to figure out the magnitude of OA and the magnitude of the other one. So do you remember how to find the magnitude of a vector?
That's the square root of
The
OA could be the square root of 3 squared plus minus 1 squared.
yes, you remember it. Right? So that'll be 3 squared is 9, 1 squared is 1, so that'll be square root of 10, right? Cool. O to B. O to B would be equal to what? Square root of?
The square root of 5 squared plus minus 7 squared.
Right? So that'll be equal to 25. 25 plus
Yeah.
9. 25 plus 49. That should be 74.
Yeah.
Right? So root 74. So now that I have the magnitude of OA and OB, you're going to multiply it. So that's going to be root 10 by root 74. Plug it into the calculator and let me know what you get for the right-hand side.
Um, 22 over 2 root 185.
Right, tell me the answers are decimal.
Um, you got 0.80.
0.80, you sure? Confirm that?
Yeah.
All right. So if I want to find for theta now, what do I have to do? Theta is equal to what?
Cos inverse.
Right? So what's that?
36.86.
Right. So anytime they ask you to find the angle between two vectors, you use cos theta and whatever the two vectors are, the dot product of it, all over the product of the magnitudes of the two vectors. That's what you do, right? You know how to find dot product and you know how to find magnitude. You shouldn't have an excuse. Get so the vectors is usually 6 to 5 marks. Get those marks. That's like the easiest marks in the paper, right? Yeah, no, you good?
Yeah.
Oh no, I don't realize we didn't do part two, but we just did part two, right? Yeah, Aliyah, we just did part two. So Aliyah, it's in part two there where you find the acute angle AOB.
Yeah.
Yeah, so I don't know why I asked that question. I mean, when that was part of the question. Oof. Yeah, so this is part two. Javon, you understand how we do part two? Anything new or you're good?
No, I good, sir.
All right, so you're getting that six or 5 marks, right?
Yeah, yeah, for sure.
Let's move on to so Aliyah, to tell you how much pace we was moving with. We finished with circles and we finished with vectors. Now we're gonna move on to statistics.
Okay.
Right. So Javon, you got to know the first question, and Aliyah, you got to know the second question. After that, we have probability, and that is it. We're moving on. We're moving on time. We're moving on time. We'll finish the syllabus. Yes, man. We finishing this. All right. So Aliyah, I need you to move fast, right? Fast, fast. So in 2021, give it a read. Yeah, give that a read.
The scores of a class of 30 students on a mathematics test were used to draw the box plot below. The total score possible is 20 marks.
Continue.
Using the box plot, determine the following: the median score, the range of the scores, the semi-interquartile range of the scores. Comment on the shape of the distribution of the scores. A student who wants to determine the mean score for the data set. State one reason why it would be impossible to determine the mean score from the box plot. State what additional piece of information would be needed to determine the mean score. Given that the sum of the 30 scores for the class is 354, and the sum of the squares of the scores is 4,994. Determine the standard deviation for the data set.
All right, Aliyah, let me move with speed, right? So I'm gonna be moving real fast. So we have a box and whisker diagram here, right? Now, in a box and whisker diagram, I'll do a little crash course on it. In a box and whisker diagram, this is what it typically looks like. Right? So Aliyah, this over here is your lowest observation. This is like the lowest value you could get. This is the highest, right? This over here, this is Q2. This over here, this is Q1. And this over here is Q3. Yeah, yeah, no, you good?
Yeah.
All right. Q1 is the lower quartile. Q2 is the median. And Q3 is the upper quartile. If we want to find for the interquartile range, how do we find for the interquartile range? IQR. IQR is equal to what?
Is that Q3 minus Q1?
Right, that's Q3 minus Q1. Cool. So you have everything you need to figure this thing out. Everything.
Yeah.
So Aliyah, tell me, in the first part, they want a median score. Median is Q2. How would I figure out for Q2? Look at this and look at the diagram they was given.
You look for Q2.
What is Q2?
Q2 is
Let me look to see what Q2 is, right? That look like it's in the middle of
10 point. No, that'll be
wait, looking like it's in the middle of what?
like 10 and 12, so 11.
11, yes. Right, so 11. You see how pretty the diagram is?
Yeah, like
Yeah. This is if I Javon, and you obviously have advanced past papers, right?
Yeah,
And some of them is like real bad quality, like the print something.
yeah. Most of them actually.
Yeah, and you see this textbook I make and have all the questions, and you see the quality of it. Like look at the diagram.
So you should publish it and like it's real good. The
But
notes and you given and that.
the reason why I can't publish this is because this is CXC questions and I'll get copyrighted.
Or
I'm working on a book that will not get me copyrighted, and that's this book over here. I will not get copyrighted for this, but this I will. So, Javon, after I finish my lessons on it, if you know anybody that need help, you could always recommend me. And yeah, this book is
Yes, I will.
this book is just for my students, just for my students, right? I can't get the opposite advantage. You know what I mean? I get the opposite advantage. Right? So Aliyah, yeah. Because if I look at this diagram in 2021 in all their copy, it go be real real shitty boy. Ooh. So Aliyah, the median here is 11, right? The median is 11.
Yeah.
All right, so that's the answer for the first one, 11. The range of these scores. Range, to find range, is the highest observation minus the lowest observation. What's the highest observation?
Um, the highest could be 20.
What's the lowest?
4.
20 minus 4 is 16.
Yeah.
That's the answer for this question, 16. The semi-interquartile range. To find for the semi-interquartile range, you first need to find for what?
Yeah, interquartile range.
Yeah, you need to find for the interquartile range, right? The interquartile range is what?
Q3 minus Q1.
Right, Q3 minus Q1. We need to find for Q3. What do you think is Q3? Would it be 1, 2, or 3?
It'll be 3.
3, right? So let me look to see what that is. So again, that looking like it's in the, it's supposed to be in the middle. Yeah, it's looking like it's in the middle. So what that is?
5, 17.
Right, 17. Where's Q1?
Um, 5,
5,
7. Sorry.
right? So the interquartile range is 17. No, 17 minus 7, that's 10. So the semi-interquartile range would just be half of the interquartile range, 10 over 2, which is 5.
Yeah.
Comment on the shape of the distribution of the scores. Some of you all probably have a hard time trying to figure out if it's positively skewed or if it's negatively skewed. Let me give a little crash course on it, right? Um, this is the this is the this is the way to figure out what the answer is every single time 100% correctly. Have no guessing game here. Right, so watch. So Aliyah, if it is, and okay, if you have a hard time remembering this, imagine a number line. Where is it positive, Aliyah? To the left or right? Where is a number line positive?
To the right.
Right, so if most of your values are to the right, then it's positively skewed. If most of it is to the left, it's negatively skewed, right?
Yeah.
If on either side it's the same, it's symmetrical. Um, Let me show you the mathematical way to prove it. If it's positively skewed, Q3, so Q3 minus Q2 will be more than Q1 minus Q2. If it's negatively skewed, Q2 minus Q1 will be more than Q2 minus Q3. If it's symmetrical, Q1 minus Q2 and Q2 minus Q3 will be the same. Right? Yeah, no, you understand?
Yeah.
All right. So to figure it out, we're gonna compare this length to this length. Which length looking bigger?
The second line.
And that's to the left or to the right?
To the right.
So is what? Positively or negatively skewed?
Positively skewed.
Right. Javon, you understand that method?
Yeah.
So Javon, if you want to know quickly if it's positively or negatively skewed, you're looking to see where this side of the diagram, where, okay, so you understand that this is Q2, right? This is Q3, and this is Q.
Yeah.
We are looking at the difference between Q1 and Q2, and we're looking at the difference between Q2 and Q3. We're looking to see which one is more. Now, and this would be to the right side of the data, the right side of the data. This is the left and this is the right.
Yeah.
So imagine a number line. If you have a number line to the right, it's positive numbers. So it's positively skewed. And we could actually do the mathematics behind it. So if you want to actually prove it, look how you're going to prove it, right? So Javon, let me find for this length, that distance. So to find
That's
that going to be Q2 minus Q1. That'll be equal to what? That'll be
11 minus 7.
4. And Aliyah, how are we going to find for this distance?
Um, el-
That we
17 minus
minus q,
11,
right? We're 17 minus 11.
6.
Right. So you can see it for itself mathematically. This distance is more than this distance. So it's positively skewed. And that's how you do it. Right? And you can do a little statement here. Since Q3 minus Q2 is more than Q2 minus Q1, the distribution is positively skewed. Awesome. Everybody understand that? Yeah, no? Let me know.
Yeah.
Yeah.
Okay, Annalie, here, nice. Giovanni, you understand that?
Yes, sir. What I just do, I just kind of like draw a kind of sketch on the box standard sky itself. And from there, I just determine it. But yeah, this method I have to.
Yeah, yeah. This is a method you would use to eliminate all guessing game. This is like an objective approach. This is like the way to get
Yeah, I'll use this one in the exam. My one, not too good.
like with this one, you're showing a proof. This is our proof here. You can't go wrong with the proof, right? So next up, let's do this question, right? This was a hard part. Like this, yeah, this was kind of hard. So that's why we're gonna do it now. So Aliyah, read part one for me.
A student wants to determine the mean score for the data set. State one reason why it would be impossible to determine the mean score from the box plot.
Right. So remind me, what is the formula for mean? By the way, in odd math, we use the formula x bar is equal to the sum of, remind me earlier, the sum of
X
over,
over
you want to say n.
N. Yeah.
Do we have the sum of all the scores? Or in
Can
any
they give that to you?
in no, let me look at the question, right? Did they ever give us the sum of all the scores in any part of the question? So they're saying that it had 30 people and the total score you could get is 20. Did they give you the total amount of scores? Like when you add up
No.
scores? No. Over here, did they give you any information about that?
No.
No. So we can't find the mean. The reason why we can't find the mean is because we were not given the sum of all the scores, right? Right? So the sum of scores was not given. Giovanni, you understand that, right? The sum of scores was not given, and so you could not find the average.
Yeah.
All right. So, Aliyah, if that's the case, what would you need to find the average?
Um,
It's real easy. You
the
just
sum.
get the sum, right? The sum of the scores. Right. So that's what you need. You would need the sum of scores. And watch thing. What I
They
give you?
give it to you in the next pattern.
Yes, yes. Watch. In part in that part over there. I'm not sure what that is. That is right. So that'll be 4, 5, 6, 7, part 7. Um Javon, you see an antics. Watch. We could not find the mean because we didn't have the score. And obviously in the last part, they tell you what the score is and the sum is. So the sum of the scores is 354, and the sum of the squares of the scores is 4,994. Calculate the standard deviation. Now, this is somewhere, this is real tricky if you don't know this special formula. Let me show you why I'm saying it tricky. Watch this, right? If you didn't know the special formula, you would have to do this. Yeah, Javon, you seeing that?
Yeah. Yeah, I see.
Yeah, you would have to do this unless you know the formula, unless you know this formula, right? Unless you know this formula. So that being said, we still need to remember the general formula for standard deviation. There are two formulas you need to know for standard deviation. And by the way, what is standard deviation? Standard deviation is just It is a number telling you how your data varying from the average. So imagine I had like this example, like 1, 2, 3, 50, 90, 2, 0. All right, Aliyah, if I find the average for this, if I find the average for that, right? And you would agree that the values kind of far from the average.
Yeah.
Yeah, because like look, first we have 1, 2, 3, then bam, we have 50 and 90. You understand?
Yeah.
So the standard deviation tells us how much our values deviate from each other. That's what the standard deviation tells us. So this would have a high standard deviation. This would have a low standard deviation. Javon, you understand? So standard deviation tells you how much your data varying from each other. Like,
Yeah.
right? And with reference to the mean. So the standard deviation tells you how much your data is varying from your mean. That's what the standard deviation tells you. Right? So annually, you understand that this would have a kind of high standard deviation because if you find the average for that, one would be kind of far from the average, right?
Yeah.
Over here, though, if you find the average for this, 1, 2, 3, 4, 5, 6, 7 wouldn't be that far from the average. So this would have a low standard deviation. They could ask all the questions like that. All right. So, Aliyah, what's the original standard deviation formula? The one that you're supposed to know. Is the square root of the sum of
The sum of
minus
x bar
squared all over.
all over n.
Right. Now, guys, let's look at the information they gave us in the question, right? So, Aliyah, they given us what?
They given you the sum of the 30 scores
So
for
that's
the class.
so that's the sum of what?
The sum of n or x.
They given us the sum of x, right? Sum of x, right? So the sum of x is 354.
Mm-hmm.
What else they given us?
The sum of the squares
The sum
of
of
the scores.
squares of the scores. So that'll be what? What notation I would write that in? If the scores is x, or would,
X squared.
right? So they're giving us the sum of x squared, 4,994.
Mm-hmm.
Let me ask a little question. Look at the information they gave us. Let's look and see. Did they give us the sum of x squared? Yes or no?
Of x squared.
The sum of x.
Yeah.
Yeah. Did they give us n? Do we know what n is?
Yeah.
Right? And x bar squared. Could we find the average from this information?
Mm-hmm.
Right. We cannot use this formula, guys. You use this formula when you have raw data. You don't know the raw data from a box on whisker. So you cannot use this formula. So make a little note about that. Anytime you see a box on whisker or you're seeing data that is not raw, you have to use this formula. This formula, right, guys? It's not given any formula sheet. You need to remember it. Right. So, Aliyah, if I wanted to find the average, that's just going to be the sum, x bar going to be equal to the sum of x, which is 354, all over n, which is 30. So the sum of x all over n, so that's going to be equal to 354 over 30. What is 354 over 30?
That's 11.8.
11.8?
Yeah.
Okay, cool. So I have x bar. Do I have everything I need to plug it into this formula?
Yeah.
Yeah. So that would be equal to the square root. The sum of x squared is 4,994. N is equal to 30. And x bar is 11.8. So x bar squared would be 11.8 squared. So plug it into the calculator and let me know what you get for the standard deviation. So Javon, here I was saying, right? If you are given a box and whisker or data that is already grouped and you don't have all of the data, here I was saying, anytime you don't have all of the data, you have to use this formula for standard deviation, right?
Yes, sir.
What do you really know about this formula? but you still need to know about the formula. I sure you never see that formula in school.
Nah.
But you should know it. You should.
Mm, yeah.
For the standard deviation, I get 5.21.
Okay, 5.21, cool. Nice. Right? And only here was saying, right? Anytime you are given a box and whisker, you have to use this standard deviation. Unless you want to do this. I don't think you want to do this to derive it. Right? Okay. All right, so let's keep moving on. So remember again, you have two formulas for standard deviation. You have this one and you have this one. Just keep that in mind. All right, I'm gonna move on now. So Annalie, help me with 2019 really, really fast. So in 2019, we have a what? What's this? What's this called?
Stem and leaf diagram.
Not just a stem and leaf diagram, a back-to-back stem and leaf diagram, right? Right?
Yeah.
So state the number of students in the class. Wow, we're getting a mark for counting. Right? So Annalie, count. Let me count the amount of people. So let me count the girls first. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have 14 girls. Let me count the number of boys. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So if you add 15 and 14, what are you going to get?
29.
Right, so this is the number is 29. Construct one box and whisker plot for the entire grade 5 class, boys and girls combined. All right. So remind me, if we want to do a box and whisker, what we had to know?
Q1, Q2, and Q3.
Right. Well, this question might take a little while. Okay. So you need to combine everything. You need to combine everything to figure out Q1, Q2, and Q3. All right. So let me think what's the best approach for this, because it's not going to be easy. It's going to take quite a while. What I would do is I would do a stem and leaf diagram containing both boys and girls, and I would use that to figure out the box and whisker. So let me do that. So annually, we're going to combine boys and girls, right? Yeah? No? Let me know if you understand what we're going to do.
Yeah.
All right. So that's going to be 2, 3, 4, 5. 2, 3, 4, 5. Right. So I'm combining boys and girls, right? So don't get confused, right? By the way, in a stem and leaf diagram, especially in a back-to-back stem and leaf diagram, you need to know you should be able to read it, right? So this over here consists of the tens. Imagine if you had a number like 85. Javon, how much tens would it take to make 85? How much tens?
6.5,
8 tens, and how much ones?
5 ones.
So you would write 8, 5, and that's how a stem and leaf diagram is work. All right. So Annalie, I want you to take your time and tell me. So I'm gonna start you off, right? So 2 girls got 28, and 1 boy got 28. One boy got 29, and 1 girl got 29. So you understand what I did there?
Yeah.
Right. So tell me for 3 now.
2, 2, 3, 3. 5, 7, 8, 8, 8, 9, 9, 9.
I'm surprised I didn't break up this question into parts. That make more sense. All right. Javon, do 4 with me. So tell me what's gonna be in 4.
0, 0, 0, 1, 1, 1, 1. 1, 1,
right?
2, and 5.
Right, Aliyah, tell me what's gonna be in 5. Aliyah, I get the easiest one. Aliyah, 5. We're gonna have in 5.
1.
Yeah, 1. Now this is supposed to add up back to what? Remind me. What's the total number of students?
29.
29, right? So let's count it real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Guys, we did a good job. Getting back 29. Right. So, Annalie, do you remember how we find Q1, Q2, and Q3?
Yeah.
All right, so to find for Q1, we're going to use this formula. We're going to use a quarter, n plus 1, to find the location of the answer. So what is n in this case?
I don't use the formula. I never used it before.
You never used the formula before?
No.
You just manually do it?
Yeah.
That's crazy. Wow. So like you would cancel off on either side until you get a median, and then you would put,
No, I was like, fine, put like 1 and then 20, 28 and 29 in the middle, and then find the 15th score or whatever in the middle.
oh, okay. Well, you're using the formula, just not explicitly. You see what I mean? So to find for Q1, it's gonna be 30 plus 1. I mean, what's saying 30 plus 1? It's 29 plus 1, which is 30. So where's a quarter of 30? Tell me, where's a quarter of 30?
7.5.
7.5, right? If it's 7.5, by the way, this formula tells you the location. What is in between 7.5? Like, no, what's saying? 7.5 is in between what?
7 and 8.
The seventh value and the eighth value. Aliyah, help me find for Q2. Q2 would be equal to what, Aliyah?
Q2 could be equal to a half of n plus 1.
Right, so that'll be a half of the t. Where's half of the t?
15.
Right, so that'll be the 15th term. Right, Q3. Javon, help me find for Q3. How do I find the term for Q3? Do you know?
3/4 of 30.
3/4 of 30 is.
Um, 22.5.
So man, so it'll be between what two values? What two values? The what and the
22 and 23. The 22nd and 23rd value.
right. So Annalie, let me look at the 7th and 8th value. So you see how we number it? That making our lives really, really simple. So this is the 7th and this is the 8th. So the 7th value was 32 and the 8th value was 33. So we have to find the what between those two numbers. Tell me, Annalie. So my 7th term is 32 and my
The average.
I find the average, right? So the average of 32 and 33. So Q1 would be equal to 32 plus 33 divided by 2. What do you get? You're supposed to get 32.5.
Yeah.
Right. Aliyah, help me find the Q2. Q2 is the 15th term. What is the 15th term?
39.
39, right? That one was simple. Aliyah, I find like I'm giving you the simple questions. Why?
Because it's meant to be.
What?
Yeah. Keep it like that now.
Maybe the exam won't come easy.
Don't jinx it. Please.
All right. I mean, last year exam was kind of stupid. So maybe
Yeah.
exam might be a little better because people
They
complete.
might ease you up.
Yeah. All right. And Javon, help me with this one. The 22nd and 22. What's my 22nd? What is the 22nd value? And what is my 23rd value?
1 and 41 and 41.
So what is the average between 41 and 41?
41.
Yeah. All right. So do we have all the information we are required we need to do the box and whisker? Let me know. Yes, no, maybe.
Yeah.
Yeah, Javon, yeah, no.
Yes, sir.
All right, cool. So to do a box and whisker, you need Q1, Q2, Q3, and you need the lowest observation and the highest observation. Somebody fast, tell me, what is the lowest observation? What is the lowest observation?
28.
Right? So the lowest is equal to 28, and the highest is
51.
right. So our box and whisker is gonna look like this. So I'm gonna draw a box. Let me do a little scale first. I'm gonna do a quick scale. So our lowest is 28, so that means I should go down to 20. I could say that is 20, 30, 40, 50. Nah, that'll be our scale will be I think I have a better scale on it. 1, 2, 3, 4, 5, 6. All right, let me go. So Javon, according to the scale here, every one block is what? So between 20 and 30 is how much is what? Is what? What is 20 to 30?
10.
Right? And how much blocks do you have in the middle?
5.
So every one block will be
2 units.
2 units, right? Nice. So 21, no, the lowest score is 28, right? So 28 could be here, right? Yeah, no, maybe. Tell me.
Yeah, like right before the 30.
Right. Cool. So that's gonna be okay. So let me just put a little mark in there. Um, Alia, what is Q1? Q1 is what?
Q1 is 32.5.
According to the scale, every one big block here, well, small, is 2, right? So 32.5 will be 32.5. 30. So this will be 32, right? You understand? This will be 32.
Yeah.
And 0.5 might be like somewhere here. All right. Um, Annalie, Q2 is 39. 39 will be where?
Right before 40.
Like in the middle, right? Because this could be 38 and this could be 40. So in the middle, right? Yes, no, you understand?
Yeah.
All right. And 41 is Q3. Well, Q3 is 41. So that'll be over here. And the highest is 51. So 51 would be right here. So let me do the box and whisker real quick. If I lose any, Ollie, tell me, you know. Ollie, you understand everything I'm doing so far?
Yeah.
Right? And that's how you do the box and whisker. Is everybody feeling 100 with this?
Yeah.
Yeah? Nice. Javon, you understand everything I did to get the box and whisker?
Yes, sir. But I have a question for if they ask to plot the box on the sky, you need to use the scale. But if they ask to sketch a scale not necessary.
Yeah, scale not necessary, right? If they ask for a sketch, you just need to show them, like, okay, so if they ask you for a sketch, right? This is what you're gonna do, fast, fast. You're gonna say that this 28. You're gonna say that this is 32.5. You're gonna say that this is 39. You're gonna say that this is 41. And you're gonna say that this is 58. Understand? Let me know if
Yeah, yeah.
All right, so if they ask for a sketch, this is what you're gonna do. If they give you a graph, if they give you a graph paper, you need to do a proper scale like that. Awesome. So we have the box and whisker done. Let's look at standard deviation now. So Aliyah, help me here. Let me move a little faster because it's 140, right? And we have a bit of probability questions to do, right? So Aliyah, the standard deviation of the weights of the boy is 5.53. Determine the standard deviation of the weight of the girls and provide an interpretation of your answer for the girls compared to that for the boys. So Aliyah, in this particular question, was the raw data given? Do you have all the data?
Yeah.
When I say raw data, guys, this is what I mean. Do I know the individual scores of the, do I know the individual, it was weight. Do you know the individual weights of the girls?
Yeah.
Right, so that's what I mean by raw data. So anytime
Okay.
it's raw data, automatically you're going to use the other standard deviation formula, right? The one with the square
Mm-hmm.
root of x, the sum of x minus x bar, right? Squared over n, and use that one. Yeah, no, you're good.
Yeah.
So let's do that really fast. Okay, okay. Right. So x is the score. I mean, in this case, is the weight, right? So x would be 28, 28, 29, 32, 32, 33, 35, 38. Um, wait, boy, there was wicked this year, boy. Real wicked. Wait, it's real wicked. How to go on a new page? Damn, bro. Yeah, this is really a good question, yes? Right. So Aliyah, so Giovanni, you understand what I'm saying, right? Since you could get the individual weights, you have to use the other standard deviation formula. The one with the sum of x minus x bar squared over n.
Yeah.
Right? So Aliyah, 28, 28, 29, 32, 32, 35, 38, 38, 38, then 40, 41, 41, 42. So Aliyah, let me know if you understand that. Right? And Aliyah, how could we find the average? We're dealing with the gills now. How would I find the average of the gills?
Yeah, add them up.
Add up all the weights. So do that from a real fast. Add up all them
Hmm.
weights. I tell you, this year was ready, bro.
Which year this was?
So 2019.
Oh. Wait,
495. When you add up everything, you're supposed to get 495. And so the average was be 495.
You
Or
sure?
it's for the years alone, eh? Let me just verify it again. 20.
I get 495.
I get 463.
I get 495. Yeah.
Okay, well, I wrong.
Let me, Giovanni, it could be right. Yeah, I get back 495, so yeah, you're wrong. Yeah. All right. So 495 over 15 is what? What is 495 over 15? I mean 14. Supposed to get 35.336. 35.36, right? Cool.
Yeah.
So now I need to find x minus x bar squared. So we're gonna plug that into the calculator one time. So that's gonna be, so x is 28 minus 35.36. You're gonna square that and you'll get 54.17. So 54.17 here, 54.17 here as well, right? Then we're gonna say 29 minus 35.36 squared, and that's gonna be 40.45. Right, so Aliyah, tell me what 32 will be. I want to make sure I'm doing the correct thing.
Would it be 29? No, it could be
So we're doing it one time.
32.
Finding x minus x bar one time. So that'll be
Okay,
to open.
32 minus, no, 35
Oh no,
point
32. It's 32 minus is x
32
minus x,
minus 35.36
right? Squared one time.
squared. Or like that, you have to do it.
Yeah.
Well,
Or you could do it separately, but I find that's taking way too much time. Like honestly, like are you going to find x minus x bar and then you're gonna find another column and square it? No, just do it one
yeah,
time, right? So for 33, you're supposed to get 11.29. Tell me what you're looking for 33. So I can make sure you're doing the correct thing.
okay.
And move
You'll
it
get 5.57.
5.57. Cool. That's correct. Javon, do 35 so I can know that you're doing the correct thing.
I get 0.13.
Yeah, you're doing the correct thing. So I trust in that everybody do the correct thing. So I'm just gonna speed through the answers fast, right? For today it should be 6.97. 6.97. 6.97. Annalie, you get anything with 40? Annalie, you know what we're doing?
Yeah. I get 21.53.
Yeah, I got that as well. Nice. So now we have to add up all of these scores because remember, which standard deviation formula are we using? Since we have the raw data, we are using the one that says the square root of the sum of x minus x bar squared over n. We're using that formula. So I need to find the sum of x minus x bar, right? So I want somebody to add up all of this and tell me what the sum of x minus x bar squared is.
See, after this yet are any more questions like this come?
No, but it could come this year.
Yeah.
You could agree that this is not hard, eh? It's just tedious. Like it's just very tedious, right?
Yeah, it's good take me probably about a good 20, 15 minutes, something.
Yeah, yeah. But this year, a lot of the marks had a lot. I feel like in that year, it had very little bit of statistics questions. This was the main statistic question, obviously, because it's real long. It didn't really have any other statistics question. So I guess it worked out, right? Because in other years, it would have multiple parts. But in this year, it just had this one. So, right? So as soon as somebody tell me where you get for that, you will let me know.
327.22.
All right. And so to find the standard deviation, that's going to be the square root of 327.22 divided by n, and the number of gills here is 14. So plug that into the calculator and let me know what you get.
.83.
Right, 4.83. So remember what I said standard deviation means, right? It tells you the spread of the data with reference to the average. So which standard deviation looks like it is less? The girls or the boys?
The girls.
So what that means is the weights of the girls is less spread out than the weight of the boys. Make sense?
Yeah.
Because the standard deviation tells you how the data is spread out with reference to the average. So that means that the boys, their weights had more variance, right? So let's write that down. So that's what it means. Since the standard deviation for the girls was lower, it suggests that the weights of the girls are less spread out and vary less than the boys. Nice, that's it. That's what standard deviation means. All right. Determine the number of students above the 20th percentile for this class. Let me show you how we're going to find this. So, Aliyah, are you there?
Yeah.
Aliyah, if I wanted to find Q1, Q2, and Q3, and for Q1, I would find a quarter, and
Yeah.
this would be what percentile?
Yeah. 24.
25th, right?
Yeah. Yeah. Yeah.
I said that'll be 25%. So let me ask you a
Uh-huh.
question, right? If we wanted to find the 20th percentile, it's the same thing. It's very, very similar. So the 20th percentile, Aliyah, you're snorting drugs.
No, I was inhaling.
Oh, I watch it, you know. So to find the 20th percentile, that's going to be equal to 20 over 100 by n plus 1. So 20 over 100 by 30. And what is 20 over 100 by 30?
You got 6.
16, right?
We got 6.
Oh no, 6. Wait, hell, I guess.
Yeah, I say 6.
Okay, good. Good. So the 20th percentile would be the sixth person. So what did the sixth person gets?
32.
32. So they asked us Determine the number of students above the 20th percentile for this class. So
So
above,
above 35, 32, sorry.
yeah, so that will be, so we would just subtract 6 from 22, right? I mean, oh, it's 29 was total, right?
Yeah,
Yeah, so you just minus 6 from 29 and you get your answer,
23.
right? Because the 16th person, I'm not saying 16, the
This
sixth
is
person,
6.
person would represent the 20th percentile. And so we're looking to see the students pass. But Aliyah, I want to bring something to your attention. The sixth person got 32. Didn't the seventh person also get 32?
Yeah.
So like, wouldn't wouldn't this person technically still be part of the 20th percentile?
Yeah, because it's the same.
Same number.
It's the same. Yeah.
Yeah. So that being said, the answer is actually 7 minus 29, which is 22. Annalie, you understand what I'm saying? So we found that the 20th percentile will be the sixth person, and the sixth person got 32, but the seventh person also got 32. So shouldn't they also be in the 20th percentile?
Yeah.
Yeah, right? So we're really looking at this to this. And so Javon, tell me if you're confused by that.
No, sir, I understand.
Right. So yeah, this one was tricky. Now the sixth person got I think they got 32. That's true? Yeah, yeah, yeah. So the sixth person got 32, and the seventh person also got 32. Therefore, 29 minus 7 is equal to 22. So 22 students got above 20th percentile, which was 32. So is everybody okay with this? Yeah, no?
Yeah.
Okay, wait. Right. This is the last statistics question and the probability from here. So Aliyah, give us a real fast read. Actually, no, Aliyah, you helped my previous question. Um, Javon, help me with this question fast.
The heights of 35 children at a nursery are recorded in nearest centimeter. The data is shown below. Display the data in a stem and leaf diagram.
All right, so let me do that. So in a stem and leaf diagram, it's always in um ascending order. It's always in ascending order, right? Always. So Javon, we need to figure out these stems, right? And I feel like this is a place where you might get confused. So if I have 100, tell me, Javon, how much tens would I need to make 100?
10,
10, right? If I had 109, how much tens I would need to make 100? Still 10, right?
yeah.
9 1. So keep that in mind. So what's the smallest value here? The
So
small,
you could do like 60, 70, 80, 90, 100.
right.
Yeah.
You're correct, right? But let me see if there are any places where there's like a skip. So we see in 60, 61 seems to be the smallest. I'm also seeing 70. And then I see in you see in the 80s, we see in the 80s,
Yeah.
we see in 81. So we had to include 60, 70, 80. I see in 90. Yeah, we had to include 60, 70, 90, 80, 100. Okay, good. Right, so we're gonna say 6, 7, 8, 9, 100. So what's the smallest value for 60?
61.
1, right? Then after that, it was what?
2. 2 twice.
And for the hundreds, right? It's supposed to be 10, not
Oh
a
my God.
hundred.
Oh my God. You know what, I write 100 here?
Why?
Because I'll going to get 100 tomorrow.
That's so real.
Yeah. I just foreseeing things now. So I feel like Ole would be able to do this question, right? I feel like I don't have to waste my time. I could just show you the solution and we could move on to the median, lower quartile, and upper quartile. Because Javon, if you would know how to do this in the exam, it would just take a little while.
Yeah.
Yeah, so I shouldn't waste my time here,
But
right?
this was one of the only years they bring like where the data wasn't in order. Usually they just bring it in like order, so it'd be way easier.
Yeah, but it didn't. I tell you, last year was real wicked, you know. Last year was real wicked, when I tell you. It's real wicked last year. So let me give away the answer, right? I have the solutions for this. 2024. All right, and don't forget you need to label stem. You need to put stem, you need to put leaf, and you need to put the key, right? You need to put the key. You need to put the key. Need to. Otherwise, you're going to lose marks. I don't want all it to lose marks. All right, so this is the answer you're supposed to get right here. All right, so Javon, how much people we have here? It was how much people? How much children? It was 35, right? So if I want to
Yeah,
so if I want to find a median, that'll be Q2, a half, 36, right? And so the one in the middle would be the 18th term. So what's the 18th term?
84.
It's, if I want to find the lower quartile, that'll be a quarter of 36.
1/4 of 36. 9. um,
What's the ninth term?
75.
Right? And on the upper quartile,
3/4 of 36, which would be 27.
it's right. And the 27th term was
103.
right. Guys, if they ask you to draw a box on whisker, would you all be able to answer it now? Because you know what Q1, Q2, and Q3 is?
Yeah.
Yeah? Okay. If they ask you to find interquartile range, you should be able to do that too. Q3 minus Q1. You should be able to find semi-interquartile range as well. All right, cool. So good. This was fairly easy. This was just the longest part though, but this was fairly easy. Right? Javon, read part 3.
At another nearby nursery, the heights of children of the same age were recorded. The median height was 79 centimeters and the intercoastal range was 24 centimeters. Compare the characteristics of the two groups at the two nurseries and describe one distinct observation about the distributions.
Right. So the median height was 79 centimeters for the other nursery. So we're comparing 79 and what? And what was the median for this one?
84.
So we're comparing 79 and 84 as the medians. This is the other, right? This is another. And the interquartile range was 24 centimeters. So you see, we had to find IQR here. So if you wanted to find IQR for that, IQR would be equal to what? For these values, what would IQR be equal to?
3/4 of 79
No, one IQR is Q3
or 3/4 of 80.
Where are you getting three quarter from? IQR is
Ready?
3 minus.
Oh, yeah. I mixed it up.
Right? So that'll be 103 minus 75. What's 103 minus 75?
28.
Right. So where is the IQR bigger? In our nursery or in the other nursery?
In
So in our nursery, it's 28. In the other nursery, in the, in the
our nursery.
so just by looking at these things, it's clear that in so we had to talk about the other nursery. The heights, the height of the children in the other nursery is bigger or small, is so the height, would it be more or less? So the height of the
More
children
or less.
in the other nursery is less because the median was less. I dot E 79 is less than 84. Additionally, the children in the up here and the vary by less. So here I was saying, right? Here I was saying the median for our nursery was 84, and the median for this one is 79. So if you arrange the children from shortest to tallest, in the middle for our nursery is 84, but theirs is 79. So that means the height of the kids in our nursery is on average more. So you would say that the height of the children in the other nursery is less because the median was less, i.e. 79 is less than 84. Additionally, the children in the other nursery appear to be shorter and their heights seem to vary less because the IQR is less. When we talk about range, we talk about the difference between the highest and lowest. So it kind of gives us an idea as to how heights would spread apart. And so, because in our nursery, it was larger, it would suggest that there's more discrepancy between the shortest person and the tallest person. In that other nursery, it's less of a difference, right? It's less of a difference between the shortest person and the tallest person. So is everybody okay with that? Let me know if everybody is okay with that.
Yeah.
Okay, good. So now we're gonna move on to probability. Right. And I strictly doing the hard questions. I doing the hard questions, right? These are only hard questions. So Annalie, let me go. At a school canteen, 80% of the students S purchase chips. My phone, railway, not phone. Right. At a school canteen, 80% of the students S purchase chips. C and 55% purchase chicken. Of the students who purchase chicken, 11% do not purchase chips. Let's try to understand what they mean by that. So 80% of the students purchase chips. So 80% purchase chips. Now, Annalie, do you think of that 80%, everybody buying chips alone?
No.
No, and some people could be buying chicken as well.
Yeah.
Okay, so keep that in mind. So 80% buying chips, and chips is represented by C. 55% purchase chicken. So 55% purchases chicken. And then they're saying of the students who purchase chicken, 11% do not purchase chips. So that 11% would correspond to what alone? So let me say that one more time. They're saying that 11% of those who buy chicken, 11% of chicken do not buy chips. So what does that mean, guys? What does that mean? That's the question, Annalie. So if 55% people purchasing chicken, and they're saying 11% of people who buy chicken do not buy chips. That means that 11% buying what alone?
Chicken.
So that would be 11 here. And if that is the case, what would the intersection be?
55 minus 11, so 44.
So the intersection is 44. And remember, the total amount of people are buying chips is 80%, right? So 80 minus 44 is?
36.
Okay, this one was a hard question. I don't think most people would have figured out this one. Um, if you would not be able to figure this out, let me know. Let me know if you wouldn't have been able to figure that out.
So I wouldn't be able to figure it out.
Well, if something come, you know how to do it now, but it's not easy. It's not easy. Yeah, it's really not. So Javon, read the question one more time and try to understand what happened.
At a school canteen, 80% of the students do not purchase chips and 55% purchase chicken. Of the students who purchase chicken, 11% do not purchase chips. Complete the Venn diagram to illustrate the information.
Right. So you understand that you have 80%, right? 80% purchasing chips. You think, oh, let me ask that question, Javon. When you buying when you buying chips, you buy chips alone or you buy chips with something?
With something.
Right. So out of that 80%, them can't be buying chips alone, right? So that 80% is the people who buying chips alone and people who buying both. Then they're saying 55% purchasing chicken. And then they're saying of the people who purchase chicken, 11% do buy chips. One more time. Of the students who buying chicken, so how much people buying chicken? What percent?
55.
And how much of that not buying chips?
11.
So if 11 of them buying chicken and not buying chips, that percent would be for what alone?
The K, the chicken.
Chicken, right? So you try to understand what happening. 55% people buying chicken, but 11% of that not buying chips. So and that 11% had to be people them that buying chicken alone.
Yeah.
And if that was the case, the other amount would be 44, right? Because 55 minus 11 is 54. It's 44. And that 44% would have been the people who buying what then?
Both.
Both, right? So you understand why I put it in the intersection.
Yeah.
And remember what I tell you, this is chips, right? People wouldn't buy.
Yeah.
We know that the whole circle is 80, right? But if I want to figure out for this portion, I would need to subtract 44 from 80, and that's how I got 36. Is it clear now?
Yeah. I think so.
You think so? You feel like you don't understand anything, so think of
Wait, you get 11% from okay, yeah, I understand.
all right. Aliyah, you'd be able to figure this out in the exam. Be honest with me. Yeah or no?
Probably.
Probably.
Yeah.
You understand it?
Like if I had like spend like at least 10 minutes on it, yeah.
But you understand it. Is there anything you need to re-explain?
Um
Aliyah, how I get
mm,
44? Why I get
with
44?
44, you find you find the they say that 11. No, wait.
Ah,
They say that 80% of the students purchase chips
right.
and 55% purchase chicken.
Mhm.
And of the students who purchase chicken, 11% do not purchase chips.
Right.
So that means that 55% purchase chicken of the 80, right?
No, that's not what I mean.
No?
No. Aliyah, I'll run it back, right? I'll run it back. So 80% of the students purchase chips. So 80% represents this whole circle over here, right? Right? Yeah? No.
Yeah.
Come on. So that whole
80,
circle
right?
there, yeah, that whole circle there is 80, right?
Yeah.
And that would contain people who buy in what and what and what. Come on.
Um,
You could either buy, you could buy chips alone or you could buy chips with,
chicken.
right? So what does the 36 represent?
The 36 is the chicken.
No, C is chips
No,
and
that's
C is chicken.
so the chips?
Right, 36 is what? Chips, chips, chips. Remember, if you buy in chips, right, and you can buy chips alone or you can buy chips with chicken.
Yeah.
So this
Yeah.
is chips alone.
So
And this 44 is people who buy in
chicken
chicken. No, that is people who buy in chicken and chips.
and chips.
Yeah. Let me run that back one more time. So 80% of the students purchasing chips. So 80% is this whole thing over here, right?
Right.
This over here would be people who buy in chips alone. And this would be people that are buying chips and chicken. But let me read the question out and understand what happening. So so they're saying what percentage buying chicken?
55,
What are they saying here?
11. Of the students who purchase chicken, 11% does not purchase chips.
So of what? Of what? What is the percentage of people that buy chicken?
Of 55%,
Okay, so 11% out of the 55 not purchasing chips. So what I'm buying?
they're buying chicken alone.
Right, so that's why I put 11 over here.
Yeah.
The chicken alone.
Yeah.
And remember, the whole of chicken was what?
55,
Right, so if this is 11, then this would be
44.
right. And this whole thing here, this whole thing was 80.
Could
And
be 80. Yeah.
this is 44. Then this score had to be 36.
Yeah.
Right. I feel like you understand it.
Yeah.
Right? Read part two for me. Okay, I'll read it. Determine the probability that a student chosen at random purchases only chicken or chips. I'm not sorry. Only chicken or only chips. So anytime you see the word or in probability, are you adding or multiplying?
Adding.
Adding, right? And means multiply. So the probability of only chicken or only chips that would be equal to the probability of only chicken plus probability of only chips. So Alia, what's the probability of only chips?
Only chips.
Yeah, they already give it as a percentage.
The
What's it? Tell me owning chicken first. What's the probability of owning chicken first? What percentage?
11.
11. So that'll be 11 over 100. Right? You know why I get 11 over 100?
Yeah, because it's out of 100. Probably.
Because it's percentage.
Because it's percent, yeah.
But where's only chips?
Only chips is
You've got this.
the
So this over here is chicken. This over here is how much?
44
What does 44 mean?
chips and chicken.
Right? So what this could be?
So 36. That's the chips.
So that'll be 47 over 100. If you can't simplify it, leave it like that. Or you can write it as a decimal. Or you can write it as 0.47.
Yeah.
Right. Now we figure out this one now, Aliyah.
Oh, okay.
Time has come. The probability of the occurrence of two events A and B are given by probability of A is equal to a quarter, probability of B is equal to 3/5, and the probability of A union B is equal to 7 over 10. Determine probability of A intersect B and probability of A happening granted that B already occurred. Cool. So Aliyah, for part one, right? This is a tricky one. This is a tricky one. Look how you're gonna do it. Anytime they give you information like this, it screams mutually, non-mutually exclusive events. If you have non-mutually exclusive events, A union B will be equal to what? The probability of what? Here we're saying non-mutually exclusive events.
That could be
We need
union.
So I will help you out. It's the probability of
Probability of A,
plus D
probability of B,
minus D.
probability of A, U.
Think about it, Aliyah. Think about it. Remember, if you have an intersection, it come like you're saying something twice. And so if you want
So A, B,
to A what?
A, B,
A what? What would I write to represent the intersection?
the
Sec B.
yeah, that, yeah.
Remember, if I do this quick example here, Aliyah, let me just say have a bio club. You in it, so Aliyah, you in it, Javon in it, Annalie in it, Kira in it, and let me just say have a physics club, right? I in it, you in it, Javon in it. So if I ask you is bio intersect physics, what you tell me? How much people in,
2,
right? So you in that and Javon in that, right?
yeah.
But let me ask that question. If I ask you, where's the number? If I ask you where's the number in P union B, would you tell me 7?
No,
No, because why are you gonna count Javon twice?
yeah.
Why are you gonna count you twice?
Mm-hmm.
So I would say 7 minus the intersection. What's the intersection?
2.
Right. So that's why we're saying add this one, and minus it from the intersection.
Oh, okay.
Right? Because watch, you'll see that if we count it, as if we count one person once, it's gonna be 1, 2, 3, 4, 5. And if I take 7, which is both of them, I add both of them, and I minus it from the intersection, which is 2, what do I get?
5.
Right. So if I forget, just keep in mind, A union B is A plus B minus the intersection to get rid of the overlapping amount. That is non-mutually exclusive events formula. Right? But Aliyah, we want to find for A intersect B. So we had to make A intersect B the subject of the formula. Right? So we're going to make A intersect B the subject. So you want to make this the subject. Right? You want to plug in everything and then rearrange it, or what you want to do? You want to rearrange it now, or plug in everything and then rearrange it?
Rearrange it now.
Okay. So that's what I would do, right? I would move across this on the other side. And if I do, it will become what?
It could be P union A plus P intersecting.
Right. And I want to make this the subject. So what will belong here?
You minus P union A, P A union B on both sides.
Right. And so I would end up with the probability of A intersect B is equal to the probability of A plus the probability of B minus the probability of A union B. Right? So do I have all of those values? What's the probability of A?
Probability of A is a quarter.
Right? What's the probability of B?
3/5.
Probability of A intersect B? I mean A union B?
That is 7/10.
Right? Plug that into the calculator and somehow you get some.
You get 3/20.
Right? 3/20. Yeah, that's correct. Javon, if you feel like you're confused, tell me now, eh? No. This over
No,
here,
sorry, sir.
okay, this over here, this is the formula for non-mutually exclusive events. And non-mutually exclusive events basically are events that can happen at the same time, meaning they have an intersection. Right. Let's do part two now. Aliyah, this is conditional probability. Do you remember the formula for conditional probability? What is the probability of A happening granted that B already occurred? Probability of what over what?
Um,
We did this one.
Probability of A
A what?
intersecting B.
Right. All over the probability of
A.
B.
Oh,
Watch. It's easy to remember, you know. You're just taking this, put it back here, by intersect sign, and whatever I have here, put it here.
okay.
Do we have all the information we need to find for that?
Yeah.
Yeah. So the probability of A intersect B is,
3/20.
right? And the probability of B is
3/5.
3/5, right?
You got a quarter.
Right, a quarter is correct. Right, and this over here, this is conditional probability. Yes, no, everybody okay with that? No. Javon, you need to remember that formula, eh? Conditional probability is a must. A must.
Excuse me, I could just see the formula again, please. I could go it over, please.
This formula,
Um,
or the
I
formula,
did drawing back, so I never see everything. Yeah, let me just see that, please.
you're talking about the non-mutually exclusive events formula. This one, I think you tell me what's good for this one. Yeah, no. That one or
Yes, sir. That one, sir.
this one self?
Yeah.
Okay. So anytime they give you a union and basically anytime you're seeing this information here, you should automatically think non-mutually exclusive events. So for non-mutually exclusive events, if you want to figure out A union B, it's the probability of A plus the probability of B, and you'll have to take away it from the intersection. So this is the formula you need to remember for non-mutually exclusive events. You want to explain how I found the answer?
Yes, sir.
Okay, so what are we to find for? Probability of A. A what? What is this symbol? What does this symbol mean? Yeah, no. You know what that symbol mean?
That is intersecting, right?
Right. And this symbol here is union, right?
Yes, sir.
So I want to find for A intersect B, but notice A intersect B is over here. So I need to make A intersect B the subject of the formula. To do that, I will take it and move it across to the left-hand side. It now becomes A union B plus probability of A intersect B. Right? You with me?
Yes, sir.
Now, if I want to find for A intersect B, this should not be here. So that should be on the left-hand side as A intersect B. So I move across A union B, and I now get A intersect B is A, B minus probability of A union B. And in the question, they gave you probability of A, they gave you probability of B, and they gave you the probability of A union B. So I just plugged in the values and I got my answer 3/20.
All right, sir. Thanks.
No problem. But I just write down the formula here again, right? And anytime
Mm-hmm.
you figure out the union of two events, it's the probability of event A plus the probability of event B minus the probability of A intersect B. Sometimes you will have to make one of these the subject of the formula. Right? So that's for non-mutually exclusive events. For conditional probability, the formula is what is the probability of A happening granted that B has already occurred? And it's A intersect B all over the probability of B. Let me get a different example. What if it was J K? That would be the probability of J intersect K all over the probability of K. Cool. And Javon, they told you what they wanted, right? They wanted probability of A granted that B already happened. And the formula for this is A intersect B over B. And we know what the probability of A intersect B is. We found that previously. That's 3/20. And the probability of B, they said it was 3/5. So you plug in this into your calculator, and a way to confirm that again a quarter.
Let me see.
Yeah, you. I want you to confirm that you get I want you to confirm that again a quarter.
Yeah.
All right? Nice. Annalie, I'm gonna ask for help with part C now. Read part C for me.
State with a reason whether events A and B are independent.
Now, if we have independent events, it's wait, if we have independent events, this is the formula. A intersect B would be equal to probability of A. And what does intersect mean? Add or multiply?
Add.
No, intersect means multiply. And so the probability of A was a quarter, and the probability of B was 3/5. What is a quarter by 3/5?
3/20.
3/20. Was that the same result I got earlier when I used the non-mutually exclusive event formula?
Yeah.
And hence the events are independent. Let me explain something. I'm gonna just give a quick crash course on probability again, right? Typically, when you see this means union, and it also means or. It means or, and or means to add. When you see this means intersect, and intersect means and means to multiply. Remind me, what's the formula for non-mutually exclusive events? I guess we now recap. Somebody tell me, what's the formula for non-mutually exclusive events?
P of A union B is equal to P of A plus P of B minus P of A intersect B.
Right? If we have independent events, what's the formula for that? That would mean that the probability of A intersect B is equal to the probability of,
P of A plus multiplied by P of B.
right? And another formula I need to know is conditional probability. So what would happen if something happened? Conditional. And this is given by what is the probability of A happening slash, and the slash means granted that B happened, and that would be equal to A intersect B all over the probability of B. Yeah, so just take a screenshot of this. You need to know it when we're moving on. Cool. Let's move on. Right? So we just have 3 more questions, and that is a week. We finished. We would have done the whole syllabus. We've done the whole admin syllabus. Annalie, feeling good about it? Well, you come a little late. You didn't get to see where we do circles and
I
statistics.
was there.
Oh, word. It was real quiet. Yeah. Right? So Annalie, let we do 2024. Aliyah, way to pay attention. I know you just say you understand, but when I question you, it just sound like you do understand. So pay attention so that you do understand. Right? I'm looking at you.
Okay.
Right? So Annalie, I'm gonna read the question to save time, right? A bag contains 6 red marbles and 5 black marbles. During 2 rounds, a marble game, a student is required to randomly draw 1 marble without replacement for each round. Construct a probability tree diagram to represent this information. Okay. So let me show you what's going on here, right, Annalie? So in the first round, well, tell me something. What does the bag contain? What kind of marbles?
Red and black.
Right. So in the first round, what would be the probability of getting a red?
6 out of 11.
Okay. And probability of getting a black?
5 out of 11.
Something all you need to keep in mind. For any given tree diagram, the branches must always add up to 1 because 1 is the maximum probability. Take note of that. If you're not getting 1 when you add up the branches, you're doing something wrong. Right. Right? Tell me what would happen here. So let's just say, so Annalie, let's just say the person does get a red. If they do get a red in the second go, how much red they have to choose from? So in the question, they said that a student is required to randomly draw 1 marble without replacement. So if you pick a marble, if you pick a red marble in the next round, how much red marbles do you have to choose from?
5 out of 10.
Right. Javon, I need to understand that, right? They said that you're drawing a marble without replacement. So if in the first round you get a red marble, what does that mean?
That means the denominator would go down.
And the top would go down as well, right?
But yeah,
What you see what I mean? So this is the first round here, and we're dealing with the second round here. So let me just say you do get a red. So Javon, if you do get a red, then the probability of getting a red again, it decreases, right? So what's the probability of getting a red in the second go now?
5 out of 10.
5 out of 10, right? Since you're losing 1 marble, it drops the sample space, right? And Annalie, what's the probability of getting a blue now in the second try?
5 out of 10.
And not blue, black, right? 5 out of 10. Aliyah, if in the first round I got a black marble, what's the probability of getting a red marble in the second round?
4 out of 10.
Whoa.
Wait, it could be 6 out of 11.
Whoa. No. Aliyah, let me run through the scene one more time, right? So you understand the first round, right? So you could
Yeah.
either have got a red or you could have got a black, right?
Mm-hmm.
In the second rounds, we in this branch, we saying you got a we saying you got a black. You got a black in that one. If you get a black
Right.
in the first round, that means in the next round, you have one less to choose from. So the sample space is gonna drop by one, and the amount of black marbles you could select will decrease by one because you got a black marble over here, right?
Yeah. Yeah.
Did the red sample space decrease?
No.
No. So what is the probability of getting a red in the second try if you got a blue?
6 out of 11.
11. But ain't you got a marble here?
So it could be 10.
Right, because in the first round, this means that you got a black. And so in the next round, since you got a black and you're not replacing it, you have one less
It could
marble.
drop.
They would,
Yeah, okay.
right? Over here now, what would you get for the probability of black?
It would be the 4 over the 10.
Yes. And remember what I said. In any given instance, some of the branches supposed to add up to what?
1.
Right, so 6 over 10 plus 4 over 10 is 1.
Yeah.
5 over 10 plus 5 over 10 is 1. 6 over 11 plus 5 over 11 is 1. So you won that. The branches must add up to 1. Is anybody confused by how I came up with the probability tree diagram? Yes or no?
So you could go over how you get for the probability of the black, how you get the 6 out of 10 and 4 out of 10.
Okay, so Javon, if in the first round you draw a black marble, right? You with me?
Yeah. Yeah.
If you draw a black marble in the first round, wouldn't that mean in the second round you have one less marble to choose from, and that one less marble would be one less black?
Yeah.
I will run that back one more time. If you got a black in the first round, what is 5 going to change to in the second round?
Oh,
Oh, because you're not replacing, right?
yeah.
If that is the case, where's your whole sample space now? Where you had to select from?
10.
10. So if I want to get a black in the second round, it will be 4 over.
4 over 10 multiplied by 5 over 11. Oh, no.
And what would be the probability of getting a red now in the second round?
6 out of 10.
You understand it, right?
Yeah.
So one more time. In the first round, you could either have gotten a red or a black. So in the first round, you had all the marbles. You didn't select any yet. So it will be 6 over 11. And if you got, and this branch means that you would have possibly gotten a red. So if you got a red, then the number of reds would decrease, so 5, and then the sample space would decrease, so 10. Right? The blacks wouldn't have been you the blacks would not have been affected simply because this branch means that you selected a red. So it still have 5 black marbles, 5 over 10. And it's the same concept for over here, but just black. So
Yeah.
you're sure you're good, right?
Yeah.
Right? Let me read part 2. Aliyah, you good, right? Like you mean it.
Yeah, understand everything so far.
Using your answer in B part 1, find the probability that the marbles drawn are all the same color. So let's look at the possible probabilities, right? So find the probability that the marbles drawn are all of the same color. So I want to hear from you all. At the end of this game, how much marbles would you have drawn? Somebody tell me at the end of this game, how much marbles would you have drawn?
2.
You'd have drawn 2, right? And they want us to figure out the probability that you draw the same color. That being said, and you could either get a red and a red or a black and a black. Yeah or no?
Yeah.
All right. So probability of same color, that's going to be equal to the probability of a red and red, or probability of a black and black. Javon, I needed to tell me if you don't understand that. I needed to tell me if you don't understand it.
I understand.
So you understand that you have two rounds. So by the end of round one, you would have drawn one marble. And in the end of round two, you'd have two marbles now. You understand?
Yeah.
So you can either get a red, red, okay? You can either get a red, black, right? You can either get a black, red, or you can get a black, black. Those are the possible cases, right?
Yeah.
And we want to figure out where is the same color. So same color meaning that it will be red and red, or black and black. You sure you understand this?
Yeah.
All right, remind me, what does and stand for?
The intersect.
Right, so I'm gonna write this as R intersect R. Or means what? I don't divide. I don't multiply.
Odd.
Add. And black, this will be black intersect black. So let me show you how we're gonna do this, right? Anytime you're trying to figure out something, and it's one event after the other, you multiply. One event after the other, you multiply. I'll say it again. One event after the other, you multiply. And additionally, Javon, any intersect minus the and means to multiply.
Pardon, what you say?
I said any and intersect means to multiply.
Yeah.
Okay, so watch. For me to figure out red and red, it's gonna be red by red. So it's gonna be 6/11 multiplied by
5/11 plus 5/11 by 4/10.
nah. It's just 6/11 by 5/10. So I guess in geometry run that back one more time.
E I was talking about for the black intersect black.
Okay, well tell me the answer for that.
Well, 5/11 multiplied by 4/10.
Yeah, that's correct. So let me show you how this thing going again, right? Aliyah. If I want to get a red and a red, I would multiply 6/11 by 5/10. If I want to get a black, 5/11 by 4/10. Yes or no?
Yeah.
Yeah. So plug this into the calculator and let me know what all I get to.
I get 5/11.
5/11 is correct. Right. So you okay with that?
Yeah.
I feel like I want to explain that one more time because questions like this will come. Anytime, so they ask you, find the probability that the marbles drawn are all the same color, Aliyah. How much marbles are you going to draw at the end of this activity?
2.
2. You're getting one over here and you're getting one over here.
Yeah.
Over here, again, I red, and I want to get another color. So where's the same color for red?
Red.
Right. So that will be 6/11 by 5/10.
Yeah.
Cool. I want to get, notice it said, drawn are all the same color. Could I just, so like when we're talking about same color, right? And it could be red and red, or it could be black and black.
Yeah.
Remember, and means multiply, and or means add. So if I say
Yeah.
red, it means to multiply 6/11 by 5/10. If I say or, it means to add So I'm going to add red and red to black and black. And to find black and black is 5 over 11 by 4 over 10. Anytime you're doing this, anytime you're doing something like that, you multiply. Right. So Aliyah, let me just say to change up the question. Find the probability. Let me see what I'm going to do here. Find the probability of getting let me see what I'm going to do here. I give it only 5 minutes. Find the probability of getting different colors. Do that for me. Let me see what I'm going to do. Let me see if I understand anything. So I'll again through this question. Yes or no?
I think so.
Yes, sir.
Finally, it looked like we do correct, Yeah, that's correct. Our boy Javon, big up yourself. You understand it? Right? So you understand that different colors would all be like this on this and this on this.
Yeah.
It's nice, nice. There we go. right? Aliyah. Yeah, Aliyah, that's correct. And excellent looking. I like what you do. Nice, man. Cool. That being said, let's move on to part two now. Or we finish part two. I don't know what I'm saying. I don't know what I'm saying. Right? And I have this question repeated here for some weird reason. Oh no, this is a different question. We had a question similar to this, but it's a different question. All right. So Javon, I'm gonna call upon you to help me with this question. Right? Yeah. I'm gonna call you to help me with this question. So Javon, give part C a read for me.
Given two events A and B, P A union B equal to 0.7, probability of A equal to 0.3, and probability of B complement equal to 0.6. Calculate A intersect B.
Right. So what formula do you think we're gonna use for that? Remind me again. What formula you think I'm gonna use? The formula.
Um, Probability of A plus the probability of B minus probability of A union B.
Okay, yeah, you remember. You can remember that formula if you want, but um, well, actually, in the interest of time, I'm gonna use that formula because all you know that comes from the non-mutually exclusive formula, and in a previous question we did rearrange it, and we know how to do it, right? We know how to do it. So tell me, Javon, probability of A intersect B is equal to the probability of A. Tell me if it's correct, right? Plus the probability of B minus the probability of A union B,
Yeah,
right? Now, there's a trick in this question. They're telling us the probability of not B is 0.6. So if the probability of not B is 0.6, what is the probability of B?
0.4.
All here, guys, take note of this. Anytime you see not, the probability is always 1 minus that because all the probabilities have to add up to 1. So if it's not B, is 0.6, then B would be 0.4. Right? So with that in mind, Javon, I could find for everything. So probability of A is 0.3. What's the probability of B?
0.4.
Right? Minus the probability of A union B. Where's A union B?
0.7. I guess 0.
Yeah, you get 0. And anytime you have two events where the intersection is 0, what do I mean? What kind of events is
Um,
Okay, so if non-mutually exclusive events are events that can happen at the same time, so intersection, what do you think? What kind of events you think?
mutually exclusive.
Yes, mutually exclusive. Nice, man. Okay. Right? Did anybody not know that? Anytime you have events that can happen at the same time, it's called mutually exclusive. Yeah, I probably see this on my TikTok. Or like, or if you watch my 2024 Add Math Solution, I did this question. Yeah. Annalie, you go with this?
Yeah,
Aliyah, did you remember that mutually exclusive means it can happen at the same time, so the intersection is 0? Or you forget that?
I think we can log out the meeting.
Oh, shucks. Right. All right. So that's the answer for part 1 and part 2. Right. We just have 2 more questions and we should be okay for the whole exam. Right, Javon? Yeah,
Yeah, the only one.
anyone. If not 1 or 2, I will take a 2. Not a 3 though. A 3 is pushing it, right? A 2 in advance is still impressive. But I'll be doing paper 1 sessions on it too, right? I go let you know the cost for that. It'd probably be 100. I wouldn't charge much money for that. Maybe 100 or something. Um, yeah, we could do a bunch of paper ones. Because the paper 1 is 30% all the mark, which is crazy. Right? So Javon, let me do 2014, right? There are 60 students in the sixth form of a certain school. Mathematics is studied by 27 of them, biology by 20 of them, and 22 students study neither mathematics nor biology. If a student is selected at random, what is the probability that the student is studying both mathematics and biology only? With these types of questions, you need to draw a Venn diagram. So we're going to draw a Venn diagram. Since this question has an intersection, we're going to include that in our diagram. And we're going to call the first one, we could call the first one mathematics, and the second one we call it biology. All right. So Javon, how much people let's have altogether?
60.
All right, so altogether you have 60 students. And they say in mathematics is studied by 27 of them, right? Biology by 20, and 22 study neither. So where should that 22 go?
Outside everything.
Outside everything, right? Cool. So here what, right? We need to figure out the intersection. That's what we need to figure out. Now they're telling us that 27 people study in maths. Now let me ask that question. Out of that 27, and some people could be studying maths and biology,
Yeah.
and out of that 20, and some people could be studying bio and maths.
Yeah.
I'm gonna show you how we're gonna do this, right? Remind me, if I want to figure out, so if I want to figure out M intersect B, use the same formula, just remove the P. That will be M plus B
Yeah.
minus,
M intersect B.
right. And if I make this the subject of the formula, if I make this the subject, what M intersect B will be equal to?
Minus M minus
Wait,
minus M minus B.
remember, Javon, remember we did a formula, we did this formula, had this formula here.
Yeah.
It's the same thing, just remove the P. So it will be M plus B, yeah, minus,
Probability. Well, not probability. M union B.
all right. So let me show you how we're going to do this thing, right? So if 22 students study in neither maths or bio, then how much people study in maths and bio altogether? The total is 60,
38.
right? So that means the people who study in maths and bio is 60 minus 22, which is 38, right? You with me?
Yeah.
Cool. So to find M intersect B, all we're going to do is we're going to add up the 27 and the 20, and we're going to subtract that from 38. So what is 27 plus 20?
47.
Right? 47 minus 38 is?
9.
Right. So that means 9 students study in both maths and bio. And if both students study in maths and bio, how much of the 27 actually study in maths alone?
18.
How much students study in bio alone?
11.
And when you add up everything inside here, what are you supposed to get?
60.
So do that for me. That's the easiest way to verify if you're
Yeah.
correct. 18 plus 9 plus 11 plus 22. Yeah. Gang, we do get back 60. Big up ourselves. Right. Yes, man. So anytime you want to figure out intersection, you're going to add up how much they say had, and you're going to subtract it from the union, and you get answer. Annalie, did you notice? So like we just adding up 27 and 20, and we subtracting it from 60, and you get answer for the intersection. Did you know that? You can do that.
Yeah.
Okay, cool. Javon, you got the 60, right?
Yeah.
So Javon, you feeling like you understand anything?
Yeah.
Okay, word. Um, right. So since we know, so Javon, do we know the amount of people that study in both maths and bio now?
Yeah,
Yeah. So probability of M intersect B would be equal to how much people study in maths and bio?
9.
That'll be 9 over
9/60.
9 over 60. That will simplify to 3 over 20, right?
Yeah.
Right. And if we wanted to figure out bio alone,
11/60.
right? They can't simplify that, so we leave it as is. Nice. Good.
Yeah.
Okay, great. That's it for this question. Easy 5 marks, right?
Yeah.
Semi easy.
Wait, you could go. How you get the M in M union B to B 38?
All right, so Javon, check this, right? Check this fast. How much students do in neither maths or bio?
22.
How much students could be doing maths and bio then?
Or how the 60 minus 38.
60 minus 22.
60 minus 22, I mean, yeah.
So you understand that of these
Yeah,
22 of them not doing anything. So 38 is actually M union B, combining M and B together.
yeah,
So if you understand that, right? Let's
yeah.
let's do the last question, and this is a sample space, right? Which is like one of the last things in the syllabus. So let me go. And it's already 3:06. Wow, we moving with the time. That's good. That's good. So Annalie, help me with question B, right? So I'll allow you to read it.
Two ordinary six-sided dice are thrown together. The random variable S represents the sum of the scores of their faces, landing uppermost. Copy and complete the sample space diagram below.
All right. So let's go. Let's go. So again, two ordinary six-sided dice are thrown together. The random variable S represents sum of the scores. So typically with probability space diagrams, you typically put the operation over here. So since it's add, I'm going to put add over here. So since that's the case, 1 plus 1 is 2. So let me fill out the table, right? So what is going to be? What would this be?
3,
This is
4, 5, 6, 7.
right. I think you get the idea. Yeah, so Javon, is there anything that confusing you with that?
No, sir.
Ah, you good? Okay.
Yeah.
Okay. Let me um let me continue. So in part 2, find the probability where the sum is more than 9. So let me show you how to do this, right? So locate the 9 and you'll get to see where it's more than 9. So this over here is 9. So you're counting everything above 9. So how much people, I mean not people. How much times did you get a score that is more than 9? Count that for me,
6,
right? All right. So for A, it'll be 6, right? And Javon, how would I figure out the total amount of probable possibilities? How am I going to figure out the total amount of possibilities?
Um, you just count the amount of the results have. So that'd be
An easier way to do it. If this is 6 here and 6 here,
36.
bam. And 6 over 36 is
160.
right. And the probability of S is less than or equal to 4. So look at what we're going to do, right? So this one is actually including 4 because it's less than or equal to. And that reminds me, when are they doing rational inequalities? Like, remember the questions where it's like 2 minus x over 3 plus x or whatever the case is less than or equal to 0. When are they doing questions like that? And when they get all the solutions, just make sure you don't put equal to for the solution. Like in this case, when x is equal to minus 3, you wouldn't put minus 3. You would say, don't forget that, because it's undefined at minus 3. Annalie, you didn't forget, all right?
I remember it now.
Javon, don't forget that, right?
Yes, sir.
Right. All right. So, Javon, they want me to figure out where s is less than or equal to 4. So it includes 4. So that's going to be everything here. So how much is that?
6 out of the 36.
And 6 out of 36 is
160 again.
right. Right. Last question now. Let D be the difference between the scores of the faces landing uppermost. The table below gives the probability of each possible value of D. Find the values of A, B, and C. So let me show you how we're going to do this question. So Annalie, what do you think we got to do for this question?
I don't know.
You don't know?
But the amount of times they get 1 over the total.
No, that wouldn't necessarily help us. I'll give you a hint. You need to construct a
I was gonna say probability tree, but I think that wrong.
no, a probability space diagram. Let me show you what I mean by that. So what we're going to do, right? So 1, 2, 3, 4, 5, 6. So Javon, they want us to fill it in, right? So they want us to figure out the probability where the difference is 1, the probability where the difference is 3. So anytime when they see in a question like this with an operation, it's probability space diagram. And what's the operation I'm going to put over here? Tell me, Annalie, what would be the operation I should put over here?
A minus sign,
Right, because it's difference, right? So 1 minus 1 is?
0,
1 minus 2 is?
minus 1,
1 minus 3 is?
minus 2, minus 3.
Wait, let me check something.
Oh,
Oh, it seems that we have to take the absolute value of it. So if that's the case, then the difference between 1 and 2 will be 1. The difference between 1 and 3 will be 2. The difference between 1 and 4 will be 3, like that. Because notice they don't have no negative values in the table. Notice that? Like 0,
yeah,
2, 3, 4, 5. What's the difference between 5 and 1?
4,
6 and 1,
5,
right? And we just keep going. 1 and 2,
0,
now 1.
1,
2 and 2,
0,
2 and 3,
1,
2 and 4,
2,
2 and 5,
3,
2 and 6.
4.
Right. 3 and 1 is 2. 3 and 2 is 1. 3 and 3 is 0. 3 and 4 is 1. 3 and 5 is 2. 3 and 6 is 3. 4 and 1 is 3. That'll be 4, 2, 1, 0, 1, 2. This could be 4, 3, 2, 1, 0, and this could be 1. This could be 5, 4, 5, 4, 3, 2, 1, 0. Let me know if you understood how I did that.
Yeah.
Right. So do you think it's possible to look at this diagram and figure out all the is it possible to look at all the outcomes here? Could I see
Yes.
yeah, enter seeing all the outcomes here? So for instance, if I roll the dice and I get a 1 and a 1, then the difference could be 0. If I roll a die and I get a 2 and a 1, that'll be a 1. So this represents all the possible cases. So let's observe it now. I think you understand it now. So for instance, they said that the probability of getting 0 is 1 over 6. Let's see if that makes sense. How much times they got 0?
6.
6 over 36s?
1 over 6.
So you see it now. Again, anytime you see an operation, you should probably do a possibility space diagram. You should probably do that. So now that we know that, we could do 1. So let's count the amount of ones we're getting. How much ones is that?
10.
10. Trust in you. So that'll be 10 over 36.
Yeah. Which is 5 over 18.
Right, so that's 10 over 36, and that'll be 5 over 18, like you said. Right. Javon, now we do 3, right? So Javon, how much times are you seeing we are getting a difference of 3?
5
5,
or 6.
6. Right. And probability of getting a difference of 5. Tell me. Probability of getting a difference of 5.
2 out of 36.
Right. And that'll be equal to 1 over 18, right?
Yeah.
Yep. That's it. So all you know how to construct a probability space diagram now?
Yeah.
Yeah.
You just listen all. So like, okay, you have a dice, right? And that dice have 6 sides. It have 1, 2, 3, 4, 5, 6 sides. So you list the amount, you list the numbers per side on either side, on either row and column, and you put the operation here. It was negative, so this could be 0, this could be 0, and so on and so forth. That's how you do a probability space diagram. Yeah. Yeah, guys, this is the chance for you ask me any additional questions. So we like basically done with the syllabus. So, Javon, what was your thoughts about it? How you find the crash course was?
Real good stay. Finish it in 4 days. That's crazy.
Yeah, we finished the whole syllabus in 4 days. Yeah. Anli, how do you find it was?
It was really good. I learned a lot of stuff that I didn't understand before.
It's a shame. I didn't meet you before. Yeah. I wish I could have. All they seem like really nice students. I feel like I would have liked Fallen to be more like full-time students, if you know what I mean. Yeah. Giovanni, you seem like you're very respectful and you do work on thing and you don't give no trouble really. Yeah, you seem like a scholar.
Yeah. Thanks, sir.
You just would you define yourself as a scholar?
Um, Hopefully. Well,
What subjects looking bleak right now? What's your worst subjects?
For me, probably Spanish was looking bad, but I think I might end up with a 201 now, and then well, it's really just bio I had to worry about.
Let me send you some links for bio, don't worry. Let me send you some links for that. Right. So if they don't have any questions, right? If they don't have any questions, we're done with the syllabus. I'd like to take a 40 minutes break. We're gonna come back at 4 and it's real jam, real past papers, real thing. Right? Um if all you go through, if all you go through the book and all you see any questions all you want me to do in particular, you'll send it and I'll do it. Right? Students in my class are gonna send all you a special book. Please don't send it to anybody. I'll look at all you. I'll come and shoot all you. That's not true. I don't mean that, but don't share it with anybody. And I only send it to people in my class.
So you just do lessons for like pure maths.
Yeah, but it's kind of on hold right now because I'm in UE and electrical engineering is kicking my butt. So I really don't have the time. But if you know somebody that needs help, I can help them over the holidays.
No, it's me.
Oh, it's you. Um, I I really love pure maths, you know. I really love pure maths. It's just that the maths, art maths, and physics already taking up so much of my time. If you're serious about it, like you're absolutely serious about it, I could look at fitting you in into a space. But I think that might be one-on-one. Or I could do a general class, but I really need to work out the logistics. Next semester is hell. Yeah. Oh,
Let me pass add maths first and then I'll get to do pure maths.
let me show you the pure maths. This is pure maths. So pretty. And so I remember watch. And are you familiar with trigonometric equations? This is how trigonometric equations is looking pure maths. Yeah. And you have to find a general solution, not for like a range, like a general solution. So like a solution where you can plug in any value for n to get the answer.
So by chance you're doing a marathon for physics?
Yeah, I'm doing a marathon for physics. I have a crash course for physics, but if you, I know some people can't afford it, but so I will be doing a marathon for physics. But if you're interested in the crash course, you can send me a message and I'll give you the information. It's starting, let me tell you the days for the crash course for physics, right? Um,
Oh, I looking at the dates. I'm not sure if I'm gonna be able to come the crash course because that weekend I had a real grind. I had to do the whole of IT and the whole of bio for Monday,
oh,
so I would only be able to come the marathon.
That is no problem. That's no problem. So the marathon is the 19th for 4 a.m. Yeah.
From 7 a.m.
4 p.m.,
Oh,
4 a.m.
all right.
Went right through. Went right through. It really have, I feel like for physics, you know how like it have real good solutions online for like maths and hard maths. It don't really have any physics in it.
The
Just
only person I see was Terry David.
you just have
So
to just have to
yeah.
yeah. All right. Right. So yeah, um, I believe this is something you're interested in. It's so pretty. Yeah, look at it. So this is
Not pretty.
yes, like it's pretty, it's pretty. This one was a hard question. Yeah. So we'll keep in touch, and if you do decide to do pure maths, you'll reach out to me and I'll let you know.
Okay.
Guys, we're gonna take a little break. I'll see you all back at 4, right? At 4 p.m. Yeah. And if I see any questions, send it to me. Mhm. Amy, let me know if you're there. Amy Mongrel. Javon, you there? Look like I want to take a little sleep. It's still have 15 minutes. So yeah, enjoy a little sleep.
Huh?
Yeah.
Good.
So, is that 1,000? What time?
All right, guys, so it's 4 o'clock on the dot. So I hear in trigonometry relation up there. So we're gonna do some trigonometry past paper questions. So in trigonometry, it have sectors, arcs, it have proof questions, you have compound angle, double angle formulas. What exactly in trigonometry is giving you all the most trouble? Drop in the chat. If I say everything, that's crazy, but that's small thing. All right, Amy, let me know if you're there.
Yeah, I hear.
Okay, nice, nice. I know somebody was gonna say everything, I know that proofs. Proofs, okay. Proofs is the hardest thing. I would say everything else is moderately easy. It's just proofs. Just proofs. Proofs is the hardest thing. All right. Right. So guys, are you okay with sectors and arc and thing? Somebody asked, what is proofs? Wait. All right. All right. So we're going to start off with trigonometry and we're going to start with sectors and arcs. By the way, guys, if you have a Casio calculator, drop a 1 in the chat. If you do have a Casio calculator, you're kind of cooked. You're real cooked. You don't have a Casio calculator. Ah. Everybody's saying 1. That's a good thing. That's a really good thing. Um, Akira, sorry about that, boy. God. Kira, that's good. That's good. Somebody want to tell Akira why a sharp is not it for hard maths? Somebody want to tell them why a sharp is not it? Oh. But anyways, let me start. So first of all, what exactly is an arc? And what exactly is a sector? A sector is just piece of a circle. So imagine I draw the circle here. A sector would just be piece of the entire circle. Now in hard maths, we don't use degrees. We use radians. So what exactly is radians? So I'm going to show you how to convert from degrees to radians. And so in any trigs question, unless they don't specify, you're not going to use degrees. You're going to put your calculator in radians and you're going to work with that. So I want somebody to tell me, how much degrees do I have in pi? So pi radians is equal to how much degrees? Let's see. Pi is equal to 180, right? So watch this. If 180 degrees is equal to pi radians, and by the way, you could either write rad or you could write C. Sachin Babulal, I see you writing on the screen. That was a mistake. All right. So if 180 degrees is equal to pi radians, then that would mean 1 degree would be equal to pi over 180. How did I do that? To do that, I divided by 180 on both sides. So 1 degree is equal to pi over 180. So let me just say I had 60 degrees and I wanted to convert 60 degrees to radians. What I would do is I would multiply both sides by 60. And so 60 degrees would be equal to pi over 180 by 60. And that should give you a third pi radians. So that's how we convert from degrees to radians. Take note of that. You'll need to know it. So to convert degrees to radians, you multiply the degrees by pi over 180. That's what you have to do. So keep that in mind. With that being said, Amy, I want you to tell them what next you have to learn. What are the main formulas you need to know when dealing with arcs and sectors? What's the main formulas you need to know? Amy, you're feeling shy or what? Okay, I'm not hearing Amy. Anybody? Okay, Amy, you're unmuted.
Yeah. Is area of a sector,
Right?
which is a half r squared theta.
Right. So let me just neaten up this thing here. So one of the main things you need to know that to go from degrees to radians is pi. You're going to multiply that. So whatever you have in degrees, just multiply it by pi over 180. Right. So the main formulas you need to know, tell them, you were telling everybody.
So area of a sector is a half r squared theta.
Right. And when you're using this formula, your calculator has to be in,
Radians.
it has to be in radians, otherwise pressure. They're going to get the question wrong one time. What's the other main formula you need to know?
Length of arc, which is r by theta.
Right. And for those who don't know, again, a sector is just a piece of a circle, right? A sector is just a piece of a circle, and the angle you use has to be in radians. Now, Amy, on either side, you're going to have the what? You're going to have the what on either side?
Radius.
You're going to have the radius on either side. And what would I call this length over here? Which looking like piece of the circumference. What do we call that?
The arc length.
This is the arc length. Right. So guys, keep that in mind. Keep that in mind. I'm going to find a question and we'll do it. Somebody just joined, your mic is unmuted. Right? So let me jump straight into it. Right. Okay, this is a nice question. Oops. So let me try this question here. So I want you to get a question I read from her. So in 2013, question 4, what does it say? So Amy, you talk already. Is there anybody that have problem with this and you want to do it with me? Now is all a chance. Don't be scared. Now is all a chance. Anybody here don't know how to do trigonometry, like these questions, and would like to do it? Okay, I'm not hearing anybody. Everybody's shy. So Amy, let me do it, right? Oh, Kira, see you raise your hand. Yeah, unmute, and let me go. Right, Kira, if you're talking, I can't hear you.
Hello?
Yeah, Kira. So let me go. So in the question, they're saying we have a sector cut from a circle of center O, and they're giving us the angle O is.
Sorry. Hey, crazy.
Somebody came into the meeting and their mic is right. So Kara, they give you an angle. Is the angle in degrees or in radians?
So, degrees?
No, that's in radians. Anytime you see pi, that's radians. So
Okay.
automatically put your calculator in radians one time. So your angle is pi over 6, and they're saying if the perimeter of the sector is 5 over 6, 12 plus pi, what is its area? Okay, this question might be a little tough to start off with, but we could try anyways. All right. Wait, give me a second. Think so. Tell me diagram. We'll check so. So Kira, they're talking about perimeter, right? Automatically, when we're doing perimeter, we're talking about the distance around the shape, right?
And so,
As area and length of arc. Which one do you think we'll have to use in that question?
so can you repeat, please?
So in that question, we are dealing with perimeter, right? That's distance around. Would we use the area of sector formula or should we use the length of arc formula? Which one?
The length of arc?
Right, because
think-
perimeter, we're dealing with perimeter,
Yeah.
and that's the length around. All right. All right, so remind me, what is the length of arc formula? L is equal to?
I don't know. Don't know.
R theta, right? Okay. So do we know what the radius is? Tell me, do we know what the radius is? Do we know what the radius is? Yes or no?
No, sir.
Now we don't know what the radius is, so I'm going to leave that blank. Do I know what the angle is? What's the angle?
Pi on 6.
So I was like, oh, what time is it? And she's like, 3 o'clock. I said, oh, you want to get
Yeah. Anytime you join, please mute your mic. Right. So this over here is the length of the arc, and that represents this length over here. But they're saying that the perimeter of the sector is that. So, Kira, to get the perimeter, wouldn't if they add up this and this, as well as this, wouldn't they have done that?
Yes, sir.
Right. So we know that L is equal to R by pi over 6. And these two lengths here, they are examples of what are they examples of? Starts with R. If we're going from the center to a point on the circumference, what is that?
The radius.
Right. So this is R and this is R. So the perimeter is R plus the length of the arc. And remind me, what was the length of the arc?
I'm not sure.
We found the length of the arc here. Check it out. L is equal to R theta, right? And so we got R by pi over 6. So we're going to take that and put it over here. So I could write that as pi over 6R. And that is equal to what? What did they say the perimeter of the entire sector was?
5 over 6.
Right.
Open bracket. 12 plus pi.
So I want you to understand what's going on, right? So in they told us that the perimeter of the entire shape is 5 over 6 by 12 plus pi. This is R, and this over here is pi over 6R. So to find the entire perimeter, I would have to add up all of those terms, and we know that the perimeter is 5 over 6, 12 plus pi, so I form my equation. Tell me if you're okay with that.
Yes, sir.
Let me ask that question. Simplify this. Can we simplify that?
Yes, sir. It would be R squared plus pi over 6R.
No. We're adding R over here. When you're adding terms, so how much R is you seeing over here?
2.
That'll be 2R. So you have plus pi over 6. So you have 2R plus pi over 6R. So this is what we're going to do, right? So guys, a lot of you all would probably have a hard time trying to come back to terms. The long way is to find the LCM. But if you have a Casio, this is what you can do, right? So, Kira, do you have a Casio?
Yes, sir.
I want you to put in the Casio 2 plus pi over 6. 2 plus pi over 6. Does it give you the answer in terms of pi? Or does it give you a decimal?
So I get 757 over 300.
Pi?
I don't know why. Yes, sir.
Okay, here what? We go do the full working on the side then. We do the full working on the side. So on the left-hand side, you notice we have an R term over here. We have an R term over here. To combine those. The same way, if you had 5x, think about it. If you had 5x and you had 2x, what is 5x plus 2x? And you would add it?
Yes, sir.
That would be equal to
7x.
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 So since these are both R terms, we need to add it. So do we have the same denominator on the left-hand side? Do we have the same?
No, sir.
No. So we had to find LCM. So if you find the LCM of that, what would it be? What would be the LCM?
6.
It would be 6. 1 into 6 is?
6.
6 by 2R is?
12R.
So we have 12R on top. 6 into 6 is?
1.
1 by pi R is?
1 pi R.
Right, 1 pi R. So you see this expression on the left-hand side, we could actually write that as 12R plus pi R over 6. And that is equal to the right-hand side. The right-hand side is 5 over 6, 12 plus pi. You understand everything I do so far?
Yes, sir.
Well, let me ask that question. Do we like working with fractions?
Yes, sir. I prefer
You like working
adding.
with fractions? The answer I was looking for was no. So
That's okay.
in every time, in every instance, we want to get rid of fractions.
Mhm.
Since we dividing by 6 on both sides, what can we do to get rid of the divide by 6? What can you throw out?
Mm,
What can I do throughout to get rid of the divide by 6?
multiply
I can multiply both sides by
6.
correct. For anybody that is not seeing it, look at this example. I'm going to do the full work in here. If I were to multiply both sides by 6, look at what's going to happen. Wouldn't the 6 and the 6 cancel off? Can you see it?
Yes, sir.
Right, and that's good. So we would end up with 12r plus pi r, and that's going to be equal to 5 by 12 plus pi. So you understood that by multiplying by 6, I got rid of the 6 here and I got rid of the 6 here. So this is what I have now.
Yes, sir.
Okay. So let me ask that question. What is the only unknown we have in this equation? What's the unknown in this equation?
Mm,
Guys, drop in the chat. Is pi a unknown or is pi a number? Is pi a unknown or is pi a number? Pi is a number, right? Pi is a number. So the only unknown we have in this equation is r. Kara, try to understand what I mean. If you plug pi into the calculator, and you're going to get a number.
yes, sir.
Right. So the only unknown in this question is r. Is r.
Oh.
So let's see if we could simplify. On the right-hand side, you have a 5 on the outside, multiplying by 12 plus pi. Is it possible to expand those brackets?
Yes, sir.
If I expand it, I get 60 plus 5 pi, right?
Yes, sir.
Right? And we are trying to find for r. Are you seeing an r to move?
Mm,
Got it?
yeah.
Yeah. So if you're seeing an r to move over here and an r to move over here, that means we factor out the r. So if I factor out the r, what will be left with on the inside?
12 plus pi.
Right. We are nearly there. Don't worry, we're nearly there. So if r is being multiplied by 12 plus pi, what would I have to do to get rid of that and find for r? What would I need to do on both sides to get rid of the 12 plus pi? Let me give you an example. Let me look at a simpler case, right? If we had 5x is equal to 20, what would I have to do on both sides to find for x?
Divide by 5.
Right, because wouldn't 5 cancel off with the 5?
Yes, sir.
So what we had to divide by to cancel off with this entire thing?
By pi. 12 plus pi.
Right. You need to divide by 12 plus pi. So by dividing both sides by 12 plus pi, it would cancel off here. And what's the only thing you'd be left with?
R is equal to 60 plus 5 pi over 12 plus pi.
And is that something you could plug into your calculator?
Yes, sir.
Right. So I want you all to plug that into the calculator and tell me what you're getting for R.
Okay. So I can't find pi on the Casio. I'm not sure where to locate it.
Do you have the same Casio as me? It's the FX991ES Plus.
Yes, sir.
Okay. So pi is to the bottom. You have an answer button. And then I have an x, 10 to the power x. You should see pi in yellow.
Yes, sir.
Okay, so to get it, you're going to press Shift X
Shift.
to the X.
Okay, thank you.
Get through?
Yes, sir.
Okay, nice. Glad to hear you get through. Right? I'm going to show you real quick why you should have a Casio for add maths. Why?
So,
This is why. Let me send a picture of the chat. What did you get for R?
64.45.
Nah. That's not it. So we got a nice answer. Nice answer.
Five.
I got 5. Thank you. Oh, she's got hers. Let's go here. Your name and age, Makira, 29. And Makira, what?
Right? Somebody came in. Let me just send a message on the chat. Right. So you're supposed to get 5 for the radius. Kira, did you get that?
Yes, sir.
Okay. Did they specify what units it was in the question? Did they specify the units? Centimeters, right? They said centimeters. So since they are saying centimeters, you need to put 5 centimeters. Okay. And in the question, they wanted us to find the area. So, Kira, let me think now. Let me think. We have the angle and we have the radius finally. Can we find the area? Tell me, can we find the area?
Yes, sir. I think we could.
I think we could too. Remind me, what is the formula for area of a sector? Yeah, tell me.
So,
Yeah, somebody was talking.
so I'm asking you to repeat.
Say that one more time.
So I'm asking you if you could repeat the question.
Okay, so now that we have R and we have the angle, is it possible to find the area of we're dealing with a sector?
Yes, sir. The formula is half r squared by the angle of theta.
And the angle needs to be in what? Degrees or radians?
Radians.
If it's not in radians, you need to convert it to radians. But thankfully, they gave us pi over 6, which is already in radians. So since A is equal to a half r squared theta, it'll be a half. My radius is 5 now. I found it. And my angle is pi over 6. So you're going to plug this into your calculator and let me know what you guys are getting. Or to the person that did not get 5 centimeters when you plugged it in, did you get 5? Let me know, did you get 5?
No, sir, I didn't get 5.
You have a Casio or a Sharp?
How about Casio, sir?
Okay, I'm going to send a tutorial on how to do it, right? I'm going to send a quick video on how to. I'm going to show you guys how to put your calculator on radians one time.
So for the answer, I got 6.544.
Yes, that's sounding correct. That's sounding correct. Right, so the exact answer, if they asked you for the exact answer, the answer would be A is equal to 25 over 12 pi centimeters squared. In this case, we'll give them the answer to 2 decimal places since it did not specify. Right, so it'll be 6.54 centimeters squared. Right, so check the tutorial on how to plug this in into the calculator and just confirm that you're getting 5. Right, I'm going to show you all how to put your calculator in radians real quick. Right. So check and verify that you're getting 5. All right. So Amy, did you do this question before? Yes or no?
Repeat, sir?
Amy, did you do this question before?
No, I didn't do it before.
It's an interesting question, right?
Yeah.
Yeah, so Amy, in this question, the problem was we did not know what R was, but they did give you the perimeter. And since they gave you the perimeter, we could have come up with an equation in terms of R, equate it to the perimeter, and find for R. And once we have R, we could find for area. You understand how to proceed?
Yeah.
Okay. All right. Guys, is there anybody that would like me to go over this? Tell me fast before I move on to another question real quick.
Question. Oh, you get 25 over 12. I pay it into the calculator and again 10 and 5 over 12.
Sharp or Casio?
A sharp.
Okay, if you have a sharp, you'll need to plug it in parts. So you'll have to put plenty brackets. You'll have to say 1 divided by 2 in brackets. Then you'll need to say 5 squared, close brackets. Then you'll need to say pi divided by 6, close brackets. Since you have a sharp, you will not get 25 over 12 pi. You'll only get the answer as a decimal. But you're supposed to get 6.54. So just verify that again, 6.54. When you do this with the sharp, right? Just verify you're getting 6.54.
Oh, excuse sir. On my calculator, the Casio FX991, when I did the same thing to put in radians, I didn't get that same option. When I press shift and menu setup, it only seen like input, output, angle unit, number, format, and engineer symbol.
What way to do? Angle unit. Go on angle unit.
Angle unit, right?
Angle unit.
Okay, I see it now. Thank you.
No problem. So guys, if you all have a different Casio model than me and you got through, please send a video on the chat to assist others that might not know how to do it. All right, so to the person that was not getting the 6.54, when you plugged it into your sharp, what I told you, did you get the 6.54?
No, sir.
Nah. Pressure, boy. Could you send me a picture of what you're plugging into the shop?
Okay, sir.
All right. Exactly.
Never mind, I got it. Thank you.
Okay, nice. So Jolene, if they tell you to use pi as 22 over 7, you have to use pi as 22 over 7. If they do not specify, you are going to use pi in your calculator, right? If they tell you pi is 3.142, you'll use that. It depends on what the question asks. But in this question, they did not specify, so you're going to use pi as what you have in your calculator, right? So I'm going to take it that we're good, and I'm going to move on to another question that probably is not so hard. Guys, and if you all have any particular years that you don't know how to do and you need me to do it live, just tell me and I'll do it. Right? I'll need somebody to read the chat because when I'm doing these things, I can't see the chat. So I'll need a volunteer to do that. Amy.
So wait, before you move on to the question, right? I feel like I should go over the last part.
This part over here?
Not a little bit before.
Which part?
Like, you're not over the whole thing.
Like how I got 12r plus pi r over 6?
Go up 2 steps from that. I will take it from there.
Okay, so you're confused with how I got this equation?
Yeah.
Okay, so here what we're saying, right? They gave us the perimeter. N perimeter means the length for the whole sector. So that means that you're starting from here and you're walking around. Yeah or no?
Yeah.
The perimeter is just the distance around a shape. So this length is r, that's the radius. This is r, and this is the arc length. We found the arc length using L is equal to r theta. Theta was pi over 6, so the arc length is pi over 6r. So this is pi over 6r. This is r, this is r. So we will add up all of those lengths and put it equal to 5 over 6, 12 plus pi to get the equation. So let me say that one more time. Perimeter is a shape around, is the distance around a shape. So you have this distance over here, you have this distance, and you have this distance. So you'll add it up and you will put it equal to what they gave you. Because in the question, didn't they say the perimeter was 5 over 6, 12 plus pi? Yeah or no?
Yes, sir.
Yeah. And whenever you're doing a question, I would encourage you all to look at the unknowns. In this question, they did not give you the radius. So in your head, you should be thinking, wait, I don't have the radius. I need to find the radius somehow. So how am I going to find the radius? You'll need to make some equation to find the radius. Right. Okay. All right. So that's how we got the equation. We added the distances all around. R plus pi over 6r. Let's do an easier question that should not be that hard. It's funny that the first question I picked was not beginner level. It was more like up there. It wasn't the easiest thing.
See, it wasn't that bad compared to how you explaining it, if I'm being honest, to my teacher.
Still not that bad?
Yeah, it wasn't that bad.
Okay, well, I should get a harder question then. We're gonna do a slightly easier question, right? Slightly easier question. Let me show you how to do this question over here. I'll copy this, paste it in. Right. So, Javon, let me know if you're there. Okay, I'm not hearing from Javon. Aliyah, are you there? Kiara?
Me, sir?
Aliyah, are you there?
Yeah, hello?
Oh, no, not you. Another Aliyah.
Oh, my bad.
Yeah. Aliyah Ramlakan. Call him full names now. Okay, I'm not hearing Aliyah. Okay, the other Aliyah that answered. Do you know how to solve this question?
If I know how to solve this question, yes.
Yes? Well, let's run through it.
Yep. Sure.
So figure 1 shows the sector OAB of a circle with center O, radius 9 centimeters, and angle 0.7 radians. Find the area of the sector OAB. So you all can see that we have a sector again, OAB. They give us the angle here. Guys, drop in the chat. Do we need to convert it or is it already in radians?
It's already in radians.
Right, it literally says radians, right? And Aliyah, if this is 9 centimeters, what do you think this would be? What do you think this length would be?
That's also 9 centimeters because it is also the radius.
Exactly, because it's from O to B. So we had to find the area of the sector OAB. Now, since we have the angle and we have the radius, we could just use the formula straight. So area is equal to?
Area of a sector is equal to half r squared theta.
Right, so we're going to say a half. The radius here is 9, so that will be 9 squared, and theta is 0.7. So you're going to plug this into the calculator. So again, if you have a sharp, you'll need to put 1 divided by 2, close bracket, 9 squared, 0.7. If you have a Casio, you can plug it in exactly like this. So plug it into the calculator and let me know what I get. Drop your answer in the chat. Yeah, seeing some good answers. Hey, Achilles, what's the plan? I know you did real talk for the AdMaths marathon, the maths marathon.
Full 12 hours again, sir.
Yeah, boy, full 12 hours again. So you're supposed to get 28.35, and the units here is centimeters, so it'll be centimeters squared. Right. So, Aliyah, let's do part 2 now. So what are they asking us in part 2?
To find the
The
area
area
of
of the shaded region.
Right. So if we want to figure out the area of the shaded region, you will need to find the area of the triangle, and then you need to subtract the area of the sector. And so you see, this will be the remaining portion. And that's what they want us to find. Now, in odd maths, let me just introduce a little formula. In odd maths, things not so simple. You can't just use a half base by height to find the area of a triangle. Instead, you need to use a half AB sine C. Let me run that back one more time. In odd maths, if you have to find the area of a triangle, you have to use a half AB sine C. So let me explain this in a real simple manner. A half AB sine C. C is the included angle, and A and B are just the lengths of the sides that is right next to the angle. So in this case, this would be an included angle because it's in between two lengths and the angle is in the middle. So automatically, the angle I'm going to plug in is 0.7. And could somebody tell me what A and B would be? What are the lengths?
9 centimeters.
Both of them would be 9, right?
Yes, sir.
Right? So the area of the triangle. So guys, take note of this, right? C is the included angle, right? C. Cool. So the area of the triangle would be equal to a half 9 by 9. And again, why am I saying 9? I'm saying 9 because both of the sides' length is 9 on either side, right? So that'll be 9 by 9. And my angle is 0.7. So I'm going to say 0.7. Now, you will not get the correct answer if your calculator is on degrees. You will need to put your calculator on radians mode. So I want somebody to drop the answer in the chat or unmute and tell me where you're getting.
So I get 26.09.
Yeah, that's correct. 26.09, right? And that'll be obviously centimeters squared, right?
So that'll be the area of the whole triangle or just the area of the arc?
That's the area of the whole triangle. Tell me, is this the formula to find area of an arc? I mean, area of a sector?
No, the reason I'm asking, sir, is because we know that one side there would be 9, but we will know the full length of OC. We know the full length of OB, and OB would be the 9 centimeters.
Okay, yes. Thanks for clearing that up. Yes, you noticed that. All right. So if that is the case, you will need to use trig ratios to figure out for this length over here. So let me just do that real quick. Sorry about that. So I'm going to redraw the triangle. So this is A. This is, all right, this is O. Right, so this is going to be 0.7. Right, O to A was 9. And so if we want to use this formula, we would need to find for this side. So let's label our triangle accordingly. So the guy that corrected me, pick up yourself. I want you to help me here. So this will be the hypotenuse. What side would this
meeting is being recorded.
What side would this?
That would be the adjacent.
And this would be the opposite, right? So I need to find.
Yes,
so I want to find for the hypotenuse, and I have the adjacent. I mean, I have the adjacent, right? So which trig ratio am I going to use? So Katoa. Which one? Which one have A? Cos, right?
Yes. Yeah.
Cos theta is equal to A over H, right? I'm going to say cos 0.7. A would be 9 all over H.
And H is the unknown.
H is the unknown, correct. So we would have to cross multiply. And if you cross multiply, you're going to get H cos 0.7. 1 by 9 is 9. So to find for H, you'd have to divide both sides by cos 0.7. So H is equal to 9 over cos 0.7. So plug that into your calculator and let me know what you're getting for each.
11.76 or 11.77 once you round up.
All right, 11.77 centimeters. So thank you for spotting that. So what he's saying is that we do not know what O to C is. This length over here is for O to B. But to use this formula, you need to know the two lengths that are adjacent to the triangles. And over here, 9 centimeter is not the full length over here. So what you would have to do is you would have to use trig ratios to find H. In this case, H is O to C. So this full distance is 11.77. So if you don't understand that, unmute and tell me or drop a message in the chat. Some of you all might have a hard time rotating the triangle. But let me know if you're seeing that. Somebody say that again.
Ask if I could do over the question.
Okay, no problem. So when we look at this diagram, we're seeing a sector over here. We're seeing a sector, and we are seeing a triangle. You understand that we would need to find the area of the entire triangle and subtract it from the sector to figure out for the missing portion, right? Well, the shaded region. Tell me if you understand that part.
Yeah.
Are you okay with how we got the area of the sector?
Yeah, just now joined, so I just wanted to know where was that.
Okay, no problem. So we found the area of the sector there, right? And so to find the area of the triangle, we recognize that we have to use a half AB sine C. Now in odd maths, you typically have to use that formula, right? Anytime you have to find the area of a triangle, you need to use that formula, where A and B are the sides adjacent to the angle, and C is the included angle. Notice, and to have an angle here, I have a length over here, but I don't know what the length over here is. Can you see that?
Yeah.
That being said, we would need to find the length OC. So to find for OC, I would use Pythagoras. I was saying I would use trig ratios because it's a 90-degree angle triangle. I have an angle and I have a length. Does that make sense? So I'll say it one more time. We need to find for O to C. We recognize that this is a 90-degree angle triangle. We also recognize that we have an angle on the inside that's non-90, and we have a length, we have one length. So the only thing you could really do is use trig ratios to find for O to C. So I redrew the triangle. I found for O to C, so H is O to C, and it was 11.77 centimeters. And so now I could actually use this formula. So, okay?
Okay, thank you.
Not a problem. That being said, since we actually know the length of H, we could actually find the area of the entire triangle. So the area of the triangle would be equal to a half AB. Now, A and B, like I said, they are just the lengths that are right next to the angle. So that would be 9 multiplied by 11.77, and the angle here is 0.7. So that's the final answer. So plug that into your calculator and let me know what the area of the triangle is. You should get to the 4.12. Let me drop a yes in the chat or a 1 if you get into the 4.12. The reason why we're saying centimeters.
So I get 33.91.
Wait, give me a second. The reason why we're saying centimeters squared is because in the question it was centimeters. You got 39 points?
Oh, sorry, sir. I make a stupid mistake. I'll leave out a 0.7 in the 11.77.
Okay. Right? We know what the area of the entire triangle is. And so since we know the area of the sector and we know the area of the entire triangle, I could now figure out the area of the shaded region. So the area of the shaded region is going to be equal to the area of the triangle, which is to the 4 28.12, subtract from 28.35. So plug that into the calculator and you will tell me what you get for the answer. Is anybody getting 5.77?
Yes, sir.
Okay, word. So you will have to be very careful with these types of questions. You see how I make that mistake? I'm blaming it on the glasses. Anybody else who have glasses, I'll give a little ease up. But in these questions, and again, anytime you're dealing with an area question and you have a triangle in add maths, you have to use a half AB sine C. You could also use the formula, a half R squared sine theta. It's the exact same thing. Now, A and B, again, is just the lengths on the either side of the triangle. C is the included angle. If you don't have the length of one side, chances are you would need to do trig ratios to find the length of that missing side before you could find the area of the triangle. I seen somebody get 0.64707. For the people again, 0.64707. Do you all have a sharp? So after this topic, we're going to do calculus. So
So you just go over how you do the cosine theta to get the 11.77.
okay, one moment. I'm seeing, I don't know how you guys got 0.647. I'm not sure how you all got that. Did you all plug this exact same thing in? If you have a Casio, you're supposed to get it. Here what? I was somebody, if you are getting the correct answer, and you can, I would like you to record what you're doing on the Casio and send it on the chat. Because if I am here, I can't really do both at the same time. Okay, Adriel, yes. Gissy and Jaden, did you all have the calculator in degrees? If you have the calculator in degrees, you will not get to the 4.12. Yeah. Right? So somebody asked me to explain how I got 11.77. So in the question, you can recognize that it's a 90 degrees angle triangle. You have an angle on the inside and you have one length. So you can't use Pythagoras theorem because to use Pythagoras theorem, you need at least two sides. But we're seeing an angle and we're seeing a side, so we could use the trig ratios. So I took the triangle and I redraw it real quick. So A, C, O. I know that the right angle is by the A. I know that the angle is by O. And I know that the length is by OA. So you understood how I drew back the triangle. Let me know if you understood that. Yes or no?
Yes.
All right. Now, to figure out what to do in the trig ratios, you're looking at what you have and what you're trying to find. So notice in this question, we want to apply this formula. So we would need to know the sides that are right next to the angle. So we need to find the length O to C. So when we label the triangle, we see that O to C is the hypotenuse. So we're trying to find for the hypotenuse, and we have the adjacent. So if you have the hypotenuse and the adjacent, then you have to use cos, because so, ka, toa. Write that down to the side. So we use cos, the angle is 0.7, and the adjacent is 9. So I would cross multiply, and in doing that, I got h cos 0.7 is equal to 1 by 9 is 9. Right? I want to find for h, so I divide both sides by cos 0.7, and that's how I get my answer. Guys, for whoever getting 0.6 something, make sure the calculator in radians, because the angle is in radians. So the person that wanted me to re-explain the triangle, let me know if you're still lost. This is maths. This is trig ratios.
No, I understand. Thank you.
Not a problem. And so once we find O to C, that means we know the lengths that are adjacent to the angle. So the length here is 9 and the length here is 11.77. So I could say 9 by 11.77 and sine 0.7. Right? Cool. Let me know. Drop in the chat if anybody's still confused. Okay, I'm going to do another question on trigs. Right? Amy, you there? Can I hear an Amy? Kira, are you there? Everybody's so quiet. All right, so let's move on to the next question. Right? Let's move on to the next question real quick.
So someone in the chat asked if you could use a half base by height since it's a right angle triangle.
Wait, yeah, that should work, but wait, okay, if you want to use a half base by height, you would need to find for A to C instead. If you understand what I'm saying, because this is the base and this is the height, so you would need to find for the height. Does that answer your question? You could use a half base by height, but you just need to find for the base and the height. The base over here is 9. You would have to find for the height using, that would be tan. You'd have to use tan. So yeah, you could use a half base by height. You just need to know what the height is.
So that formula, you can use it for all triangles or just right angle triangles?
What, the trig ratios?
No, the half AB sine C.
Oh, we don't use this for right angles, you know. You can use it for any triangle really. It's not just 90, any triangle, as you will see just now, any triangle. And in AddMaths, typically you have to use this formula. Yeah. Right? So once you have the angle and you have once you have an included angle and you have the length for either side, you could use that formula, no matter if it's a 90 or a non-90. You'll get the same result. Yeah. So let me do a question that's going to apply everything we just did. Okay. All right, so this is one of the infamous questions. So, any volunteers to help me with this question? Any volunteers? Chat, any volunteers?
I still reading it and understanding, sir.
Right. Notice they say figure 1 shows a plot of land. I know somebody put this question because people like to fight for land in Trinidad. I know that.
You sure, sir?
I
Or
sure.
they just feel everybody farming still. So they say they don't know this, they gonna know this.
Hey. Nah. I feel how to do with land dispute. Right? So you will help me with the question. We can do the question together. That's okay. But you willing?
Yeah, take your help. Yes, I go take my licks. Yeah. I'll take my licks now and get you the paper tomorrow.
Right, so figure 1 shows a plot of land, ABCD. Section ABC is used for building, so automatically I'm going to write building over here. This section is used for building, and they are saying that the remainder,
farm.
The radius BC is 10 meters, and the angle BCD is 90. Right, so in this question, we clearly have a sector over here. You seen it?
Yes.
So if this is 10, automatically, what would this length over here be?
AC, 10.
10. you all need to be aware of the small things like this, right? Small things like this you need
And we have the hypotenuse at ADC
You said we have the hypotenuse?
of ADC now, yeah,
Okay, yeah.
because both sides will be 10.
We do have the hypotenuse, right? And I bet you're going to have a question asking us to find the area of this shape. I sure. Yeah, look, calculate the area used for farming. So to find the area, you would need to find this length, just like the previous question. Okay.
And we'd have to find the angle at C.
Yes, and that wouldn't be hard at all. You'll see it. It's very, very simple. So if the building space is 50 pi over 3 meters squared, calculate the angle ACB in radians. So what are they giving us? In part 1, what are they giving us?
The area of the building space.
So here what? I go and come and write area formula one time. So A is equal to a half r squared theta, right? One time. All
And
right?
that's equal to 50 pi on 3.
Right. So A is equal to a half r squared theta. I know that the area is 50 pi over 3. So I'm going to plug that
And
in.
R is 10.
So what is the only unknown then?
Theta.
Right. This is how the badnesses go. You're looking to see which equation you could use so that when you plug it in, you end up with one unknown. That's typically what you have to do. So let's continue. On the right-hand side, could we simplify?
Yeah.
Yeah, and you could find a half a 10 squared.
Yes.
Are we 50, right?
Yep.
Right. And so you're trying to find for what? What is the unknown in this equation? If all you tell me pi, I will shoot this.
Theta.
Don't say pi, guys. Pi is our number. So theta is the unknown. I know it's looking a little confusing, right? But what would I have to divide on both sides to get rid of the 50?
50.
Right. So I would have to divide both sides by 50, right? But you're probably wondering how you can do that overhand. Yeah or no?
Use a calculator.
Use the calculator. So on both sides, you have to divide by 50. So this is what I'm going to tell you all to do. In the calculator, you're going to say 50 pi over 3, plug that into the calculator, 50 pi over 3 divided by 50. If you have a sharp pressure,
You got a third pi. No, so it'll be easier. Oh no, you'll have to open up the brackets more.
You have a sharp or?
No, I have a sharp, I have Casio, but I find it would be easy with sharp too. You just go 50 pi divided by 3 in brackets, and then you open brackets again, divide that by 50.
You want to know
Once you have everything in the
You want to hear the problem though?
Oh.
You're not going to get the answer in terms of pi. You're going to get the answers as decimal. And with these questions, you want to keep the answer in terms of pi.
So for the answer, I got 2 to pi.
Yeah.
Yeah. Now, for those who want to understand it, like how to actually do it, I'm going to show you fast. So if I divide both sides by 50, I would be left with theta over there. Now, dividing by 50 is the same thing as multiplying by what? Somebody tell me. Dividing by 50 is the same thing as multiplying by what?
50.
1 over 50.
50.
1 over 50.
1 over 50, right? So watch this. It's going to become 50 pi over 3 multiplied by 1 over 50. And I think I can see how to do it from now. Watch. You get pi over 3. Yeah. And the answer is in radians, right? Rad. Or you could put a little C on top. That's like equivalent to degrees notation, but just in radians. So you understood everything I did?
So yeah, pi on 3 is the same as a third pi?
Yes, it's the exact same thing. Let me show you something, right? If I'm gonna get a simple fraction. If you had a third by 2 over 5, what that fraction gonna be if I multiply it? What is 1 by 2? So this will be 2, and 5 by 3 is
15.
Right, so if you have a third, watch this, guys. If all you have a third pi, 1 by pi is pi, 1 by 3 is 3. It's the exact same thing. It's the exact same thing. A third pi and pi over 3 is the same thing. Yeah. So don't get scared. Right. So here what? we know that the angle there is pi over 3. We know that it's pi over 3. So now we need to figure out the area used for farming. And so, oh, what's your name again? I didn't catch your name. What's your name? The guy that was talking. The guy that was helping with this question. What's your name?
Achilles.
Say that again?
Achilles, it was me.
Oh, Achilles, that's you. Oh my God. I promise my memory not that bad. I promise. Right? So Achilles, right? I'm going to plug in that into my diagram now. So now I know that theta is actually pi over 3.
Yes, sir.
Now look at what's going to happen, right? If I know that this is 90 degrees, and I can figure out for this angle.
Yeah, 90 take away pi over 3, which would make it pi on 6.
No. Oh, you said
No?
the correct thing. Someone will go and say 90 minus pi over 3, but that's wrong. You can't say 90 minus pi over 3. The reason that's
Yeah,
wrong.
that's to convert it to radians.
Exactly. Guys, I can't do this, because one is in radians and one is in degrees. You need to get everything in terms of radians. So I want somebody to tell me.
But they make you memorize that big stupid table for the first 180 degrees and radians.
Well, it's not
So I know.
It's not hard to remember, It's not hard to remember. So watch this, right, guys? We know that pi is equal to 180 degrees, right? So then 90 degrees would just be half of that. So 90 degrees will be equal to pi over 2. If you can't see it like this, use this method. Anytime you want to go from degrees to radians, you're multiplying by pi over 180. If you have a Casio, it will give you the exact answer. If you have a sharp, you're going to get decimals. So if you have a sharp, you're going to have to do it manually.
Also, we could just cancel for a number like 90 degrees.
Say that again?
So we could also just cancel and we could manually for a number like 90 degrees and 60 degrees and stuff.
Yeah, those are quite simple, right? Those are quite simple because, again, pi is equal to 180. So then half of pi would be 90 degrees. Simple, right?
Yes, sir.
Right. So that would make this entire angle over here. That entire angle is going to be pi over 2. That entire angle is pi over 2. So if this entire angle is pi over 2, what would I have to do to figure out for this missing angle on the inside?
Pi over 2 take away a third pi.
Correct. So that's going to be angle ACD, right? So if I want to find for angle ACD, that's going to be equal to pi over 2, which is the big angle on the outside, right? Minus pi over 3. If you have a Casio, you can plug that in and they're going to tell you the exact answer. But if you don't have a Casio, we'll have to find the LCM. So I'm going to show you how to find the LCM and work it. 2 into 6 is 3. 3 into pi is 3 pi. 3 into 6 is 2. 2 by pi is 2 pi. So we end up with 3 pi minus 2 pi. So if you have 3 pi's and your friend eat 2 pi's because they're hungry, you're going to end up with 1 pi. So you end up with pi over 6. Right? Pi over 6. So the angle over here is pi over 6. So now I could come and draw that triangle to the side. So this is pi over 6. This is 10 meters, right? Let's go see where I draw any triangle to the side. It's because in the next question, look what they want me to do. They want me to calculate the area used for farming. And we know that this is the area used for farming. So Achilles, you good, right? I mean, if you understand.
Yes.
All right.
Yeah, I understand.
A real thing going on in the chat.
Really?
Yeah, if you get a decimal, leave it to 2 decimal places. Right. So Achilles, let me keep pushing.
Yes, sir.
We have this shape, right? And we want to find the area of it. Now again, in advanced, it's a formula half AB sine C, right?
Yeah, but you have to find that side first, so we'll do the same trig ratios.
You'll use the same trig ratios. So to use the formula, a half AB sine C, where C is the included angle, and A and B are the lengths, I would need to figure out for this length. Because if I know this length, that would make this angle an included angle. Because you know the two lengths that are right next to it. Okay, so let me label the triangle, right? This will be the hypotenuse. Since this is the side right next to the angle, this is going to be the adjacent.
Adjacent.
It's going to be the opposite, right?
Yes, sir.
Okay, so we're going to underline what we have and what we're trying to find. So we have H and we're trying to find A. So which trig ratio we got to use? Can I answer it here? Cos theta, right?
Cos.
Right, because K. Somebody breaking up. Right? So in the next line, I'm going to say cos pi over 6. And that's going to be equal to A all over H. Now, H is...
Same as the first question.
I tell you, it's the exact same thing. So once you master it once, you just have to repeat it, right? So I want to find for A, so you could cross multiply, or since you have 1/10 of A, I think you just multiply both sides by 10. Or they would prefer to cross multiply. Let me know.
Cross multiply.
Okay, we'll keep doing cross multiplication. So I'm going to write cos pi over 6 over 1. We're going to do cross multiplication. And if I do cross multiplication, we're going to end up with 10 cos pi over 6. And 1 by A is A. So A would be equal to 10 cos pi over 6. So I would like you guys to plug this into your calculator. Again, your calculator needs to be in radians. If it's in degrees, you're going to get the wrong answer. So plug that into your calculator and let me know what you're getting on the chat. So I want to hear the exact answer, and I also want to hear the answer in degrees. What's the exact answer in surd form?
5√3, and in decimals is 8.66.
Right. 5√3 meters squared, and in so two decimal places, it's 5√3. What's that saying, boy? That'll be 8.66. That'll be 8.
Yes, sir. So, like, you never sleep for the whole week, or what happened? You again got lacking real bad.
No, I didn't sleep. I've been up for days. I've been up for days.
So I think you're getting too much into this staying up all night thing, eh?
I think so, and I think so.
Wait, so listen, right? If I get the decimals, how am I supposed to convert it to the surds?
You have a sharp or a Casio?
You don't need,
Casio.
You won't need to convert it to surds, sir. You're going to plug in the same decimal anyway. It'll be the same thing.
Was I interested in why he not getting the answer as a surd? I mean, said you have a Casio, right?
You have a Casio, then you
Yes, I have
probably
a Casio.
you click on the S&D button before when you answer. Just click that and you'll get to surd.
This button over here, S to D. Press S to D.
Yeah, I press STD, but it's still coming up as a decimal.
What kind of Casio you have?
FX991EX.
Well, it's supposed to work. You plug in this exact same thing?
Yes, same thing.
Really, Jill. I don't know what to tell.
Reset your calculator. You probably go on and set it to some odd setting. Reset your entire calculator. That's the best you can do.
Right? So we know that the area is 8.66 meters squared. But let me ask you a question, Achilles. When we're doing calculations, should we use the 5√3 or the 8.66? Which one is more accurate?
The 5√3.
Right. Yes, it's meter squared. If you're asking why is meter squared, it's because in the start of the question, they're giving us the
It's
dimension.
radius calculating. Well, area, hemi-radius.
The guy with calculator problem, he got through?
Nah, so it's still the same way, same decimals I seen.
I don't know what to tell you, but if you write the answers as decimal, that's fine. They wouldn't penalize it.
It's okay.
So now that we know that A to C is 8.66 meters, I can now figure out the area. So the area of the triangle is going to be a half, and the lengths for the sides right next to the angle are 10 and 8.66. Right? And the angle is pi over 6. So plug that into your calculator and let me know what you're getting. Right? So the guy with the calculator problem, you would have to do this. Those who don't have the calculator problem, you all could plug in 5 root 3 to get the exact answer. But if you're not getting 5 root 3, then plug in the 8.66, the answer would not differ by that much. So the exact answer you are supposed to get is, I'm going to tell you the exact answer. The exact answer is supposed to be, the exact answer is 25 root 3 over 2. And that should be 21.65. Achilles, you get any 25 root 3 over 2? Okay, I'm not hearing Achilles. But guys, if you're not getting the third form, don't beat up. This is acceptable. This is just being extra. This is just being extra here, right? Unless they don't specify, you don't need to put your answer in third form. So that's the answer.
I get that, sir. But I didn't get mine. I can't you.
Say that again. You got it, right? Okay. Now, somebody asked earlier if they could use a half base by height. The answer is yes. But if you want to use a half base by height, this is what you're going to have to do. So I'm going to take a quick detour and I'm going to answer your question real fast. We should get the exact same answer. So I'm going to draw back the triangle real quick. Let me draw back the triangle real quick. So this is 10 meters. A, D. Right, so Achilles, is there?
Yes, sir, back. My internet had cut there.
The internet don't want to see a win, boy.
Yeah. They even talk
So we
about
would
that.
have to solve for AD here as well, right?
You would need to find...
Because in order to use the half base by height, we would have to find AD and use the other trig ratio, the sine.
Yeah, you would need to find for two sides. You really want to go through all that stress? You need to find for
If there's a whip, there's a way, sir. If there's a whip, there's a way.
Right? So
honestly, that's kind of easier than learning the other formula because this one is already here from maths.
I mean, a half AB sine C not that bad. A half AB sine C. A and B is the two lengths and C is the angle in the middle. Not bad. But if you want to use a half base by height, I'm going to show you how to do it real quick. So previously, we found D to C. Now we could find A to D either using Pythagoras theorem or using the trig ratios. I'm going to use the trig ratios. So this is H, this is A, and this is O. So I'm trying to figure out O, and I'm going to use H. So that'll be sine. So sine theta is equal to O over H. That'll be sine pi over 6. I don't know what O is. I know that H is 10. If I cross multiply, I'll get 10. If I cross multiply, I'll get 1 by O, which is O, and then 10 by sine pi on 6. So somebody tell me, what again for 10 sine pi on 6?
5.
Exact 5, right? Exact 5. Just confirm that. Yes, I'm getting 5. So if you want to use a half base by height, now you could use it. So the area is going to be a half. My base is 5. So my base is 5. If you were to take the triangle and rotate it, for those who are not seeing it, I'm going to rotate it for you quickly. So if you take this triangle and you rotate it, you could clearly see that A to D is the base and D to C is the height. So that's going to be a half base by height. So plug that into the calculator and you're supposed to get something very, very close to 21.65.
So and if we do it the other way, if we put 5 by 5 root 3 over 2, we'll still get the 25 root 3 over 2.
Yes, you'll still get the correct answer because multiplication is commutative. It doesn't matter the order in which you multiply. Right? Right. So it's up to you guys which method. But we got the same answer regardless. Right? So is there anybody majorly confused by this? If so, tell me. If not, I want to do one more question on trigs, this particular case, and then we're going to move on to, I want to do proofs. I want to do proofs because proofs give people real trouble. Real trouble.
So how you get the 8.66 from the third thing on top?
Okay, when I plug this answer into my calculator, I actually got 5√3 and 8.66. With Casio's give you your answer in third form and in decimal. So if you don't have this line, that's fine. You need to say this too. So you had the 8.66?
No, I only get the third format.
Oh, okay. Press S to D in the calculator. Press S to D. S to D. That's this button over here. S to D. Right? And you're supposed to get the 8.66. Confirm that it's working.
Okay, let me try.
Yes, I get it now. Thank you.
Okay, no problem. After calculus, I would like to do log sales and indices because that was like the third most voted topic. Right?
So I have a question about the formula you was using for the triangle, the half AB sine C. We could use that for a right triangle only, or like triangles other than a right triangle as well.
You can use it for any triangle. Yeah, any triangle you can use that for. Any triangle. Here what's saying any triangle. Once you know
Okay.
so like watch. If I have this triangle over here, if I know that this is 9 and this is 8, and let me just say I have an angle here, 60 degrees, I can find the area for that. But the condition is you must have an included angle. And again, what is an included angle? An included angle is an angle whose lengths are known on either side. Understand? Tell me if you
Yes.
understand. So if I wanted to find the area for this, I would just say a half 9 by 8 sine 60. And if I wanted to write that in radians, I'll be pi over 3. And I would say 9 a half 9 by 8 sine pi over 3. And I'll get the area. So that formula works for any triangle. It's kind of magical. Right. So I want somebody to pick the last sector question I'm going to do. Pick the last question.
Augustine. The formula you just call out, right? You just get on the formula sheet, so that's something you have to remember.
That's something you have to remember. Yeah.
Do you have a sine C, sir?
Yeah, it's in the formula sheet.
I think I'm not sure. I won't say.
Oh, yeah.
I don't even watch it.
Yeah, who does watch our formula sheet anyways? Who does watch that?
Me?
Not there. Oh, it's not there.
Exactly. I felt offended.
Yeah, that formula not there. You have to remember that one.
No, we never get formula sheet for we end of them, so we just don't watch it.
Yeah, I know Priya wouldn't give her no formula sheets. That is, she will not do that.
So she give me a formula sheet for last year for term 2 and nothing.
Serious? You lie.
Yeah.
That's,
No, she gave me one.
we times changing.
Times changing. We use it, and I don't know what to say. That formula sheet I do much. You just make your head stupid because you're watching the equation and you don't know what to do. You're like, well, yes.
That's crazy. That's genuinely crazy. You know things bad when you have the formulas, but you still can't figure it out. So here what? I want somebody to pick the last sector question I'm gonna do. The last sector question.
The 2012 good.
2012. This question over here, okay. Does everybody agree that this is the last question or they want me to do on sectors? The last question. Yes or no?
No problem, sir.
No.
No? Let me
The,
see.
the one with less space. That was lower down.
This one?
No, up. That with that small little space.
This one over here? Okay, let me vote
Yeah,
on.
I want to can one as well.
All right. So let me vote on it on the chat. I want a letter to go on the chat and tell me which question I want to do. So
I abstain. I want to get good enough. I could do one of them.
right. So it's either between 2015, 2012, and 2014. Yeah, let me see. So let me see how the badnesses go. Right. So I want somebody to be the moderator. Just let me know what's going on in chat. There's plenty of things at once. What is it called?
So 2015 one, yes.
Say that again?
It looking like 2015 when
2015 one.
2015 taking the lead, right? Say no more.
I mean 2015 when overwhelmingly nobody else voted for anything else.
That's crazy. What? Okay, so I guess we're going to 2015. Say no more. Kira, you here in class and you're not saying anything? Kira, let me know if you're there. Because I see you send my message just now.
Yeah, hi.
Hi, Kira. I feel a little bit shy or
Yep,
no,
I
no,
want.
no. Use my original student. You can't be feeling shy. Use our boss here. So if you have any direct questions, feel free to message me.
Okay.
All right, so Kira, while you're unmuted, let me do 2015. I know you like to do these kind of questions. I cannot put you on the spot there, but you'll get through, right? So Kira, get the question I read.
The following diagram shows a circle of radius r equals 4 centimeters with center O and sector AOB, with subtends an angle theta equals pi over 6 radians at the center. If the area of the triangle AOB equals a half r squared sine theta, then calculate the area of the shaded region.
Now, Kira, and you agree that this question is cake? And you agree?
Yeah, possibility.
Right. So Kira, if I want to figure out the area of the shaded region, which is this region over here, wouldn't I have to find the area of the whole sector? That's one. And what other area I would have to find?
You had to find the area of the sector, and then you had to find the area.
What else should we have here?
A triangle.
Right. So we have to find the area of the sector and the area of the triangle. Let's start off with the area of the triangle. Actually, no, let me start off with the sector. That should be easier. So Kira, tell me what's the formula for area of a sector? Area of sector.
A half pi theta. No, sorry.
In the middle of the night. Right, right. Yeah, so a half. You tell me the one in maths, eh? We use that in a maths. We use that for maths. It's a half pi
A
minus,
half pi r squared theta.
no, a half pi r squared.
Oh shoot, sorry.
No, I was saying, yeah, it's a half. No, this is correct. Yeah, half pi r squared.
Yeah.
No, no, half r squared theta. You did follow that? Yes or no?
Yeah, I call that, but
Okay, my bad. I really had to get some sleep. I waking too much nights, not doing more well, right? So Kira, we have a half r squared theta. Let me ask that question. Do we have the radius and do we have the angle?
yeah.
Or do we have everything we need?
Yep.
All right, so let's plug it in, right? So it's a half. My radius is 4, so that's 4 squared, and the angle is pi over 6, right?
Yeah.
Okay, so I want everybody to plug this into the chat and let me know what you're getting for the answer. I want the answer in terms of pi. Tell me the answer in terms of pi. All right, so Kira, when you plug this into the calculator, what did you get? You're supposed to get 4 over
I get 4/3 pi.
right. And that's the exact answer, 4 over 3 pi. And for those who are not getting that, that's okay. Tell me the answer you're getting to 2 decimal places. So Kira, you could tell me that one time. What's the answer to 2 decimal places?
4.19.
Okay. But Kira, if we can, wouldn't it be better to work with the answer in pi?
Yeah.
Right. Now, for those who don't have a Casio, you have a sharp and you want to get the 4 over 3 pi, let me show you how to do that. So 4 squared is 16. Right? So pay attention. So everything here is being multiplied. So Kira, doesn't that mean 2 could go into 16 8 times? Tell me if it makes sense. So 2 into 16 is 8. And in doing that, I would end up with 8 over 6 pi. And you could simplify 8 over 6 pi further. You could divide both by 2.
Yeah.
But if you don't have a Casio and you want to get the answer, you'll have to do these extra steps. Right. So is anybody not understanding how to find the area of a sector? To find the area of a sector, you need r and you need theta. And you need to have the angle in radians. I say it again, angle needs to be in radians. All right, so I seen all good news. And I seen out of 4.18. It's supposed to be 4.19 because when you plug it into your calculator, you will get 4.1887. And the number after 8 is 8, which is 5 or more. So that's supposed to be 4.19. Guys, that's rookie mistakes. Watch out for that. So Kiara, you okay with the area of the sector, right?
Yeah.
The people who wanted me to do this question, let me know if you understand how I found the area of the sector. Let me know.
We understand too.
Okay, nice. So you understand that in all those questions, you have to use a half r squared theta, and the angle must be in radians, and you must know the radius. Yeah?
Yes,
Yes,
sir.
All right, good. And so now we need to find the area of the triangle. Now, in this question, they gave you the formula to use. Now, if you use a half AB sine C, you'll get it correct. But why are you using that when they give you a formula? So, Kiara, how are we going to find the area of the triangle now? Tell me, Kiara, how are we going to find the area of the triangle?
Well, to give you the
They gave us a formula.
yeah, they give us the formula. So what we could do is
So the formula is a half. Yeah, Kiara, all you have to do is substitute. So Kiara, tell me, what is the radius?
4 centimeters.
Right, it's 4 centimeters. So I'm going to plug in 4 for the radius. And Kiara, what is the angle?
Pi/6.
Right, so Kiara, I want you to plug that into your calculator. Again, make sure your calculator is in radians, okay?
Okay.
Right?
I get 4/3 pi.
Now you're supposed to get 4 for your answer.
I don't know what to do wrong. Wait.
Let me show you how you're going to plug that into
Oh wait, I get 4.
There you get 4.
Yeah.
Is anybody having a hard time finding the area here? They're not getting 4? Let me know so I could show the solution on the chat if it's needed. Let me know, guys. Is anybody here having a hard time getting 4? Those who are sharp, are you all getting 4? Denisha,
No.
Denisha, I see you're having some trouble. What kind of calculator I have? Sharp. Okay, if you have a sharp, this is where you'll have to plug in. You'll have to say 1 divided by 2, close bracket, because that's how you represent that's how you would represent a half on the sharp. You're gonna say a half, then you're gonna open another pair of brackets, and you're gonna say 4 squared, and you're gonna multiply that. So you're gonna open up another pair of brackets, and that's gonna be sine pi over 6. Denisha, do you know how to put the sharp in radians? Yeah, okay. Once your calculator is in radians, right? Plug this in and you're supposed to get the answer. Supposed to. Or one more thing. Instead of pi over 6, you'll need to plug in pi divided by 6. I think everybody here with a sharp realizing why I say a Casio is supreme. Yeah. Okay. So that being said, let's find the final answer. So Kiara, what I haven't read is the area of the triangle. So to speed up things, I'm not writing the full thing, but in the exam, please take your time and write the full statements. So you need to say the area of triangle is 4 centimeters squared, and you need to say that the area, this would be the area. So the area of sector, that sector will be O, is equal to 4 over 3 pi centimeters squared, or 4.19 centimeters squared. Right. And so Kiara, now that we know the area of the sector, and we know that the triangle is 4 centimeters squared, how am I going to find my answer? Tell me, Kiara.
You're minusing the area of the sector minus the area of the triangle. So, you think, like, we could probably use the area of the sector in the point form. So 4.19 centimeters minus the 4. So that will give you 0.19 centimeters squared.
Yeah, that's correct. Now, guys,
Okay.
if you all know how to work with the exact form, do it. If you're having a hard time at this stage, please just work with the decimals, get your marks. If you lose a half mark or 1 mark, that's okay. The main thing is to get most of the marks. So the area of the shaded region is going to be 4.19 minus 4, and that's going to be equal to 0.19 centimeters squared, right? Achilles, and you know how to work with the exact form to get the exact answer in terms of pi?
Yeah, I can convert from degrees to radians.
Wait, what? No.
I was lost for a moment there.
Wait, what? No. 4 over 3 pi, that is 4.19. Watch, in the calculator.
Yes, sir.
Yeah, you're not going to put 180 there. 4 over 3 pi will be 4.19. So here what? If the exact notation confusing all you, guys, just work with decimals and done. Work with the decimals and done. Don't get confused with the fractions. Joanna, you need me to go over this part?
Yeah, near mic on or
Yeah, somebody's mic is on. Jaden's mic is on. Maria's mic is on. But the only person talking is Achilles. So if you're not talking and somebody else is talking, can you please mute your mic? If not, I will mute the mic for you. All right. So I'm going to go over the first part real quick. And here what, guys? I really don't want to confuse anybody. So if all you're okay with the decimals, just work with the decimals. Don't worry about the exact form. We're trying to get the most marks here, right? So how did I do the first part? Again, in this question, you want to find the area of the shaded region. To find the area of the shaded region, I need you to recognize that there are two shapes. There is a sector, and the area of a sector is a half r squared theta, right? And you have a triangle. And they gave us the area for that. They said that the area for that was a half r squared sine theta. So how did I get the area of the sector? To get the area of the sector, I use the formula, a half r squared theta, right? My radius was 4, and my angle was pi over 6. You plug that into your calculator, and you're going to get 4.19. The person that wanted me to re-explain it, let me know if you catch that. If you're not understanding the exact form, don't worry. Just work with decimals, right? So, Joanna, let me know if you want me to re-explain it, or you're good. So all you're doing is you're using a half r squared theta. You know that r is 4, and you know that the angle is pi over 6. You could plug that directly into your calculator, and you'll get 4.19 centimeters squared.
Excuse me, I'm not seeing the part of the area of the shaded region. Thank you.
Yeah, that's the area of the shaded region. Right? So we're done with sectors. Now we are going to move on to proof questions. Kiara, you know if anybody from my class here? You know what the rest of them?
I know Nicholas here.
Hey, Nicholas here. Nicholas, you had a work here.
Annalie here.
Okay.
I don't think anybody else here.
That's crazy. Well, go in the chat and ask them.
Okay.
Okay, that being said, I'm now going to move on to trig proofs, right? Let's move on to trig proofs. So before I move on to trig proofs, we just need to get a couple of things straight. There are some main things you should know. First of all, the main identity in trigonometry is sine squared theta plus cos squared theta is equal to 1. That's the main identity. Using this, we could write sine squared theta in terms of cos squared theta. Sine squared theta can be written as 1 minus cos squared theta. Cos squared theta can be written as 1 minus sine squared theta. For anybody that's confused, if I'm making cos squared theta the subject of the formula, I would move across the sine squared theta and it would become negative. If I'm making sine squared theta the subject of the formula, I would move across the cos squared theta and it will become negative. That's why I'm getting these answers. Something else that you should know, you should recognize that this isn't the complete in the square form. Sometimes they bring questions where you have to factorize it and cancel off terms. So you all should recognize and make that linkage. So 1 minus cos squared theta is the same thing as 1 minus cos theta all squared, and that's in the difference of two squares form. And anytime I have the difference of two squares form, remember difference of two squares is a squared minus b squared, and that's equal to a plus b by a minus b, right? And so this will be equal to 1 minus cos theta by 1 plus cos theta. You could also say 1 plus cos theta by 1 minus cos theta. It does not matter. You'll get the same answer because multiplication is commutative. And I want somebody to tell me, if this is another way, I could write 1 minus cos squared theta. What's another way I could write 1 minus sine squared theta?
1 plus sine open and close brackets and 1 minus sine open and close brackets.
Yes. So the main identity you should know is that sine squared theta plus cos squared theta is equal to 1. You should also be able to find sine squared theta in terms of cos squared theta. And you should also be able to find cos squared theta in terms of sine squared theta. And you should be able to see that it's in the difference of two squares form. Okay. That being said, you should also know what cos 2a is and cos and sine 2a. But before we move on to that, you should probably know compound and double angle formulas. So let me just address that one time. if I have something like sine A plus B, sine A plus B is equal to sine A cos B plus cos A sine B. If you didn't know that, drop that in the chat. If you did, say one. If you did know that, you're probably gonna pass. Right? What's the main consensus in the chat? I see somebody say 0. Adriel, I feel like a trolling, you know. I feel like a trolling there. Right? And if I want to find sine A minus B, sine A minus B is equal to sine A cos B minus cos A sine B. Okay, let's move on to cos now. Cos A plus B is equal to cos A cos B minus sine A sine B. No, I did not make a mistake. I know there's a plus sign here and there's a negative sign here. That's just how cos works. And cos A minus B would be equal to cos A cos B, right? Plus sine A sine B. This formula is given in the exam, right? This formula is given in the exam. It's in the formula sheet.
Wait, so all four of those?
It's not exactly in this form. It typically is be in this form. Watch. It is be in this form. So it could be like sine A plus or minus B is equal to sine A cos B plus or minus cos A sine B. It is be in this form, right? And you need to be able to understand that this form, it could split up into these two possible cases. Understand?
Oh, yes, I understand.
And then for cos, you will see cos A, instead of saying plus or minus, you're going to see minus plus. The reason for that is because when is plus is negative and when is negative is plus. All right? Right, so you need to be familiar with this. And guys, if all you remember this, all you could derive the double angle formulas in the exam. I'm going to show you all how to do that. So what exactly is the double angle formula? Double means 2. So double angle formula is when I add the same angle, so A plus A, or theta plus theta, or anything. Once is the same thing. So I'm going to show you all how to derive sine 2A. So sine 2A will be equal to A plus A. And so if I'm saying sine A plus A, instead of having another B, I'll have another A. So that's going to be cos A, that's going to be sine A. Right. So it's not hard, like I promise. All this means is that instead of having a B, you're going to replace the B with another A. So anywhere you see B, you're going to write a A. So you're going to end up with sine A cosine A plus cosine A sine A. Did anybody get confused by that? Let someone know.
Yes, sir.
You get confused by that?
Yes, sir. Could you just say it over again, please?
Okay, so did you ever see these identities? Did you ever see these compound angle identities?
Oh, yes, sir.
Okay, so what was I saying, right? All the double angle formula is, instead of adding a different angle, you have the same angle twice. So instead of adding A and B, you're adding A and A. So watch. Instead of B, it's going to be A. And instead of B here, it's going to be A. So sine A cos A plus cos A sine A. Understand?
Yeah, I understand better.
Okay. Do you know that these two are the same thing? Yes or no?
Yes, sir.
So for those who confuse, again, multiplication is commutative. Imagine if you have 7 by 5. 7 by 5 is the same thing as 5 by 7. So cos A by sine A is the same thing as sine A multiplied by cos A. That being said, I want you to see that you have two of these terms. Can you see that there are two of these terms here? You have one here and you have one here. They're the same thing.
Yes, sir.
So that's how we get 2 sine A cosine A for the double angle formula for sine 2A. That's how we get it.
Oh, okay, I understand it now.
And so now, if you forget the double angle formula for cos in the exam, you do the same process. So it's going to be cos A plus A. And so again, what is happening is that instead of a B, we're going to write an A. So tell me what to write then. That'll be cos A by what?
By sine B.
No, what? We working with the cos.
Oh, cos A by sine A.
Cos A.
Now watch is
Cos A, cos A.
yes. Because we're using this formula here, right? We're using this formula. The only difference is instead of having another B, instead of adding B, which is a different angle, you're adding A, which is the same angle. That is there twice. That's why we call it double angle. Right? So cos by cos A, and this is gonna be minus sine A by what?
Sine A.
Sine A.
And so you'll end up with cos squared A minus sine squared A. And this is what cos 2A is equal to in its simplest form. Now you could go a step further and you could write this in two variants. You could write it in terms of cos alone or in terms of sine alone by recalling the main identity. Remember, the main identity is, right, so the main identity was sine squared theta plus cos squared theta is equal to 1. So I'm going to write it here, but instead of theta, I'm just going to say A. So if I want to write my answer for cos 2A entirely in terms of cos, how would I do that? Somebody remind me.
Cos 2A in terms of cos would be, well, it would be cos A plus A, which is just cos A minus sine A, which is cos squared A minus sine squared A.
Nah, that's not what I mean. So let me show you what I'm talking about, right? Let me show you what I'm talking about. And you remember that sine squared A plus cos squared A is equal to 1? Remember that?
Yes, sir.
And from that, I could either say sine squared A is 1 minus cos squared A. And from that, I could say cos squared A is equal to 1 minus sine squared A. Yes or no? Somebody tell me.
I'm going to say yes, but I'll need you to re-explain this, sir.
Have you ever seen this identity before? This is like the most essential.
Yes. Yes. I had to revise all that.
Okay, so if I want to make this a subject of the formula, I would move across the cos, and the cos would become
Yes.
the other side. If I want to make cos squared the subject, what would I have to move across?
Do the same thing. The sine squared A.
That's how I get 1 minus sine squared A. So
Yeah.
what I'm saying now is that there are two different ways you could represent cos 2A. So look at what I'm going to do. What if I want my answer completely in terms of sine? What I would do is, let me show you what I could do.
Oh, okay. I understand what you're saying, sir.
So,
You would say cos A is equal to 1 minus sine A.
yes, that's exactly what I would do. Right? They could ask you a proof like this. And this would be minus 2 sine squared A. Because how much sine squared A is you minusing? 2. If there's a problem with simplifying, there's a simple way to think about it. If I ask you how much sine squared A is we minusing, and you go tell me 2, so minus 2 sine
Yes, sir.
right? Minus 2 sine squared A. Right? So that is...
But see, if cos A is equal to 1 minus sine squared A, and if it's 2 cos A, and they would have our next minus 1, it will be
no.
Minus 2 sine squared A, no?
And what was cos 2A equal to? What did we find cos 2A to be equal to?
Cos squared A minus sine squared A.
Right. And what is another way we could write cos squared?
Okay.
Right?
1 minus sine squared A.
You can see it, right?
Understood.
Right.
Yeah.
And if I wanted to write sine 2a, I was saying, boy, if I want to write cos 2a in terms of cos now, this is what I'm going to do. So check it out. So you need to know these proofs. So watch. I want somebody to unmute and tell me. Instead of having cos squared a minus sine squared a, I want my answer to just be strict
In terms of cos.
terms of cos. So who I had to replace? Cos squared a or sine squared a?
You replace sine.
Sine squared
Yeah.
a.
I would replace sine squared a with what? And guys, anytime you have a binomial term,
1 minus cos squared
1
a.
minus cos squared a.
right, but a lot of people just make this mistake. This not correct. That's not correct.
Is 1 minus. It's positive 1, so cos squared a plus 1 minus cos squared a.
Say that one
Are
more.
we wrong?
Say that one more time.
It'll be cos squared a. It'll be cos squared a plus 1 minus cos squared a. Right, no, that'll be sine. Why tripping myself, man?
Take your time, right? So you see, look at this, right? Sine squared a. And sine squared a could be written as 1 minus cos squared a.
Yes, sir.
This is what we call a binomial term because there's two terms and there's a sign in the middle, so there's two terms. Anytime you have something like that, you need to put brackets by it. So that's going to be minus, open bracket, 1 minus cos squared a. A lot of students make that.
Okay.
And so you would now expand. Minus by 1 is minus 1. Minus by minus cos squared a, cos squared a. And so when you group together the cos squared a's, if I ask you how much cos squared a's you see in there, you would tell me 2. So that is 2 cos squared a.
Minus 1.
Right. So guys, this is a little summary. Take a picture of this. Take a little screenshot of this. Right? Let me just highlight what you need to know. You need to know that's 2a. You need to know that sine 2a is equal to 2 sine a cos a. If you don't remember these two, at least remember this one. At least remember that cos 2a is equal to cos squared a minus sine squared a. If you think you could remember it, remember that cos 2a could be written as 1 minus 2 sine squared a. And if you could remember it, remember that cos 2a could be written as 2 cos squared a minus 1. But my advice is, what I personally do, I would remember this one, and in the exam, I could always figure out what these two are, using sine squared a plus cos squared a is equal to 1. So you need to know all of those things, and this is an essential thing to know. Right, so take a screenshot of those things. Those are things you need to know moving forward. Moving forward, you need to know those things. Right, so take a screenshot and let me know when you're ready to move on.
I already there, sir.
Okay. Well, let me keep pushing, right? Let me go. A couple other things you should probably know when you're dealing with trig proofs. You should know that tan theta is equal to sine theta over cos theta. You should know that. And if that is the case, I want somebody to tell me, what do you think tan 2 theta will be equal to?
Sine squared theta over cos squared theta.
No. Tan 2 theta would be sine 2 theta over cos 2 theta. Try this one. What do you think tan 1 plus x will be equal to?
Sine 1 plus x over cos 1.
I can.
Yes. So let's see it. So generally, I tell my students that you don't necessarily have to remember the identity for tan 2 theta. In the exam, you can just find sine 2 theta and divide it by cos 2 theta because the formula for this is very, very tedious. Yeah. Right? So that's that. What else? What other advice I could give all boy? In terms of identities, I think that's it. So everybody should know that sine squared theta plus cos squared theta is 1. Everybody should know that cos 2a is cos squared a minus sine squared a. Everybody should know that sine 2a is 2 sine a cos a. And well, now you know that tan theta is sine theta over cos theta, and any variant of it could be written in terms of sine and cos. Okay.
Sir,
Yeah.
you can hear me?
Yes.
I don't understand how you're going to use the double angle formulas to solve the question. Like, I don't know how the question go come for you to use that formula.
Okay, well, we'll do our question, right? We'll do our proof question. Don't worry. So let me do our question.
So,
Yeah.
I have a question. I just go back up the out.
All right.
Right here. Right? How in cos you have cos 2a equal cos square a minus sine square a. You could do the same thing for sine and put sine square a equals sine square a plus cos square a.
Wait, run that back there. So you're asking me something, right? You're asking me.
Right. So, right, like how you have that highlighted here, right? You could do the same thing for sine, make instead of putting it separate, join them together, like put like terms together, so cos with cos, sine with sine,
Go ahead.
and write it the same way. Yeah.
No, you can't do
Right.
that.
So you could group them together and write the same formula. So you'd be like sine 2a equals sine square a plus cos square a.
No, you can't do that. You can't do that. Let me ask you a question, right?
That will make it wrong.
This is sine a cos a, and this is sine a.
Right.
How much sine a cos a is you seeing?
1. 2.
2, so 2 sine a cos a. That's a simple.
Okay, okay.
Right? You can't do anything there. All right.
Okay, no problem.
So let me do a proof question. Okay, well, if I start off with this question, I'll go die. This question we could try. So let me give already the hints, the golden hints. Anytime we're dealing with
proofs.
Oops, yeah, I'm gonna show you the golden hints. Where is it? Oops. Have it in my notes somewhere.
Wait, after this, we'll be doing integration.
Differentiation and integration. Differentiation first.
Okay.
Right? Right, so these are the hints I would always advise you. If you have sec theta, cosec theta, and by the way, these not only syllabus, but I just showed my students it just because you really just need to know tan theta, sine theta, and cos theta. So if you have tan theta, you're immediately going to convert that to sine theta over cos theta. In all these questions, if you have different denominators, you need to find the LCM. You also should be able to see difference of two squares. You need to recognize that cos square theta plus sine square theta is 1. And using that, you should be able to go from cos square theta plus sine square theta is equal to 1 to sine square theta is 1 minus cos square theta. You should be able to convert fractions to division, then multiplication. And again, look at what we're trying to prove. So these are the golden hints. So we will do a question like this, and you'll see how these hints are utilized. So the first thing I see in here, I see in tan theta, sine theta over 1 minus cos theta. So the first step would be to immediately change tan to what? What am I going to change tan theta to?
Cos theta.
Sine theta over cos theta, yes. Tan theta is sine theta over cos theta. So I'm going to write sine theta over cos theta, and that's being multiplied by sine theta all over 1 minus cos theta. On top, what will that simplify to? So you're seeing sine theta over cos theta multiplied by sine theta. What would that simplify to? Somebody come
Sine
on.
sine square theta over cos theta.
Right, sine square theta over cos theta. And that is divided by 1 minus cos theta was surely going to happen, right? But did I confuse anybody here? Was everybody okay up to this point? Are they okay up to this point?
So it will be 1 over 1 minus cos theta divided by 1 over 1 minus cos theta.
Say that again?
Only 1 minus cos theta. When I bring it up, it'll form 1 over 1 minus cos theta.
Let me ask that question. Did I multiply or did I divide? Look at it. It's currently divide. If I have, imagine if I have 3 over 5, wouldn't that mean 3 divided by 5?
Yeah.
So I didn't multiply as yet. I'm showing everybody how to go from division and from division to multiplication. Right?
Oh, okay.
Yeah. So I hope I didn't confuse anybody yet. So now I'm gonna write back sine squared theta over cos theta. You see that divide? This over here, this over here, you could look at it as 1 minus cos theta over 1. And so if I change that to multiplication, that would be multiplied by 1 minus cos theta. For anybody that's confused, I want you all to think of this example, right? Imagine you had, let me just say you had 4 divided by 2. What does 4 divided by 2 mean? Doesn't 4 divided by 2 means 4 multiplied by a half? Are you understand that? That 4 divided by 2 is 4 by a half.
Yes, sir.
Okay, so n2 is the same thing as 2 over 1. So if I divide by 2 over 1, that's the same thing as multiplying by 1 over 2. So if I divide by 1 minus cos theta over 1, that's the same thing as multiplying by 1 over 1 minus cos theta. So I hope all you're seeing that. Yeah. All right. On top, we're going to multiply sine squared theta by 1. Sine squared theta by 1 is just sine squared theta. In the bottom, we have cos theta by 1 minus cos theta. So let me see if I follow the hints so far. Well, in this question, I didn't have to find LCM, but I did convert tan theta to sine theta and cos theta. I'll give all a hint. Maybe you had to look out for this. Maybe you had to look out for this. And you also had to use this hint. So guys, when we look at what we're trying to prove, are they seeing sine anywhere in this? Yes or no? Are they seeing sine in this?
No.
Nasty.
What do you think I should convert sine squared theta to?
To 1 minus cos squared theta.
Yeah, I should do that hint. And if I do that, what hint are they seeing?
The difference of 2 squares.
Yeah, we see any difference of 2 squares. Nice. So 1 minus cos squared theta, if you remember, is the same thing as 1 minus cos theta by 1 plus cos theta. And I think you can see that we're very, very close to the answer we want.
Would we cancel here now?
Yes, it'll cancel off. It will cancel off. And you're going to get 1 plus cos theta all over cos theta. Guys, if I split up this fraction, or for anybody that confused about that, let me give you an example with simple numbers, right? Imagine I had a half plus 3 over 2. And I could write that as 1 plus 3 over 2. Yes or no?
Yep.
Yep. And that being said, I could go from this to this. So if I have 1 plus cos theta over cos theta, I could break it apart into 1 over cos theta plus cos theta over cos theta. Is anybody majorly confused? I take my time. Let me know, is anybody majorly confused? I need a little unmute and tell me.
Nah, sir, we balling.
You balling? Nice, nice. So, let's continue, right? So 1 over cos theta, I can't really do anything with that. Cos theta over cos theta is what?
1.
Is that in the exact form they want it in, or we have to do something still?
We just had to switch it around.
We just had to switch it around, and we can switch it around because it's addition. Somebody mic is muted and there's background noise. Can you please mute the mic? Right, so did we get the answer we want? Let me know, guys. Let me know.
Yes, sir.
Right. And let me see how much of the hints we use. We did have to convert tan theta. We did have to use difference of two squares. We did have to do this. And we did have to use the identities. And we did look at what you're trying to prove. So these proofs are golden. Like, these hints are given always it's like sacred. Once you follow it, you'll be fine. And once you follow it, you'll be fine. So is there anybody that want me to go over any part of this solution?
So just to confirm, right? The part where you say 1 plus cos theta over cos theta, when you put 1 over cos theta plus cos theta over cos theta, that's just like an expansion of it.
Yeah, watch. Let me give you an example again with regular numbers, right? If you have 1 plus 3 over 2, what is equal to? No, don't tell me 4 over 2, eh? If I split up that, what will be equal to?
2 over 2 plus 3 over 2, which is 5 over 2.
Wait, somebody tell me 2 over 2? What you see in 2 on top?
1 over 2 plus 3 over 2.
So all you
no.
you understand that 1 plus 3 over 2 could be written as 1 over 2 plus 3 over 2, right?
Oh, so I understand now. It's just the cos was confusing me.
It's no different. It's no different. Cos theta is just a term. It's no different. Right? Anytime you're feeling confused, go back to the basics. Go back to the basics and see how it does work and just apply it to a harder example. Right?
So I really make myself look stupid there.
Well, yeah.
I say that 1 plus 3 over 2, and I feel that 1 was a whole number, you know.
You was the guy that said 2 over 2?
Yes, sir, it was me. It was me.
That's crazy. That's crazy. So if that's all, I'm going to do another question, another trick proof. Right?
So that's getting me so vexed while I'm working for 4 marks. I don't even get that much space on the paper to answer that question.
Well, truth be told, I was very, very careful with the working. If I was doing the exam, I would leave out half of the working here. But for the sake of understanding, I'm doing every single line. But you don't have to do this much working. Your working might probably just be like that. If you can see the concepts fast and do it one time, your working will be like that long for at most. But I would rather you take your time and get your marks, right? Take your time and get your marks.
I agree.
So don't live life on the edge just yet. After CXC, yeah, a little live life on the edge. No, though. So somebody was asking me why and how would I use the double angle formulas in a proof question. Let's look at how we'll do that. So these hints here missing out on something. So I'm gonna add it in one time. The last hint. Oh my. The last hint. If you all see double angle formulas, you need to write it. You need to write the identity. So you're gonna convert all right. So guys, before we even continue, I want somebody to tell me what is sine 2 theta and what is cos 2 theta. Remind me, what is sine 2 theta?
So sine 2 theta would be 2 sine A cos A.
Well, in this case, we're dealing with theta, so replace the A for theta.
Okay, yeah. 2 sine theta cos theta.
Yes. Right? And remind me, what is cos 2 theta?
Cos square theta minus sine square theta.
Yes. I want you all to play it safe. Don't use 2 cos square theta minus 1 or 1 minus 2 sine square theta. You're not really sure which case you would have to use, so I would recommend using this one and alter it down the line. So let me go, right? So I have sine theta, and again, guys, if you see something that's in its double angle form, you need to write the identity fit. So I'm going to change that sine 2 theta to 2 sine theta cos theta. all over 1 plus cos theta plus cos 2 theta. And cos 2 theta, I know it to be cos squared theta minus sine squared theta. Right. Now, something that's, I don't know why I didn't include it here, but you need to be able to factorize. So you need to be able to factorize, right? And what do I mean by that? The main type of factorization here is GCF, the greatest common factor. In some instances where they're feeling evil, you have quadratic factorization. You might have something like 2 sine squared theta minus 2 sine theta plus 1 as any form of a quadratic, and you have to see that and factorize it. Yeah, this be evil sometimes, right? Okay, yeah, so let me go. So I want somebody to tell me, are you all seeing any common terms with sine theta and 2 sine theta cos theta? Are there any common sine theta, right? You're seeing sine theta. So as I could pull out sine theta from both of those terms. Now, this part has confused plenty people, but I'm going to show you all a trick to always get it right. If I'm pulling out sine theta from both of these expressions, this is how you can look at it. Sine theta over sine theta is 1, and then 2 sine theta cos theta over sine theta. That'll be plus 2 cos theta. Did anybody get confused by how I factored out the sine theta from this expression? Yes or no? I need some feedback.
No, sir, I understand now, because it's sine squared, so you take out the positive factor.
Wait, sine squared? What you see in sine squared?
In the denominator, sine, you prefer to get sine theta over sine theta. No. How you get that sine theta over sine theta, sir?
Okay, wait. Here what, guys? We're not dealing with the denominator, you know. Forget the denominator. Forget that. And on top, you notice you have a sine theta here, and you have a sine theta in that term as well.
Yes.
So what I'm going to do is I'm going to factor out the sine theta from both terms. So
Okay.
if I pull out sine theta, the question is, what would you have to multiply to get back sine theta? What by sine theta is sine theta?
1.
1, so I put 1 here. And what by sine theta is 2 sine theta cos theta? 2 cos theta by sine theta is 2 sine theta cos theta. But some people have a hard time doing that. So I'm saying all you can do is, if you know you want to pull out sine theta, just divide sine theta by your terms here, and you'll get what you're supposed to get inside the brackets. Let me show you what I'm talking about. So sine theta plus 2 sine theta cos theta. If I am pulling out sine theta, that means I'm dividing by sine theta throughout. See, you see what I'm talking about, right? Sine theta over sine theta is 1, and the sine theta will cancel off with that. So 2 cos theta.
Yes, sir.
Right. I'm not hearing anybody else. You guys lost or are they okay?
Understand?
So we get into
Okay, that's good to hear. That's good to hear. Right? In the yeah, say that again.
I said that I understand that part.
Okay, great. Let's look at the denominator now. In the denominator, most of my terms are what? What are most of my terms? If you look at and another thing, right, guys? Let me ask you a question. We want to get tan theta, and that's what we want to get. Do you want to get tan theta?
Yes, sir.
If only want to get tan theta, ain't you know that's gonna be sine theta over cos theta?
Or we could cut down the time it takes for this here plenty.
Wait, no. You're scaring me. I just showing you a concept, right? And you know tan theta is sine theta over cos theta.
Yes, sir.
What I'm saying is, on top, you're supposed to get sine theta, and in the bottom, you have to get cos theta by 1 plus 2 cos theta. So you can cancel off now. You get sine theta, cos theta.
Yes, sir.
Well, you really figure out any exam, do this. You'll get some marks. right? But we're going to do the full work in here. So here we're saying, right? In the denominator, it should be cos theta alone. Are you all seeing cos theta alone in the denominator?
No, sir.
Now we see in sine squared theta, and that's our issue. So we need to convert that, right? So we're going to do that. Let me just make this smaller. Right, so we're going to convert sine squared theta to cos squared theta. I want somebody to tell me what is sine squared theta to cos squared theta?
It would be minus open brackets 1 minus cos square theta.
Yes. I'm happy that you said brackets, right? If you leave out the brackets and you just put minus 1 minus cos squared theta, you're doing it wrong. Since 1 minus cos squared theta is a binomial term, you need to put it in brackets and then expand the brackets. Yeah. So take that in mind. Just don't forget that. And so in the next line, we could actually simplify, right? We could actually simplify. So on top, it's going to be 1 plus 2 cos theta. I'm going to leave it like that. Guys, I'm going to leave it like that because we could only cancel off terms when it's a product. And on top, we have sine theta being multiplied by that whole expression. So that's good. We like that. Let's simplify the denominator and see if we could pull out 1 plus 2 cos theta. Let me see. So 1 plus cos theta plus cos squared theta. I want somebody to expand this out. Expand that out for me quickly. If we expand that out, what again? What again?
Minus 1 plus cos squared theta.
Right. Cool. It's sounding like I have some people from foreign here. Drop your location. If you're not from Trinidad, drop your location. Yeah. I'm curious.
So you sound like you're interrogating the people.
No. I just curious. I'm wondering how much people from different countries joining my marathon. My little marathon, you know?
Where's Diego, boy?
Diego Martin.
Somebody,
No.
somebody just say they're from Diego, and I see a bunch of Jamaica.
Seeing a bunch of Jamaica, but Diego? That's Diego Martin is Trinidad. Man say Russia.
Chelsea, where Diego from, boy? You have to say the full country. It's the north of the chain. I guess we get intro lesson.
Nah, boy, and people from North thinking they in another country is wild, boy.
So I think there's a dumb question, but how did we get 1 plus cos square theta?
How do we get 1 plus cos squared theta? I mean,
Yeah, down in the denominator from the difference of the two squares. I think I get lost there.
where is the difference of two squares? It's not different. I never do difference of two squares yet.
The 1 minus cos square theta we have in brackets.
Okay.
That's turning to 1 plus cos square theta.
I'll bring your attention to something. Sine squared theta plus cos squared theta is equal to 1, right? From that, sine squared theta could be equal to 1 minus cos squared theta, and cos squared theta could be 1 minus sine squared theta. Yeah or no?
Yes, sir.
So you understand that if I'm making sine the subject, I would just move across the cos, and that is how I get 1 minus cos squared theta. And
yes, sir.
if I want to make cos squared theta the subject, I will move across the sine squared theta. So that'll be 1 minus sine squared theta. So what I said here, and why did I do it? I did it because I want to get tan theta. If I want to get tan theta, the top should only have sine, and the bottom should only have cos. But this is not cos. So I want you to recall.
Oh, so that wasn't what I was asking, but I figured it out. We was multiplying by the minus sign from outside the brackets. My bad.
Oh, I thought you didn't understand why we went from that to that.
Oh no, sir, I know how we get from that. I was just trying to figure out how we went from 1 minus cos theta to 1 plus cos theta, but I realize now.
You know what was confusing, man? You were saying 1 plus cos squared theta. That's not 1, eh? That's a minus 1 plus cos squared theta. Because watch, the minus by the 1 is minus 1, and the minus by the minus cos squared theta is plus. So that's that whole term. This whole thing here is minus 1 plus cos squared theta. Right.
Okay, so thank you.
No problem. And so again, we're gonna leave the top as in a factor format. In the bottom, we're gonna look to simplify. Is there anything we could simplify in the bottom? We're looking at the bottom.
Cos square theta.
Somebody said cos square theta. I'm seeing a cos square theta here, and I'm seeing a cos square theta here. So how much cos square theta are we seeing?
So you're
Two.
We seeing
cos
two,
square
right?
theta plus cos theta.
Say that again.
You're going to get 2 cos square theta plus cos theta, and then you're going to be able to distribute it with cos square theta as your common factor. So you're going to put cos square, open brackets, 1, add 2 cos theta.
Yes, that's correct. That's exactly it, right? Is anybody seeing that we could cancel off 1 and minus 1? Yeah or no? I didn't hear anybody tell me that.
Yes.
And 1 minus 1 is 0, guys? Yeah, 1 minus 1 is 0. And so we end up with cos theta, and we have cos square theta plus cos square theta. So we have 2 cos square theta. So now we could pull out the greatest common factor. The greatest common factor of the denominator is the 1 plus 2 cos theta. Well, no, it's cos theta. And you end up with 1 plus 2 cos theta in the brackets. So let me run that back. And everybody sees that we have a cos theta over here and a cos theta over here. Everybody's seeing that, right? So since I have a cos theta in both terms, I'm going to pull out cos theta. If you don't know what's going to go inside the brackets, you can do this. You can go aside and you can say, watch, check it out. You could just divide by cos theta. And so cos theta into cos theta is 1. If I divide this by cos theta, cos square theta means cos theta by cos theta. So it would cancel off with 1 and so it would remain with plus 2 cos theta. Guys, if you're not doing anything, please abstain from writing on the screen unless it's providing actual substance or I ask you all to help with a question, right? Plus 2 cos theta. So is anybody confused by how I factored out the cos theta from these two terms? Yes or no?
No, sir.
Don't be scared to drop something in the chat, you know. Let me know. Okay. So that being said, can everybody see that these terms could cancel off? Since we have products on the top and at the bottom, we could cancel off. I'm hoping everybody could see that. And so that would be equal to tan theta because we end up with sine theta over cos theta, which we know is tan theta, and that's the question solved. Bam.
All that for 4 marks.
No,
So I really want my prayers real strong tonight.
It's only looking hard, you know, and I went very carefully. This working like this one of the easier questions. If I share a hard question, you get a heart attack. This not that
So
bad.
usually differentiation and integration for me. I'll go pass with that. Differentiation and integration.
Well, differentiation and integration is 30% of the entire paper. Trigonometry is not that significant if we look at the marking scheme, because it's in section 2, and in section 2 you have coordinate geometry, you have vectors, and you have trigonometry, and that does only make up 20% of the paper. So I don't know why they're hurting all their head over trigonometry this much. The main thing on it should be stressing.
We want to do the best we could. Or we should be stressing about.
They should be stressing about integration and differentiation, because you have differentiation, you have integration, you have kinematics, which is the application of differentiation and integration. You should be stressing about that. And you should know.
That's why I
run it.
Okay, well, after this,
I read it.
And you should also know how to do log, surds, indices by heart. Like any question in that, you should be able to solve. And you should know polynomials as well, like factor theorem, remainder theorem, polynomial long division. Even how to do x to the power 4. You should be able to do all of those things. Like, and sum and product of roots, you should be able to handle that. So I'm going to explain this question one more time. I'm going to do one more proof question, and then we're going to move on to trigonometric equations, right? So how did I do this question? whenever you're doing a proof question, if you see a double angle formula, I need you to write what the identity is equal to. I need you to do that. Once you have that, you should be able to factorize. So if you can, pull out the greatest common factor. Now look at the question. Look at what we're trying to prove. In this case, we're trying to prove tan theta. So to prove tan theta, you have sine theta over cos theta. So on the top, you should have sine. In the bottom, you should only have cos. We realized that we had a sine squared term over here. So sine squared theta is the same thing as 1 minus cos squared theta. And don't forget, you have to put that in brackets. When I expanded, I got negative 1 plus cos squared theta. The 1s was able to cancel off. I had 2 cos squared theta, so I write 2 cos squared theta plus cos theta. You realize you could have factored out the cos theta, and you did, and you cancel off and you get tan theta. Not that bad. It's like an easy question. Let me move on to the hard question now, the one that will stump all you, but you should know it. I think trigonometric proofs is the one thing they repeat in the paper too. It's like the one thing they repeat. They don't really repeat anything else, but you see proofs, they just repeat it. I swear I see, when I was making this book, I see some repeats. Right? That question not bad. Yeah, this is the question I need to do with you all. For 4 marks is wild. There I say myself. Okay. So who wanna help me with this question? I need a brave volunteer.
So I want to help.
Okay, help me out, right? So first of all, we consider the left-hand side. So that'll be 1 over cos theta plus tan theta. Would I leave tan theta the way it is?
No, sir. We could convert it to sine theta over cos theta.
Question. Do we have the same denominator in the denominator? Check it out. You have 1 over cos theta plus sine theta over cos theta. Do they have the same denominator?
Yeah.
So
So
what
we could
mean?
just add.
You said just add. So tell me what to write then.
It would be 1 plus sine theta over cos theta, all over cos theta.
Yeah, that's correct. Okay. If any of you are confused, look at this example. If I have a half and I have 3 over 2, from standard 5 maths, all you should know, I could write that as 1 plus 3 over 2. Why? Because I have the same denominator. Just because of the same sine and cos something, that don't mean it different. It's the same thing, right? 1 plus sine theta over cos theta is the exact same thing. No tricks. All right. I'm the person who's talking. What's your name? So I could know your name. I know who I'm talking to.
Oh, there's Aliyah.
Aliyah, okay. Right? This expression, and I could write that as 1 divided by 1 plus sine theta over cos theta. Yes?
Yes, because, yeah.
You were saying because? Continue.
Well, I was just gonna say that the line, the dividend, it just means divide, so we could also just write it out.
Yes, that's correct. I don't know if all you know this, right? But the divide sign quite literally tells you that you have something on top and you have something in the bottom. That's the division sign. I don't know if all you ever see that. So like when you have 1 over 2, it quite literally means 1 divided by 2. This literally means division. Don't know if anybody know that. Right? And so we have this. How are we going to go from division to multiplication?
We would have to put the inverse of the second fraction, so it'd be cos theta over sine plus 1 plus sine theta.
Right? That's going to be equal to what?
Is gonna be equal to cos theta over 1 plus sine.
Right. So I know 90% of you all will reach this point and all they will hold all their head and all they will cry and all they will not know how to proceed. Because
Well, on the other side, we have 1 minus sine theta, and we should know from the ratio that sine square theta plus cos square theta is 1, and if we move it around, you get cos squared theta is equal to sine squared theta minus 1, we could always just use the so I know what I'm trying to say just now. Hold on.
Wait,
So I think what she's trying to say is like how we know sine squared theta is equal to minus 1 minus cos theta. We just swap out them two values that we have and we get the answer at the top.
right, but you can't just swap out values, eh? Let me show you what all you had to do. I hear what they're saying and all they're seeing it. That's good. Let me show you something, right? Imagine I had a fraction like 1 over 2, right? Cool. If I multiply the top and the bottom by 3, I'll get what? Where's a half by 3 by
3
3?
over 6.
Doesn't this still mean a half?
Yeah.
Yeah. So let me show you something. I'm going to use what they're saying, right? So all they're saying that we should be able to see the fact that, 1 plus that's cos squared theta is equal to 1 minus sine squared theta, which is 1 minus sine theta by 1 plus cos 1. I know all they're saying, right? All they're saying that cos squared theta is equal to 1 minus sine squared theta, and that's equal to 1 minus sine theta by 1 plus sine theta. That's what they're saying. But we need to introduce it properly. So look at how we're going to do this. So, Aliyah, look at this, right? We clearly have to introduce cos squared theta. We clearly have to do that. And how are we going to do that?
Yes, sir.
Well, we could multiply the top and the bottom by 1 minus sine theta. And we can do that.
Right?
Yeah or no? You seen it?
Yes, sir. Yeah, I've seen it now. Yeah.
Because guys, I'm not doing anything crazy. I'm not breaking the laws of maths. If I have a half, I can multiply the top and the bottom. I get 3 over 6. It still mean a half. Over here, I need to get 1 minus sine theta over cos theta. So how would I get cos theta in the bottom? Cos theta is 1 minus sine squared theta. So if I multiply the denominator by 1 minus sine theta, I'm going to end up with 1 minus sine squared theta, which is cos squared theta. And so the cos theta on top would cancel off for the cos squared theta in the bottom, and that will leave you with 1 minus sine theta over cos theta. You see it?
Yes, sir.
Right.
Yes, that like in thirds when you rationalize the denominator.
Yes, it's very similar, but for different purposes. Different purposes. When you are rationalizing surds, you multiply by the conjugate because to get any difference of two squares form, so that you get a squared minus b squared. And obviously, if you have a surd, it's in your root. So when you square a root, you get rid of the square root. And the whole purpose of rationalization is to get rid of the square root in the bottom. It's for different reasons, but I see where you draw the comparison. Right?
So to understand it, right? But after we finish getting cos theta over the 1 plus sine theta, you had to multiply both of them by 1 minus sine theta. Wait, but when you multiply the cos theta by the 1 minus sine theta, that is cos squared theta, right?
No. Wait, eh?
How is it cos squared theta?
Take your time, right? So you understand that, let me run through back something, right? Let me run back through something. You understand that cos squared theta is equal to 1 minus sine squared theta, right? You have no confusion with that, like you understand that fully.
Yeah, I understand that.
And then I could write that in the form 1 squared minus sine theta squared.
Yeah.
Form is in?
What's it said?
What form is this in? 1 squared minus sine theta squared.
Standard.
No, difference of two squares form.
Oh, difference of two squares. Sorry, my bad.
So if you recall, difference of two squares form is a squared minus b squared is equal to a plus b by a minus b, or a minus b by a plus b, right? Yeah or no?
Oh, yes.
So I could write that as 1 minus sine theta by 1 plus sine theta. I think you can see now why I multiply by 1 minus sine theta in the bottom.
Right. I understand better now.
Maybe if I do this, you can see it better. You understand that in multiplication, I could switch the order and it wouldn't change the meaning, right? So if I wanted,
Yes.
Cool. So I really think you could see it now. I had 1 plus sine theta, and so to get cos theta in the denominator, I should multiply by 1 minus sine theta. So this whole denominator go and turn to cos squared theta, because 1 minus sine theta by 1 plus sine theta gives us back cos squared theta. You can see it?
Right, yes.
Right. So that whole denominator going to turn to cos squared theta. Yeah, that whole denominator going to turn to cos squared theta. And so I think you could see it now. If you have cos squared theta, doesn't cos squared theta mean cos theta by cos theta?
Yes, sir.
And so nth one on the cos theta on top would cancel off with one in the bottom,
Yes, it would.
right? So again, I do any full working because I don't really want to lose anybody. But all you should know the laws for indices and thing. So my final answer is 1 minus sine theta over cos theta. Is that what they wanted us to prove? Yeah, that's what they wanted us to prove. Right. I will go it over one more time because if a question like this come tomorrow, I want it to get correct. So, Aliyah, you understand? You understand how the badnesses go?
Yes, sir. So the badness go.
Right. So you understand that 1 plus sine theta by 1 minus sine theta is the same thing as 1 minus sine squared theta, which is equal to cos squared theta.
Yes.
All right.
Answer to square.
Say no more. Michaela, see that you raise your hand? Yeah.
So, we could also cross multiply in this situation.
No, you can't cross multiply. The only time you could cross multiply is when you have something on the left-hand side and on the right-hand side. We are trying to simplify our expression. Let me explain. If I had something like x over 2 is equal to 3 over 5, you see how we have fractions on either side? You see how we have two fractions, one on the left-hand side and one on the right-hand side? You would cross multiply there. But if you just have an expression like x over 2, what are you going to cross multiply it with? You understand what I mean? Yeah or no? I'm not hearing you. Someone kind of quiet. Yeah, someone kind of quiet. But you can't cross multiply here because you're trying to prove an expression. You're not solving something, you're proving something. So again, I'm gonna run through this one more time. How did I know to do this? I knew I had to do that because how else was I gonna get cos theta in the denominator? And how else was I gonna get 1 minus sine theta on top? How else? You need to be able to look forward and see that cos squared theta is 1 minus sine squared theta. And so I could multiply the top and bottom by 1 minus sine theta. And when I do that, this goes into 1 minus sine squared theta, which is cos squared theta. Yeah. So have anybody still confused, or are you ready for me to do trigonometric equations?
We good, sir. We good.
So run the equations.
All right. Ooh. So before we move on to the trigonometric equations, let me just give all this some pointers, right? When we do trigonometric equations, anytime you see double angle identities, you replace them one time. You don't stick, you replace them one time. If you see sine 2 theta, we know that sine 2 theta is 2 sine theta cos theta. You should know that by now. If I see cos 2 theta, again, I should know that that is cos squared theta minus sine squared theta. If I want, so like when we do trigonometric equations, right? We want everything to be in terms of one trig ratio. When we do trigonometric equations, you should have one trig. Shouldn't have more than one. You should have one trig, either sine or cos. So you should remember again that cos squared theta is equal to 1 minus sine squared theta. And you should make the connection that sine squared theta is equal to 1 minus cos squared theta. When we do trigonometric equations, you should also know the quadrants. So in the quadrants, how I like to remember it is all teachers curse. So what this means is all the trig ratios are positive over here. So sine, cos, and tan. In the second quadrant, the only thing that's positive is sine. In the third quadrant, the only thing that's positive is tan. And in the fourth quadrant, the only thing that's positive is cos. When we are doing these questions, you need to find the reference angle. The reference angle alpha is in the first quadrant, and you can mirror that in the other quadrants to find your answer. So if this is your reference angle here, the position of the reference angle in the other quadrants would be given as such. So alpha would be over here. Alpha would be over here. Alpha would be over here. Let's just say, so I want to call on somebody. Let me just say my solution was in the second quadrant. Before I do that, let me just put some labels here. This could be 0, that could be 90, this could be 180, this could be 270, this could be 360. Or alternatively, this is going to be, this is 0c, this is pi over 2c, this is, no, what's the same? Yeah, that's correct. This could be pi c, this could be 3 pi over 2c, and this could be 2 pi c. All right, so I want to call somebody. Anybody want to help me with something here? Yeah, anybody?
Yes, sir. I'll go open around big motor again.
Okay, thank you. So let me just say my answer was in the second quadrant, right? Look at what's gonna happen.
Yeah.
If my answer is in the second quadrant, let me just say alpha is 30 degrees, right? If the second quadrant, that come like a stop what degrees before 180? How much degrees?
50. 50.
150, right? You understand how that go? So
Yes, sir.
I do this. So this is how I want to show my students so that they go remember it no matter what. If we go from 0 degrees and we stop to
180 minus alpha. All right.
Right? If my answer is in the third quadrant, then it come like I went 180 degrees plus alpha.
Alpha plus 180.
Everybody seeing that? So if my answer is in the second quadrant, it come like I went 180 degrees, and what I do? I went alpha and alpha more. So if alpha was 30, that'll be 180 plus 30. I need somebody else to help. Like, I need somebody else to give me feedback. Are you understanding what I'm saying?
Yes, sir.
Okay,
Yes, sir.
if my answer is in the third quadrant, and alpha is 30 degrees, that come like I stopped
360.
Yeah, that come like I stopped 30 degrees before 360. So that'll be 330. Understand? So with that way, you don't have somebody going on them. Okay.
Sir, could you do that part over again for me, please?
Okay, no problem. So what's your name, my chance?
Kitana.
Oh, like the sword?
Yes, sir.
Okay. So if my answer is in the second quadrant, watch this, right? It come like I stopped 30 degrees before what angle?
180.
So if I stopped 30 degrees before 180, I would have traveled 150 degrees, hence.
Yes, sir.
Yeah, because this will be 30 degrees, and this whole thing here is 180, so that'll be 180 minus 30. Let me just say, my answer was in the third quadrant. And that come like it went 180 degrees, and it went on alpha more. You can see it? Let me do that one more time.
Yes, sir.
So this is 180 degrees, and if I go, let me just say, this was 30. That would be 180 plus 30. And if my angle was in the last quadrant, that come like I stop in 30 degrees before reaching 360. So that'll be 360 minus 30. And that's what you remember. To find any angle without remembering any formulas or anything. You can just figure it out in the exam. So that being said, somebody join on. I think your mic is unmuted. Okay, everybody mute. Cool. All right. So, another thing you need to know, when you're finding for the reference angle, your reference angle is always positive. I'm going to say that again. Reference angle is always positive. So how do these questions flow? With these questions, you're given an equation. You need to convert the equation to one trig. You'll end up with a quadratic. You will need to make some substitution if you want to make your life easy. So you could say like, let sine theta or something be equal to y. So you could say like, let sine theta be equal to x. From there, you solve, and you're going to get two different values for x. Guys, tell me something. If we're looking at the sine graph and the cos graph, what do both of those graphs go up to? What's the maximum value for those graphs? So this is the sine.
1.
1. So if I get a value that surpasses that range, will my answer be valid?
No.
No. So if I get an answer that's more than 1, so if I get an answer, so if x is such that x is more than 1, or x is less than minus 1, it's invalid. Invalid. Because the sine graph and the cos graph could only go up to 1 and go down to minus 1. So like, let me just say we get negative 2 here and a half. We had to take the half. Next thing you would need to do, you would need to consider all cases. Consider all cases. And yeah, you get your answer like that. So let me do a question, right? If all you need to take a screenshot of this first. Yeah, take a screenshot of this. So after we finish trigs, I'll give all you 10 minutes break and we'll come back to some differentiation.
All right, so
Right? So anybody that's asking for the link for the book, no. I made this book and I sell it to my students. You cannot have this book. Yeah, can't have that book. Would be nice, but yeah, you can't have it. You can take screenshots, so. Right? So let me do a question. Let me see how it is going. I saw that somebody sent me a proof question. It looks really nice, so we could look at that. Right, we could look at that question. Right. So which question do I want to do? Let me check. Yeah, this is a nice question. All right, solve the following equation, giving your answer correct to one decimal place. Now, I want somebody to tell me, are we going to give our answer in radians or degrees?
Degrees.
Degrees.
Degrees, because the specified range is in radian. The specified range is in degrees. So you have to use degrees. You can't use radians. This is like the only time you have to use degrees in advanced. So let me go. Guys, can we convert cos theta to sine theta? Yeah or no?
Yeah.
Drop a 1 in each chat and drop a 0 in each chat if you think that's nonsense. Yeah, so a 1 if you think you could do it, and a 0 if you think you can't do it. I see nobody put anything like, oh, they're scared. Short answer is you can't convert cos theta, guys. You can't do that. When you're doing these questions, you're looking to see which trig function is squared. So we have sine squared theta. Do we know what sine squared theta is in terms of cos?
1 minus cos squared theta.
So again, When you're doing these questions, you're looking to see which one is the squared term. Which one is the squared term? And whichever one is the squared term, you can convert that. You can't convert the one that's linear. So I'm going to say 8 by 1 minus cos squared theta, and that's going to be equal to 5 minus 10 cos theta. Now, since we know we're going to end up with a quadratic, I'm going to take everything on the right-hand side and move it across, right? But before I do that, let me just expand. If I expand, I'm going to get 8 minus 8 cos squared theta, and I'm going to bring across everything. If I bring across the 5, it's going to turn to minus 5. If I bring across the minus 10, it's going to turn to plus 10 cos theta, and that whole thing is going to be equal to 0. Right? Now I want to put this in the form of a quadratic. So the form of a quadratic is ax squared plus bx plus c is equal to 0. That being said, I'm going to write the minus 8 cos squared theta first. Right? Then I'm going to write the cos theta term. And then I'm going to simplify all the constants. So we're seeing a plus 8 here. We're seeing a minus 5 here. Could somebody tell me what 8 minus 5 is?
3.
3. All right. This is the line where you make the substitution. Now, if you're bad, you could factorize this with the trig, but I would not advise it. So the trig we're dealing with here is cos theta. So I could say let cos theta be equal to y. Or any letter for that matter of fact, other than theta. Right, so cos theta is equal to y. So if cos theta is equal to y, I want somebody to tell me what the equation becomes. What does the equation become?
It would become minus
Minus
8y squared
For one person at a time.
plus 10y.
Yeah, minus
10y
right.
plus 3 is equal to 0.
Now, what is easier to factorize? A quadratic with a negative coefficient for y squared or a positive coefficient?
Positive.
So we can multiply through by minus 1, but we'll show a little trick, right? I will show you a trick with the factorization. So if I multiply that out, I'll get 8y squared minus 10y plus 3, and that's equal to 0. Now, if you're bad, and you could do it, I wouldn't be against it. It is not hard to factorize. It will be 4y by y, and then 1 by 3. Would that work out? No, that wouldn't work out. So maybe I could try 8y by y, 3 by 1. That wouldn't work out. So let me check back this.
So how you get it positive it again?
Okay, so what I was saying is it's hard to factorize a quadratic with a negative coefficient for the squared term. So we multiply throughout by minus 1. You don't have
then she's supposed to be minus 1 too.
Oh, shucks, sorry. Yeah, no wonder it wasn't working out. Right? So if we do this, and I want to factorize it, that could be 4, that could be 2, that could be 3, and that could be 1. And so I want to get negative 10.
Listen, we could just do it on the Casio.
Yeah, using the Casio, but I'm sure you could factorize it here, if you're brave enough. Okay, do it on the Casio and make sure it's solvable. Sometimes you have to use the quadratic equation for these things. So
So wouldn't the minus 10y just factor out the minus 4 minus 6?
well, you're talking about the AC method, right? I typically stay away from that. I typically do it intuitively. So, like, let me show you how I just do it. To get 8y squared, I would multiply, I could say 4y by 2y. And to get minus 3, I could probably say 1 by 3. And so to get, we want to get negative 10y, so I should probably put a negative here to get negative 12. And since I had to get negative 3, it'll be plus 1 by negative 3. And yeah, look, we find the solution. So y would be equal to negative a quarter, and y would be equal to 3 over 2. So somebody just confirm that. Yeah, but I don't use the AC method. I just do it in my head, like intuitively. So like how I just do it, I just look to see where I had to multiply to get 8y squared. So to get 8y squared, you can say 4y by 2y. And to get minus 3, you could say positive 1 by minus 3. And so when you expand it back out, you're getting back to 8y squared. You're getting minus 12y. Over here again, plus 2y. And again, minus 3 over here. So minus 12y plus 2y is minus 10y. And again, back to 8y squared. So this is correct. Yeah, that's how I do it. But if you all are comfortable with the AC method, that's fine. Right. If you're having trouble with this, just plug it into your Casio. Does everybody know how to solve a quadratic on the Casio? Yes or no?
Yes, sir.
Yes, sir.
No, sir.
In case it has somebody that don't know how to do it and they're feeling shy, let me show you how to do it. I'll show you how to do it real quick. All right. Now, if you're using your Casio calculator to get y, you don't even need to do this. You could just jump straight from this line to this line. We might lose our mark, but I rather only lose our mark than get the whole question wrong. So if you have a Casio, or a sharp you could solve quadratics as well. I want you to plug this into the Casio or the sharp, and you're supposed to get the same answers for y. You're supposed to get minus a quarter and 3/2. Somebody just confirm that. So if I plug the original quadratic into the calculator, I should get the same results.
Yes, it's the same thing.
Same thing, right? This is more so for if you want to flex your brain and should make it factorize, but it's not necessary. You could just jump straight from this line to this line at the same time. Right? So does anybody not know how to solve a quadratic on the Casio or the sharp? Let me know. If we're dealing with sharp, I can't really help, but I could help with the Casio. Drop a 1 in the chat if you know how to work it on a Casio. Yes, you could find the quadratic on a sharp, but I just don't know how. Yeah, I just strictly work with Casio.
Yeah, there's press mode and it just press into 2 and it does let us solve a quadratic on a sharp.
Okay, word. Right, so for somebody with a sharp calculator, put how to do it on the chat. Record yourself and send it on the chat. Yeah, all are we helping each other here, right? We're gonna succeed. Right? Okay, let's proceed. Could somebody tell me which one out of these solutions is invalid? Which one of these solutions is invalid?
3/2, sir.
3/2, sir.
Okay, somebody tell me why is 3/2 invalid?
It's greater than 1.
It's above the limit.
Right, and we're dealing with cos here. If we look at the cos graph goes up to 1 and it goes down to -1. So there's no possible value for y. There's no angle that would give us 3/2. None. So that's invalid. So the only valid solution is -1/4. So now I'm going to recall that I said cos theta was y. So cos theta is equal to -1/4. Now this is where we find the reference angle. So to find the reference angle, guys, the reference angle sometimes is a solution, sometimes it's not. But if you look at this, right? Somebody tell me, we want to figure out where cos is positive or negative. We want to figure out where cos is positive or negative. Negative, right? So which quadrants would that be in? So again, cos would be negative.
2 and 3.
Right, 2 and 3. But here I was saying, right, when you are finding your reference angle is always the inverse of the positive angle because the reference angle exists in the first quadrant. And you could always mirror it in the other quadrants to get your answer. So to find the reference angle, it's going to be cos inverse of 1/4. Now, since this question is in degrees, I'd like everybody to convert, go back to degrees, right? And somebody tell me what's cos inverse of 1/4? What is cos inverse of a quarter?
So 75.5.
75.5, right? And let me ask a question. Will 75.5 give you negative a quarter? Yes or no? Somebody tell me. Kira, if you're there, tell me, would 75.5 give me negative a quarter? I don't hear anybody, but the answer is no. It will
So
not,
no, yeah.
it will not give us negative a quarter, but we need the reference angle to find the solutions, right? So this is not part of the solution set. It's just there to help us find the answers. So now I'm going to draw the reference angle in the respective quadrants. So alpha is here. Alpha is 75.5 degrees. Now my answers are in the second and the third quadrant. So I'm going to draw alpha in those quadrants. So alpha here will be 75.5 degrees. And over here will be 75.5 degrees. All right, so I want somebody to unmute that has had trouble with these kind of questions. I'll wait to unmute. Somebody that's had trouble with these kind of questions.
All right, yes, sir.
All right.
Hi, sir.
Let me show you how it's going to go, right? Our solution is in the second and third quadrant. So you're going to start from 0 degrees, and it come like you stop 75.5 degrees before what?
180.
Yeah, so because this would be 180. Okay, let me just draw the angles so I don't confuse anybody. So watch. This come like it was going 180 degrees, but wait, you stop. You stop how much? 75.5 degrees before 180. So my first solution is going to be 180 minus 75.5 because I stopped 75.5 degrees before 180. Do you understand that?
Yes, I understand that.
Somebody who's had trouble with these things, tell me. Are you understand that?
Yes, sir.
Yes.
Okay, and my other solution is in the third quadrant. So this come like I went 180 degrees and I went how much extra?
75.5 degrees.
75.5.
So if we went extra, it'd be 180 plus 75.5. So I want you guys to plug that into the calculator and tell me the two answers.
Okay, so the first one is 104.5 and the second one is 255.5.
Cool. So how do we check if these answers are correct? If you want to check if your answers are correct, it's supposed to give you what? What is it?
Negative.
So in your calculator, I want you to go and put cos 104.5 and tell me what you're getting. Cos 104.5.
Minus 0.25, which is minus 1/4.
Right. So that's answer. That answer is correct. I want you to go and plug in cos 255.5 now. So for those who saying this is not negative a quarter, guys, it is negative a quarter. If we use the exact angle, you would get negative a quarter, but we're using a rounded off value. I want you to recognize that negative 0.25, if you round that off, is negative 0.25, and 0.25 is a quarter. Guys, and 0.25 is a quarter.
Yes, sir.
Yeah, so negative 0.25 will be negative a quarter. And that's the answer both of these solutions are giving me. So we are correct. So I'll run through it one more time. With these questions, whichever one is squared, you're going to make a substitution. Then you're going to simplify and you want to put it in the form of a quadratic. Then you're going to say let cos theta be equal to y or sine theta. You're going to come up with a quadratic. If you cannot factorize it, plug it into your Sharp or your Casio and get the values. If any of your solutions are more than 1 or less than -1, it's invalid. You consider the other solution. So y is cos theta, so we said cos theta is equal to negative a quarter. Now, because cos is negative, I'm looking to see where my answer is negative. So it's negative in the second quadrant and the third quadrant. Are you probably asking why? Because in the first quadrant, everything is positive. And in the fourth quadrant, cos is positive. I want to figure out where cos is negative. Cool. I hear what we're saying. We're saying that cos is negative. So then why am I finding cos inverse of a quarter? I'm finding cos inverse of a quarter to find the reference angle. And you could kind of think of it as like a map from Dora. It is helping get to where you need to. So alpha is just cos inverse of the positive angle. Always, it's always the positive angle. And so we got 75.5. So we drew our reference angle in the respective quadrants. By the way, guys, it's common practice to draw your reference angle in the first quadrant, even though your solution is not in the first quadrant, right? So I drew 75.5 in the quadrants that had my answers. And then you would start from 0 degrees and you would go. Over here, and notice I stopped 75.5 degrees before 180, so 180 minus 75.5. And over here, I stopped, well, I didn't stop. I actually went past 180. How much did I go past 180 by? 75.5. So 180 plus 75.5. And if you ever want to check your answer, you can plug it in into cos theta, in this case, and you're supposed to get negative a quarter. And that happens, so both of our solutions are correct. So is everybody okay with this question?
So I understand everything, right? Except why y equals 3/2 wasn't valid. Like I don't understand that.
Here a way to do, right? Here a way to do. Hence why was cos theta?
Yeah.
Okay, a way to try to find cos inverse of 3/2. Try to find cos inverse of 3/2.
Okay.
What do you get?
It's an error in the calculator.
The reason why you're getting an error, you know what the cos graph looks like?
Yeah.
Okay, so the cos graph was the highest value the cos graph has go up to.
Okay, 1. Okay, I understand, yeah. Thank you.
So there's no angle that would ever give you a read off for 3/2. None. Because you're only going up to 1. Yeah, you're only going up to 1. So that's it for this. Let me know if you understand. Kira, have anything you need me to re-explain? Annalie?
No, I good.
Okay, Kira, don't be scared to talk, you know. He's a big man. Them have a bunch
Oh.
of outside children in this. You on the inside. Use like family, you know? So like, don't be scared.
Nah, don't worry. If I have anything unsure about, I'll let you know.
Right, say no more. Say no more. So we're gonna do one more trigonometric equation question, and then I'll accept 2 requests. So I already see somebody send me a proof question. I'll do that, and I'll take one more request for trigonometry. And then we're gonna move on. I'll give all that 10 minutes break, and we're gonna move on to integration. So somebody, yeah, you were saying
Quick question.
Mhm.
Why we didn't put the negative in when we plug it in the calculator?
Why we didn't put what?
The negative sign in when we put cos inverse. Yeah.
Okay, do that for me. Tell me what you get.
So I got the 104.5.
Okay, but how are you gonna find the other angle now? That's my question. Okay, so you'll get 104.5, but how are you gonna get the other angle? That's my question. You understand? The person that was asking the question, if you do that, you'll only end up with one of your solutions. So what I'm saying is, you need to find your reference angle. Your reference angle is positive. And why do you need to find cos inverse of a quarter? The person that was asking the question, I needed to unmute your mic so you could understand it. Who was that? I'm not hearing you again.
That was me, sir.
Okay. So you're asking me why we just always find cos inverse of the positive angle, the positive fraction. Alpha is primarily in the first quadrant. What we do to alpha is we mirror it in the other quadrants to get our angle. And so if you notice in the first quadrant, everything is
Positive.
right. So for me to find the reference angle, which is in the first quadrant, I would need to find cos inverse of a quarter. Let me say that one more time. The reference angle exists primarily in the first quadrant. And so tell me something, right? And everything had to be positive in the first quadrant.
Yeah.
Yeah, so that's why I found cos inverse of a quarter. And cos inverse of a quarter is 75.5. You could agree that 75.5 is not part of the answer, right? And none of my answers was 75.5?
Right.
None, right? But did it help us get the answer?
It did.
Did. So in these questions, the reference angle always needs to be positive. Why? Because the reference angle is in the first quadrant, and everything in the first quadrant is positive. So cos can't be negative in the first quadrant. So it's going to be a quarter, right? And all we do from there, we just mirror the angle in the other quadrants and use it as a reference. So watch, you notice how we stopped 75.5 before 180, and we went 75.5 past 180. The 75.5 or the reference angle is like a guide, and we use it to figure out all our answers. So in all the questions, you'll have to find alpha, which is always positive. That don't have to be part of your answer, but it will help you get your answer. Understand?
Okay.
Yeah. Somebody asked me why we didn't take the fourth quadrant. We want to get negative. We want to figure out where cos is negative. So why would we look at the fourth quadrant? The fourth quadrant is where cos is positive, and the first quadrant is where everything is positive. That is not, my answer would not be there. My answer is negative a quarter, and so it would be in the second and the third, because the only thing positive in the second is sine, and the only thing positive in the third is tan. Michaela, saw you raise your hand, you can speak.
So how would we find like 104.5 in the third quadrant?
Okay, so watch this, right? You understand that the reference angle will be here and here, right? Yeah or no?
Yes.
All right, so check this. If I start from here, this come like I stopped how much degrees before 180? Imagine you was going to go 180 degrees, right? But it come like you stop how much degrees before it?
So I'm talking about like if we put cos inverse of negative a quarter, we will get 104.5. So I
Right.
understand how we would get 75.5 degrees, but I don't understand how to get the 255.5.
Right, so that is why we don't find cos inverse of negative a quarter. That's why you don't do it.
Okay.
You know what I'm saying? Make sure you understand. Guys, you cannot find cos inverse of negative a quarter. Because if you do that, you're only going to get one of your solutions. You need to find the reference angle. The reference angle is cos inverse of a quarter, not negative a quarter. And you use
So,
it, yeah?
so anytime we have like a negative number, we would change it to positive.
Right, because you're trying to find your reference angle, and your reference angle is in the first quadrant. Everything is positive in the first quadrant. Yeah. So you always find your reference angle. The reference angle is always the inverse of the positive. And we use that to figure out all the other angles. So you understand that if you find cos inverse of negative a quarter, you're only going to get one solution. So you can't do that. You need to find the reference angle, and from there we could figure out all the other angles. So I think we should do another question like this, so they could see how it will look like in another case. So nobody would be confused. So or they could just take a quick screenshot of this all they want. So they could look at it when we do the next question. Right? As soon as you all have the screenshot, let me know so I can move on. Okay, I'm gonna
Go ahead, too. Yeah.
like you eating some gyro there or
Hold on, sir. With 1 second, you could go back, please.
yeah.
A sandwich.
Yeah.
All right, thanks, sir.
Yeah. I move on. So, so let me do another question. That's similar. Okay, look at a nice question here. Right. So the person that was very confused about the alpha and finding for negative and okay, I want you to help me with this question, right? I want you to help me with this question. So,
Yes.
right, so let me go. What is the squared? Which one is squared over here?
Sine.
We're gonna convert sine to,
Cosine.
so remind
So
us.
it will be 1 minus cos squared theta.
Right. So I'm gonna write 1 minus cos squared theta, right? Plus 3 cos 2 theta. And I'm gonna move across the 2 because we know we had to end up with a quadratic, right? And that will be equal to 0 now. By the way, guys, I want to let you look at the range. Look at the range. The range is from 0 to pi. Anytime you see pi, that means you had to work in
Radians.
Radians.
right. Radians 1 time. So let's put this in the form of a quadratic. That'll be minus cos squared theta plus 3 cos theta. Oh, notice in this question you have cos 2 theta. So what we had to convert that to? Tell me what we had to convert that to. You see in cos 2 theta, we're supposed to convert that. What is cos 2 theta again?
Squared theta minus sine theta. Sine squared theta.
If we expand this, what are we going to get?
3 cos squared theta minus 3 sine squared theta minus 2.
Okay, is anybody confused by anything at all I did so far? Remember what I said? You need to end up with one trig, and if you see sine 2 theta or cos 2 theta, you need to replace it. So just remember that cos 2 theta is equal to cos squared theta minus sine squared theta, right? Okay, so you understand everything so far, right? Yeah or no?
Yes, sir.
All right, so we have minus cos squared theta, and we have 3 cos squared theta. That come like is minus 1 plus 3. What is minus 1 plus 3?
2.
2. Now this question is kind of special, meaning that you could really go any way you want. Question, do you want to go in terms of sine only or cos only? What do you want to do? Sine or cos?
Sine.
You understand that since both of it squared, you could go in either direction, right? So you said,
Yes, sir.
so if we want to get in, if we want everything to be in terms of sine, we need to do what?
Put cos squared theta as 1 minus sine squared theta.
Right? And if you expand that, you're going to get 2 minus 2 sine squared theta minus 3 sine squared theta minus 2 is equal to 0. If you notice, we have a constant over here. We have 2. Guys. I feel like somehow they go look at this and say that is 0. No, you cannot do that. Reason why you can't.
Sir, quick question. Where do you want going?
Remember, you expand it. So 2 by 1 is 2, and 2 by minus sine squared theta is minus.
Oh, from the 1 minus the cos squared theta, the 3 cos theta from higher up.
Let me check.
Yes, so shouldn't it be minus 1 in the end instead of minus 2?
Let me check it back, right? So which line are you talking about? 1, 2, or 3?
Yeah, so from line 2, the one
That
disappear.
first line.
Oh, yes, I see what you're talking about. See what you're talking about. Let me just add in that real quick. Thanks for spotting that. One. All right, let me just check it back real quick. So 1 minus cos square theta plus 3 cos square theta minus 3 sin square theta minus 2. Right, 1 plus 2 cos square theta minus 3 sin square theta minus 2 is equal to 0. 1 plus 2. Yes, that's correct. Yeah, so let's continue. So we notice you have 1, 2, and minus 2. So where's 1 plus 2? Minus 2. What is 1 plus minus 2?
It's just +1.
Just plus 1, right? So we'd end up with minus 2. And matter of fact, since both of them are sine squared, can we combine them?
Yeah, so we will get -5 sine theta.
Sine squared theta. And that'll be +1 is equal to 0. Right. Now this question is a bit different in the sense that you won't get a traditional quadratic. But it's okay. It's actually easier. So let me ask you that question. If I had 5x squared plus 1 is equal to 0, how would you all solve that?
A, B, and C.
A, B, and C?
Summon product method.
Now, if I wanted to solve this, I just go and move across down -1.
Just move across the -1, and then carry across the 5, and then find the square root.
Yeah, but you can't find this word because it's negative, but yeah, you're correct. Correct. So can you recognize that it's the same thing over here, right? It's the same thing. If it's confusing you, we can make the substitution again. We could say let sine theta be equal to y. And so if we say that, we're going to end up with
-5y plus 1.
Oh, Kitiana, see you have your hand up. Tell me, what's going on?
Sir, you kind of lost me at the last part where you have the 1 plus 2 minus 2 plus sine square. So it's right there, you kind of lost me how you cancel out it.
Okay, so I kind of simplified. So, and we could agree that 1 is a constant, 2 is a constant. Oh, by the way, this is not a constant, right? Because it being multiplied by the sine square theta. So forget about this too. So 1 is a number, plus 2 is a number, and minus 2 is a number. You agree?
Yes, sir.
So, and we can say 1 plus 2 minus 2. So you could work that out separately in a calculator. So you can put 1 plus 2 minus 2. And what do you get for 1 plus 2 minus 2? Salma Kichana, what do you get for 1 plus 2 minus 2?
1, sir.
Right, so that's how I got the plus 1 over here. And we group together these two. So if I ask you a question, if you have negative 2x minus 3x, what will be equal to?
1, sir.
Say that again? I'm not hearing you, but if you had minus 2x minus 3x, that would be minus 5x. And so it's the same concept here. I have negative 2 sine squared, and I have minus 3 sine squared. So minus 2 minus 3 is minus 5. And
Okay, sir, I understand now.
Okay, good. So right now we have minus 5y squared plus 1 is equal to 0. And so we need to make y the subject of the formula. So I will move across the plus 1, it's going to turn to minus 1. And then I'm going to divide both sides by minus 5. I'll end up with minus 1 divided by minus 5, which is positive 1 over 5. So y is equal to positive 1 over 5. Y squared. And if I want to find for y, what would I do next? Somebody tell me, what would I do next if I want to find for y? Right now I have y.
Square root.
Right, square root. Now this is a place where a lot of you all are going to make a mistake. Anytime you find the square root, how much solutions do you get?
2.
2, because it's plus or minus.
Positive or negative.
Right. A lot of people would just consider the positive and ignore the negative solution. So over here, you have two solutions. If you're wondering why, let me show you like a common sense approach. If I wanted, so like, let me just say I wanted to get the square root of 16, right? And square root means what number by itself would give me the number on the inside. So 16, and I can multiply 4 by 4 to get 16? Yes or no?
Yes, sir.
And I could also multiply minus 4 by minus 4 to so that is why you have two solutions. So for the square root of 16, you actually have two solutions, 4 and minus 4, because 4 by 4 is 16, and minus 4 by minus 4 is also 16. So when you find the square root of 1 over 5, it's actually two solutions, right? And that's why the question is, 4 marks is crazy, but you need to consider the two solutions, right? So y would be equal to positive root 1 over 5, and y would be equal to negative root 1 over 5. Okay. Cool. So we need to recall what y was. What did we say y was?
Sine theta.
Right. So we have sine theta, and that's equal to the square root of 1 over 5. So again, look at what we're going to do. We're going to find the reference angle. So to find your reference angle, it's going to be, well, in this case, I shouldn't have any problems because it's positive root 1 over 5, right? So you don't have to take the positive of the solution. So you're going to find sine inverse of root 1 over 5 and tell me what you get. Now, for the sake of all your understanding, I want to work it in terms of degrees first, and then we're going to move on. Then I'll show you how to work it in radians, right? So work it in degrees first. Work it in degrees. Let me stick to degrees. I want you to understand the basis first. So find sine inverse of root 1 over 5.
Sir, I think something is wrong with my calculator.
What happened to your calculator?
Sir, I get 26.5.6.
That's correct. I got that as well. Why do you think you're wrong?
Okay.
Tell me why you think you're wrong. Why do you think you're wrong? You're not telling me why you're wrong, but you're correct. You're correct. You did everything right. So alpha is equal to 26.5, and they wanted the answer to 1 decimal place. So that'll be 26.6 degrees. Right. And this is going to be sine theta. Sine theta is going to be negative root 1 over 5. And somebody tell me, since we already found sine inverse of positive root 1 over 5, and we already have the reference angle for this, tell me if I can see that. Because to find the reference angle for this, wouldn't I find sine inverse of, yeah. And you already found that?
So, sir, would we just put a negative in front, negative sign in front, sir?
A negative sign in front. What do you mean? When you're finding, hear this, right? When we find any reference angle, it's always positive. So you see how we have sine theta is equal to negative root 1 over 5? The reference angle will be sine inverse of root 1 over 5, not the negative.
Yes, sir, I just realized. My bad.
So that being said, you don't even need to do this because you already have the reference angle here, right? The reference angle will be the same for both of them. Yes or no? Let me know if you understand that.
Wait,
Yes.
so is the same 26.6 or one is negative?
No, the other one is not negative. Here we're seeing to find your reference angle, and you always find any positive, the sine inverse of the positive.
Yeah.
Yeah, so isn't positive root 1 over 5 this?
Yeah, that is it.
Yeah, so when we find alpha, you're going to find sine inverse of square root of 1 over 5. And this is your only reference angle.
Okay, I see.
So let me say that one more time for the people at the back. when you're finding the reference angle is always, somebody said, reference angle is always
Positive.
Positive.
So you understand that this positive is just root 1 over 5. Cool. So by me finding the reference angle, it will be the same reference angle for both of them. And for the people that don't believe me, I will show you when we finish the question how we get back the same answer. Right? So let we look at the quadrants now, right? So in this situation, we have a peculiar case. We really have a peculiar case. I'll show you what I mean by that. So A, S, T, C. So what's different here is that we want to figure out where sine is positive root 1 over 5, and we want to figure out where sine is negative root 1 over 5. And then the reference angle is the same for both.
Yes, sir.
Okay, so look at what's going to happen, right? So where are my solutions going to be? So, okay, for the first one, right? If I want to get positive root 1 over 5, since it's positive, which quadrants are my answer going to be in?
First and second.
First and second, right? Okay. And for the other one, where are my solutions going to be if it's negative?
The third and the fourth.
Third and fourth.
Yeah. So here what? Let me put down the reference angle. So we know that the reference angle is 26.6. And is that part of my solution set this time? Tell me, is 26.6 one of my answers? Yes, it is.
Yes.
Let's watch, guys. In this case, we're trying to figure out where sine is positive root 1 over 5. So it would be positive root 1 over 5 here. It would. So that's part of my solution set. Right? So that's one of your answers. Okay, let's draw the reference angle in the second quadrant, 26.6. Remind me, how am I going to find the angle here? So I'm going to start off at 0 degrees, and it come like a stop in how much degrees before 180?
26.6.
Right. So my first answer for theta is 26.6. The second answer is going to be 180 minus 26.6.
Which is 153.4.
Right? And that should be 143.4. If I do that mental maths correct. That's the correct answer?
So I got 153.
Yes, sir.
53.
Yeah, because 5 plus 2 is 7, and you take the 1 and place it, yeah. All right, 153.4 degrees, right? Cool. And so in your calculator, if you want to verify if you are correct, this is what you could do, right? I want somebody to tell me where is the square root of 1 over 5. Where is the square root of 1 over 5? Somebody tell me that.
.44.
0.447, right? So guys, when we plug sine, when we plug 26.6 into sine, we're supposed to get what? An answer that's very close to what?
0.447.
0.447.
Do that for me. Go in the calculator and put sine 26.6.
Sir, I got 0.447.
That's correct. Because
my number.
Because you are supposed to get root 1 over 5. And what is root 1 over 5? And 0.447. For anybody that confused by what I'm trying to say, go in on the calculator and put the square root of 1 over 5. You get 0.447, right? Yes or no? You verify that.
What's that, sir?
Say again.
Yes, sir.
Right. And all you understand that when you put sine 26.6, you're getting the same thing. And it's making sense because you're satisfying the equation. You're trying to figure out the angle that would give you root 1 over 5. And so everybody understand that 26.6 is one of my answers. Yes or no?
Yes, sir.
Yes, sir.
All right. And I want to to verify that 153.4 is also one of the answers.
Yes, sir.
When you plug
Yes,
it into your calculator and you get in 0.447, somebody try it. Other than
Yes,
the
sir.
other than the people that get through so far. Put sign 153.4, and if it's correct, you're supposed to get 0.447.
Yes,
Drop.
sir. Got 0.447.
All right, say no more. So we're good, right? We're good. We're cool. Now, in the question, I want to make something explicitly clear, right? In the question, they wanted us to give the solution between 0 and pi, which is between 0 and what degrees? Pi is how much degrees?
180.
180.
So this is actually the solution. If you look it up online and saying this is the solution, right? But I'm going to go a little step further just to show you what would happen in the other quadrants, right? So this is the solution. The answer is 26.6 and 153.4. But you just had to convert it to radians. If you wanted to convert this to radians, remember, if you want to go from degrees to radians, you just multiply by pi over 180, right? Remember that. If you want to go from degrees to radians, you multiply your answer by pi over 180, and you get your answer in radians. Keep that in mind.
Sir, could you do one just real quick because I don't really remember how to do that.
Okay. If I wanted to convert 26.6 degrees to radians, I would just say 26.6, right? And I'm going to multiply that by pi over 180. Yeah. But when you work in the question, you're supposed to work it entirely in radians. That's how I'll show you how to do that just now. Right? But you're supposed to get, for this one, you're supposed to get 0.46. 0.46 radians. Just verify that. If I convert 26.6 degrees, I'm getting 0.46 radians. Is anybody else getting that?
Yes, sir.
So what I want to do, right? I want to put a calculator in radians first and verify that it's working then. So put a calculator in radians, and I want to put sine 0.46. You'll realize you're still getting 0.44. Since we round off even more, you'll get a slightly off answer, but it's still correct, right?
Yes, sir. 0.4439, yeah.
And that's basically 0.44, right? Yeah. But I will show you the proper way CXC wanted. I did the question like this because I know some of them not so good with degrees, and so radians will be held. So I'm trying to explain it in a simple way first, and then we will increase the level, right? So guys, we have the solution for this. So we have the solution for that, right? Now we need to figure out the solution for where is negative. So somebody tell me, where is it negative?
Quadrant 3
Third
and
and fourth.
Right, so I'm going to put on the reference angle there. So 26.6 and 26.6. So like, watch this, eh? That come like I went 180 degrees plus what? This 180. Right. So the other solution would be 180 plus 26.6. So you're supposed to get 206.6. And so let me just draw it in here. Are you all getting 206.6 degrees? Yeah or no?
Yes, sir.
Okay, and that's how I did this one. Let's move on to the angle in the fourth quadrant. So that come like I stop in how much degrees before 360?
26.6.
So to find that angle, I would do what?
360 minus 26.6, which
Right.
is 333.4.
That being said, if I want to test if my answer is correct, I need to plug it into this one, right? That. Yes or no?
Yes, sir.
And we're supposed to get sine theta is equal to minus 0.447. That's what we're supposed to get. So let's verify that. So any calculator, you're going to put Make sure your calculator is on degrees, put it back on degrees, and you're gonna put sine 206.6. 206.6. Just confirm that again, negative 0.447, which is negative root 1 over 5.
Yes, sir.
Right?
Sir, wait, what did you say we should put in the calculator? Sine what?
All right, so watch this, right? I'm showing Ole how to check if Ole get the correct answer. So was the person I was talking, what's your name?
Kitana.
Oh, Kitana. Right. So Kitana. Okay, so you understand that this work in here is to solve this, right? Yeah or no?
Yes.
So sine is negative in the third and the fourth quadrant. So that is how I got these solutions. Understand?
Yes, sir.
So I got 206.6. So if that is correct, and okay, so minus root 1 over 5, if you plug that into the calculator, is negative 0.447. So, Katana, when I plug the angle into the equation, and it's supposed to satisfy the equation.
Yes, sir. Sir, I got the answer, but I didn't hear what you said about the answer. That's why I was wondering, because I was wondering why I got a negative number.
We understand now you got the correct answer because it was negative root 1 over 5.
Yes, sir.
Right. And when you put 333.4 into this, you'll get the same negative 0.447. So you have the correct answer there again.
Okay, sir.
Right? So is everybody understanding the ways of add maths?
Yes, sir.
Okay, word. Add maths genuinely not that hard, it's just like, it's very procedural. I say maths harder than add maths. Once you like understand something in add maths, you just spam it. It's like a spam fire, and it's honestly not that hard. So, Oliver, I'm going to show you the creme de la creme of confirmation, like how to confirm if your answer correct, like for sure.
Yes, sir.
Yes, sir.
Watch
Yes,
this.
sir.
I'm going to show you this, right? Check this. So all you understand that these answers satisfy this equation and these answers satisfy this equation. Yes or no?
Yes, sir.
Yes, sir.
So I want somebody, so we're going to pick an angle from here. So the angle is 26.6, and we're going to pick an angle from here. So I'm going to choose 206.6. Check this out. I'm sure it's some real maths magic. Remember, these answers supposed to satisfy this equation, not? And it's supposed to satisfy that equation. So, look, I want to later plug this exact same thing in the calculator. So sine squared theta means sine theta squared. So you're going to put sine 26.6 squared, then plus 3, cos open bracket 2 by 26.6 close bracket, and that's supposed to be equal to something very close to 2 if you're correct. So check that out.
Yes, sir. 1.99, which is 2.
How bad we is, how bad? Ah, boy. Maths is vibes, eh? Telling you. When you do the correct thing, it's be like, damn, I get it correct. So, guys, I just want to confirm that you're getting something very close to 2. Let's verify.
Sir, you were speaking so fast. I don't even know if I got anything correct.
Okay. Here what I was saying, right? So, Kitana, you see these angles, you see these answers we got? All these answers.
Yes.
They are supposed to satisfy the main equation. So when I plug in the angle into the main equation, I'm supposed to get what?
2.
Right. So I'm plugging in 26.6 into it. So that'll be sine 26.6 in brackets squared plus 3 cos open bracket 2 by the 26.6. So I want you to plug that into the calculator, exactly how you're seeing it, and you're supposed to get something very close to 2.
So I get something very close to -2.
Yes, I get negative, what is this thing? Negative 1.946 some.
Okay, I'll go check that out. I'll go check that. Give me a second. Maybe that is why they specify over this range. But let me check.
I got a positive.
Okay. So there's clearly some confusion. Okay, when I plug in this answer, I'm getting positive. Let me try the other solution. Yeah, I get both of them are getting 1.99. I don't know what again. Yeah. Even when I plug 206.6, I'm getting 1.99, which is 2. Let me send out a tutorial.
So if the calculator in degrees, then after you get the 1.99, but if it's in radians, then you're getting negative.
I was not about to say that, yeah.
Nah, if it's guys, if your calculator is in radians, you'll get something a lot different. A lot different. Way different. You'll get something very crazy. I'm gonna show you how to plug it into the Casio. Okay.
Sir, I got 1.997 and more numbers.
And you're supposed to get what?
2.
So are we good? And 1.99 is
Yes.
basic. Right. Say no more. So I'm gonna send only a tutorial, all right? Because I recognize some people having trouble using the Casio or the Sharp. If you have a Sharp, you're cooked, guys, you're cooked. But I'm trying to help all you, right?
So how you gonna say we cook? We what we to do?
I feel like I should have a lower ban in Sharp, honestly. That being said, I use a Sharp all the way from since I was born to like upper six, and I didn't find it was that bad, but when I got a Casio, I was like, damn, nah, this is crazy. I was missing out. Yeah, so that's a little tutorial for those who are having trouble. And if you have a Sharp, it'll work the same way, the same exact way. So I want to later verify that again too. So for those of the misbelievers, do you all understand why you need to find the reference angle and it needs to be positive? The reference angle needs to be positive so you could locate all the other solutions. You can't find the inverse of the negative answer. You need to find the positive and then locate where your answers are. All right? If you find the cos inverse or sine inverse of the negative solution, you'll just get one solution and you will lose a chunk of marks. So just keep that in mind. For the people who was not getting the 1.99 and for somehow got negative 1.99, are you all getting the 1.99? Let me know. And the guy that was talking and he was saying minus 1.99.
So yeah, I get positive 1.99, but that's when I have it on degrees.
Also, it was really an issue of radians and degrees. I could have swear I get an answer with like a much different like a night and day result a difference now. Like for one year I get like 0 point something something. Didn't expect it to be so close. Wait, you okay, right? You get through. So you understand how these kind of questions. So like let me run through how these kind of questions just work one more time. One more time, right? So with these types of questions, you need to remember that sine squared theta plus cos squared theta is equal to 1. Doing that, you could find for sine, you could find for cos, you could really find for anything. If you see any double angles, you need to write it. You need to write the identity. If you see cos 2 theta, that's cos squared theta minus sine squared theta. If you see sine 2 theta, that's 2 sine theta cos theta. Right. That begins your simplification. Yeah?
Can you please speak slowly, please? Because you speak so fast, I didn't hear one thing you said.
Okay, I'll try to go a bit slower. So the process for this question, these type of questions, you need to know that sine squared theta plus cos squared theta is equal to 1. Using that, you can manipulate the equation to find for sine squared theta or cos squared theta, like this. You understand?
Yes, sir.
Then you need to remember your double angle identities. So cos 2 theta is cos squared theta minus sine squared theta. If you see any double angle identities, you need to replace it with its associated identity. So we saw cos 2 theta, so we replaced that with cos squared theta minus sine squared theta. We saw sine squared theta, so we decided to replace it with 1 minus cos squared theta. After a bunch of simplification, we ended up with minus 5 sine squared theta plus 1 is equal to 0. To make our lives a bit easier, we said, let sine theta be equal to y. So minus 5y squared is equal to minus 1. Well, that's this line over here. You would get this, and you need to move across the plus 1, right? And when you do that, you would divide both sides by minus 5. Cool. And so the negatives will cancel off, and you'll get y squared is equal to 1 over 5. Now, something to keep in mind, when you find the square root, you'll get a plus and a negative solution. Here we're saying a plus and a negative solution. So, I want somebody to remind me, at this stage, I need to find what to get the reference angle. What do I need to find to get the reference angle? I want to make sure nobody will make this mistake in the exam tomorrow. When you find any reference angle, it has to be
the inverse of the positive.
Yes, the inverse of the positive, nothing else. Right. So to figure out where my answer was positive, my answer will be positive in the first quadrant and the second quadrant because everything is positive in the first quadrant and only sine is positive in the second quadrant. Cool. I put on my reference angle. I measure, this could be 26.6. That's one of my answers. I measure again. I see it stopping 180 degrees. I see it stopping 26.6 degrees before 180. So I say 180 minus 26.6. And that is how I got my answers for this. Right. Then we have a negative to deal with. Where is sine negative? It's negative in the third quadrant and in the fourth quadrant. So starting from 0 degrees, it come like I went 180 plus 26.6. That is how I get 206.6. And for the last one, it come like I stop in 26.6 degrees before the entire 360. So I say 360 minus 26.6. So these four are your solutions. 26.6, 153.4, 206.6, and 333.4. If you're having trust issues, here what to do. Plug it into your original equation, and it should satisfy it. And when we plug it in, we get like 1.99, which is 2. So we're good. If there's anybody that's still confused, let me know now so I could try to help you before we finish trigonometry. Michaela, see
Yes, sir.
Wait, sir? Yeah, the guy that was talking, Tama.
Yes, sir. No, yes, when we find it for when sine is positive, which is in the first and second quadrant, right? My question is, how come we end up finding for all 4 quadrants? Is it because we end up with a negative value when it is they depart before we include it with sine?
Check it out, right? And when you find the square root of a negative number, is there a positive solution and a negative solution?
Yeah.
So we need to find where sine is positive, you agree?
Yeah.
I need to find where sine is?
Yeah.
Was that positive or negative?
Negative. That is negative.
So you understand how I get the answers in the first 2 quadrants because sine is positive there.
All right. And after the other 2 because it is negative.
Yeah, anytime you find square root, you get 2 possible solutions, positive and negative.
Okay,
Yeah.
and let's say in an instance we find that we only find in the positive, we only find it for the positive when sine is positive in the quadrants.
Exactly. So if
okay, no problem.
So like if we only got this, then your only answers will be 26.6 and 153.4. If you only got this, your answers will be 206.6 and 323.4.
Yeah, sounds.
Okay, no
Right,
problem.
so listen, right? I understand the last few parts, but you could explain from step 1 to 6, please. That is the part where I was getting to the thing.
Okay, so you understand that any square terms you see, we're gonna convert those to like okay, any square term you see, we could write that as the other trig function. So we know that sine.
Excuse me.
Yeah, somebody was talking.
What if they can they give tan in this equation?
Yeah, you could get tan, but that's like
And what you do if you get tan?
you need to convert tan to sine theta over cos theta. Then you would multiply throughout by sine theta. You'll get a equation with no denominators, and you would try to get it in the form of a quadratic. That's what you could do.
Okay, sir. Okay, thanks, sir.
Yeah, so you can imagine something like tan theta plus sine theta is equal to 0. And then tan theta is sine theta over cos theta. Let me give you a better situation. So like you understand in this example, you would multiply throughout by cos theta, right?
Yes, sir.
You're going to end up with sine theta plus cos square theta, right?
Yes, sir.
Then you would convert cos square theta to sine square theta, and you're going to end up with a quadratic equation you could solve.
Oh, yes, sir.
Yeah. So that's how you would do if you
thanks.
Right. So back to this explanation fast, like really, really fast, because time running by. Anytime the trig that is squared, you could convert that to either sine or cos. Since it's sine squared, you could convert it to cos squared using this. So sine squared theta is 1 minus cos squared theta, right? And cos 2 theta is cos squared theta minus sine squared theta. Matter of fact, let me just do this back real fast. I will just do back the whole thing real fast since I feel like plenty people confused by this. So I'm going to do back real fast, right? So watch, pay close attention. So sine squared theta is 1 minus cos squared theta. So I'm replacing that for 1 minus cos squared theta. Then I have cos 2 theta. Cos 2 theta is this. So I'm going to write plus 3, open bracket, cos squared theta minus sine squared theta. You okay so far?
Yes, everything so far good.
I'm going to move across the minus 2, so that's going to be equal to 0. Right? I'm going to write back the 1 minus cos squared theta. I'm going to expand these brackets. That's going to be 3 cos squared theta. And then I'm going to expand again. So that'll be minus 3 sine squared theta minus 2 is equal to 0. Now, you notice we have plus 1 over here and we have minus 2 over here.
Yeah, I noticed so.
And notice we have minus cos squared theta and we have plus 3 cos squared theta. So my question for you is, what is 1 minus 2?
Minus 1.
Minus 1. Right, minus 1. And what is minus cos squared theta plus 3 cos squared theta? If you're confused, plug the coefficients into the calculator. So put
2 cos squared theta.
Right, so put minus 1 plus 3, you get 2 cos squared theta, right? And we're gonna write back the minus 3 sine squared theta. But what is the issue here? Do we have everything in terms of one function? One trig function? No, so we could convert cos squared theta to sine squared theta again. Remind me, what is cos squared theta equal to?
1 minus sine squared theta.
Right, so if I expand that, I'll get 2 minus 2 sine squared theta minus 3 sine squared theta minus
1.
Notice I have plus 2 and I have minus 1. 2 minus 1 is? Right, so that's how I get the plus 1. And minus 2 sine squared theta minus 3 sine
Minus 5 sine squared theta.
Right, so I think you understand it. Yeah. Right? So, cool. I feel like all are okay. Right? I feel like all are in an okay position. Right? So, that being said, I want to do, I feel like all you need to do any more of these kind of questions, yeah or no?
Start beating up
integration now.
Kinematics.
Okay, before we move on, somebody sent an interesting proof question, so I just want to answer that real quick. Right? I'm going to do that real quick. So after I do this, I'm going to move on to differentiation and integration. For those who are wondering, kinematics is part of part of the calculus. Right? So we will proceed with that next. So I'm going to do one more proof question, and that is it for trigonometry. So we want to prove that 1 all over 1 minus sine x minus 1 all over 1 plus sine x is equal to 2 tan x all over cos x. Okay, so we're going to take the left-hand side. Do we have the same denominator? Yes or no? Somebody tell me, do we have the same denominator here?
Yes, sir.
No.
No, sir.
No, sir.
So the denominator here is going to be 1 minus sine x by 1 plus sine x, which I think all they can recognize as cos squared x, right? So 1 minus sine x into this would be 1 plus sine x, and 1 plus sine x by 1 is 1 plus sine x. For anybody that don't understand, you could do this. You could say 1 minus sine x, 1 plus sine x. You divide that by 1 minus sine x. It will cancel off. You get 1 plus sine x. You multiply it by 1. Bam. That's how it works. Right. So let's move on. Cool. And so somebody tell me why we go over here. You need to put brackets, You need to put brackets. So 1 plus
1 minus. 1 minus sine.
Yeah. You all were correct. You need to put brackets there, by the way. You need to put brackets. So be careful of that. You need to put brackets. Otherwise, you will not get the answer. And so if I simplify this, so I'm going to expand the brackets, right? If I expand the brackets, I'm going to get minus 1 plus sine x. We know by now that 1 minus sine x by 1 plus sine x is in the difference of two squares form, and that will give us 1 minus sine squared x. And guys, what is 1 minus sine squared x equal to?
Cos x.
Cos squared x. Not cos x. Right? Not cos x. Anybody confused? Remember, we said we know that cos squared x is equal to 1 minus sine squared x. And 1 minus sine squared x is the same thing as 1 minus sine x by 1 plus sine x. So we know that this is cos squared x. On the top, could we simplify? Notice I'm seeing 1 and minus 1. Where's 1 minus 1? 0, right? And how much sine x am I seeing on top?
2.
Right? So it's going to be 2 sine x over cos squared x. So what makes this question difficult is the fact that it's similar to the previous question where you had to introduce something new. So all you should see it here. Let me give a little example or something. If you seen it to divide by sine x on both sides?
How you get the 1 minus sine x on top?
Okay, watch this, right? So over here, you're confused by that. Yeah or no?
Yeah.
Okay. 1 plus sine x could go into this. So if it confusing you, do this. So how much times 1 plus sine x could go into that? So you divide it. What are you going to end up with? See anything that can cancel up there?
Yeah, the 1 plus sine x.
And so you're going to remain with 1 minus sine x. And what is 1 minus sine x by 1?
Sine x?
No. 1 minus sine x. Let me ask that question, right? Where's 5 by 1?
5
What is anything by 1?
itself.
Right. So what is 1 by 1 minus sine x?
1 minus sine x.
Right. And since the term has a minus sign in the middle, I need to put it in brackets. It's a binomial term, so I need to put it in brackets. You understand?
Yeah, thank you.
No problem. No problem. Right, so let me keep on pushing. Now again, what makes this question difficult is that you need to see that to get tan x on top and to get cos x on the bottom, you have to divide the top and the bottom by cos x. So this is what you have to do. Some of you probably thinking of breaking the laws of maths here. But surely that will not. Right? On top, 2 sin x over cos x is 2 tan x. And in the bottom, one of the cos x would cancel off with 1 here, and so we remain with cos x. And that's what they wanted us to prove. Now, let me guess, plenty of you are so confused by this. Yes or no? How much are you confused by what I just did?
Yes, sir. I'm confused.
Okay. Let me ask that question, right? Look at what we're trying to prove. Tan x over cos x. So what we know tan x is?
Sin x over.
Right, tan x is equal to sin x over cos x. So if you notice, I have sin x here, right? So what I could do is I could divide the top and bottom by cos x. Because notice, we had to get cos x in the denominator. So if I divide both sides by cos x, this will turn to tan x, and this will turn to cos x. Yeah, you see that?
Yes, sir.
Let me say that one more time. Let me reload. No, they wouldn't get that joke. All you know the joke where Tanti Kamala say, load up the matic and knock it on them. You know about that?
Yes, sir.
No, but if you're from Jamaica, I don't think I'm gonna know about that. Yeah, I don't think they're gonna know about that. But anyways, we have tan on top and we have cos on the bottom. So to get the tan, we would have to divide by cos x, because sine over cos is tan. And in the bottom, I would divide by cos x, because cos squared x over cos x is cos. That's it. And I'm not breaking any laws on maths, because watch this. If I have 4 over 4, if I divide the top by 2 and the bottom by 2, and that'll be 2 over 2, which is still 1.
Yes, sir.
You're allowed to divide the top and bottom by a same number, and you're also allowed to multiply the top and the bottom by the same number, or the same two. So that's how you handle a question like this. So take a screenshot of it. I'll give you only a 10 minutes break, and then we're going to move straight into differentiation, integration, and kinematics. Yeah.
Yes, sir. So this thing is hot in my head, by the way. Breathe.
Trigonometry?
Yeah, these proofs, not the other trigonometry. You fix them up with the alpha and thing. You fix them up with that thing.
Nice. That's this. Yeah, it's not so easy. It requires like real practice to get it.
So in the beginning, you cross multiply that how you get the equation there.
You never cross multiply. You can't cross multiply in these questions. You can't cross
Because
multiply.
I'm still trying to figure out how you get the 1 plus sin x, and I seen like I could see that is the multiply the 1 by the sin x on top there, if you understand what I'm trying to show you.
You tell them like, let's tell them.
Yeah. Like what I see and like what I confused.
Okay, let we look at a simple example. Imagine you had a half minus a quarter, right? What's the LCM for that?
Eight. 1 and then 2 minus 4.
Wait, where's the LCM between 2 and 4?
I don't know.
4.
4.
Right, because 2 could go into 4 and 4 could go into 4. So 2 into 4 is 2, 2 by 1 is 2, 4 into 4 is 1, 1 by 1 is 1. It's the same exact concept over here. So to get the LCM, you multiply the denominator by each other, right? So 1 minus sin x by 1 plus sin x, and then 1 minus sin x into this leaves you with 1 plus sin x, and you multiply that by 1. 1 plus sin x by 1 is 1 plus sin x. Then 1 plus sin x into this, the 1 plus sin x would cancel off with the 1 plus sin x, and then you're left with 1 minus sin x. 1 minus sine x by 1 is 1 minus sine x. But you have to put it in brackets.
All right, okay, I see what you're talking about now.
Is the same concept as this. But what you're saying is like a commonly taught shortcut. So like you see this over here? What you could do is you could just multiply the 1 by the 1 plus sine x and the 1 by the 1 minus sine x. So what you're talking about is like a little math trick. But you could do that for these kind of cases. Yeah. So you could do what you're saying, you know. It's just that you need to put the brackets here, right? Don't ever forget that. Don't ever forget that. Right? Don't forget the brackets.
All right, okay.
All right. So
So, what my what my lessons teacher did, right? I don't know, like if this makes sense or if it'll make it easier. From the line where you have 2 sine x over cos squared x, you can't just simplify it to say 2 sine x over cos x multiplied by 1 over cos x. So the 2 sine x over cos x would simplify it to 2 tan x.
like, that's sounding a little more complicated, you know. But that is
So she just divided by cos.
well, no, but that's why I do though. Isn't that why I do?
Yes, but she the way she said it, so she said she multiplied by 1 over cos x, which is the same as divided by cos x.
But isn't that what I did here? Isn't that what I did? Watch. What is 2 sine x multiplied by 1 over
Oh
cos x?
yes, sir. Yes, sir. I'm just saying that she might have thought it was different because of
Oh,
the format written in.
Also, I understand, right? But like, will you get the same amount of marks if, like, instead of doing the work and you just skip like all of that and just write the answer? Like, that's what I mean.
yeah, you're gonna lose marks because you had to show that you had to divide both sides, top and bottom by cos x. You need to show that working. If you just jump straight to this, you're gonna lose like if the question is like what 5, if it's 4 marks, you're gonna get like 1 mark, 1 or 2 marks. You need to put it. So what your lesson teacher did and I did is the same thing, right? What we did was we divided the top and bottom by cos x. In other words, multiply by 1 over cos x. You can see it. So on top we have 2 sine x. And so what I did was I divided it by cos x. And in doing that, n sine x over cos x is tan x.
Yeah.
Right. So that's how we got the 2 tan x. And in the bottom, nth we divided cos squared x by cos x.
Yeah.
And we got the cos x. Bam. So yeah, the same method. You okay?
Yeah, I understand.
Okay, good. All right, so take a 10 minutes break, guys. And we're gonna jump straight into differentiation and integration and kinematics. Yeah. All right, so if you know any friends that needed help with differentiation and integration, let them know. We're gonna start off the thing just now. All right, let me send all of these notes in the meantime.
Here we got K number.
Chat, we ready to cook? Come on, guys.
Yes, sir. Start back the fire.
All right, all right. You know the song Old Fire. I'm gonna finish the whole song there. But you know that song?
No, sir. Check out the song in there.
Raw Baby. No, it's not my Raw Baby. Some chutney artist. Yeah. I don't want to talk.
Okay, next to tell me the name.
I don't want to talk about rum too much. Next thing the foreign people think I'm an alcoholic teaching maths. Yeah.
You have to be a little mad to like maths at this stage now, you know, sir. Not gonna lie. I used to really like maths. Now you feeling like I turning into a madman.
Well, if I show you the maths I just do for fun, you go ball. If I show you that, you'll be like, nah,
So,
man.
and this coming from the same fellow who has sleeping however many days now.
Yeah. That's me. That's me. Yeah. Only thing
You really have to be mad to like maths.
only thing trigonometry hard in regular maths. I'm not sure how is it in pure maths. So you know how you had to learn double angle formula, you had triple angle formula and thing here. Yeah. But like I don't find this hard anymore. It's just like once you understand the processes, like you just spamming that on you, you're good. It's really not hard.
So it's not hard, it's just tedious. And there's a lot to remember.
I wouldn't agree. I wouldn't agree with the is a lot to remember part. Because as I showed you guys, a lot of stuff you could figure out. You don't necessarily have to remember. It's only if you can't figure it out, you have to remember it. But a lot of stuff you could figure out.
Nice news.
Right? But the formulas is a lot. But over time, once you do it, it becomes second nature. Right? All right.
You teach physics too?
Yeah, I teach physics, maths, art maths, pure maths, some like tertiary courses. A lot of things, yes. Yeah,
Okay then.
I have a physics crash course next week, and I have the physics marathon. The crash course is $400 for 4 sessions. That's like 4 hours each, and the marathon obviously is free. Same thing like this, from like 4 p.m. to 4 a.m. Yeah.
Sir, 400, like, which money? US, Jamaican, what?
Dollars, TT dollars. TT dollars. Yeah. Yeah. TT dollars, eh? Not US dollars. Matter US dollars.
Okay, sir.
US dollars would be insane. I'll be a millionaire then. Right? All right, so let me keep talking it out. Right? So I'm gonna give all you a little introduction to everything you need to know in differentiation. Let me go. Part 2. Round 2. So differentiation, you need to know that differentiation is basically the same thing as gradient, right? So when you find the function dy dx, you need to know that you're finding for the gradient function. The gradient function. And when you find dy dx and you plug a value for x into it, you're not just finding the gradient function, you're finding the gradient of the tangent, right? This will come in handy soon. Gradient of tangent, right? Okay. You also should be able to remember the quotient rule. But before we move on, let me just show you the basis of differentiation. So let me just say we have a function y is equal to 7x cubed plus 3x squared plus 5x plus 2. If we want to differentiate this, look at how we write the notation. We're differentiating y with respect to x. So I'm going to write dy over dx. And to differentiate, you're taking the power multiplying by the number in front, and then you're minusing 1 from the power. It's really quite simple. So this will become 21x to the power 2. This will become 3 by 2 is 6. 6x to the power 1. Now, you're probably wondering, well, what does happen if I have something like 5x? Anytime you have something like this, when you differentiate it, you end up with the coefficient. So 5. And when we differentiate all constants, we get rid of them. Is everybody okay?
Yes, sir.
Yes, sir.
Okay, word. So let me do a harder example now. They could do this as well. They would just say we have a function like root x all over x. What are we going to do then? Now, to differentiate, it should be in the form. So when you're doing differentiation, you could only differentiate when it's in the form ax to the power n. So what do I mean by ax to the power n? I'm talking about like 7x cubed and thing now. Right? Where you have some x term to a power. So guys.
Wait, sir.
Yeah?
You kind of lost me.
Okay, here what I'm saying, right? Here what I'm saying. When we differentiating, and you just multiply the power by the number in front and minus 1 from the power. And you just do that. Okay, I'll go backtrack a little bit. I'll backtrack a little bit, right?
Sir, you don't need to go that far. You lost me from the part right where you start to differentiate.
I promise it like real simple. Let me do another simple example, right? You and me, we could do a simple example. So let me just say y is equal to 2x squared plus 4x plus 8. To differentiate, you're taking the power. What is the power here?
2.
You're taking that and you're multiplying it by the number in front. What's the number in front?
2, so that would be 4x.
And you minus 1 from the power. Where's 2 minus 1?
1.
Right. If I differentiate in something in this form, you just write back the coefficient. Where's the coefficient of 4x?
4.
And anytime you differentiate a
And
constant,
then you'll just get rid of the 8.
I'll get what? I'll leave out the 8.
Then the 8 normally it would just be a 0 after you differentiate it, so you wouldn't write that.
Yes, correct. Guys, in case all was ever wondering why when you differentiate constants it just be 0, I'm gonna blow some all in mind. So for the people that like maths, are they gonna be like, damn, I never see that before? Or maybe you did. When we differentiate, we find in the change in y over the change in x. The change in y over the change in x. That's also why gradient, dy dx is gradient, because gradient is the change in y over the change in x, right? But when we find dy dx, we want to see how y changing with respect to x. So let me ask that question, right? Kitana, that was you that was talking, right?
Yes, sir.
Does the 8 ever change? Does 8, okay, 8 is a constant, is a number. Could 8 ever change?
No.
Sir.
No. Because it's a number, because it's a constant, it cannot change. So when you differentiate it, the rate of change is 0. That's why dy dx for a constant is 0, because constants don't change. So that'll be 0. Yeah. But you can just remember that when you differentiate a constant is 0, you can just do that. Right? So Kitana, you understand this example, right?
Yes, sir.
Let me do one more that's semi-simple before we move on to harder examples. What about if we have minus 3x to the power 4 plus 2x to the power 2x to the power 3 minus 8x squared plus 2x plus 4. That only looking hard, you know, but I like so easy. So tell me, what is the power? What is the power there?
4.
So we're going to multiply 4 by?
-3, which will be -12x. So the
minus 1.
3.
Right. Then you're going to take the power and multiply the power by the number in front. So 3 by 2 is?
6x squared.
Right, you're going good. Over here now. So, what is the number in front here? Kitana, what's your number in front there?
8. Negative 8.
Negative 8 by 2 is?
Negative 16.
Negative 16.
X.
Right? And that will be plus?
2.
That's it. Was that hard? Really? Was that hard?
No, sir.
No, I tell you, you could do it. So if you didn't know how to differentiate, now you know. This is the basis of differentiation. So I hope you understand that. Where
Sir,
did
someone asked where the frog.
I've seen a lot of people say that the power 1 is understood. Yes, you don't need to put the power 1 but for explanation's sake and for making sure everybody understands it, I'm putting 1. But yes, if you have x, that's understood to be to the power 1, right? It doesn't kill to write x to the power 1. Nothing's wrong with that. So somebody asked where the 4 went. Anytime you differentiate a number, the number becomes 0. So really, I should write plus 0. So to the person that said that on the chat, Tommy, I like how you're thinking, right? So yeah, the constant doesn't change, so it's 0. Yes. Right? So to the person that's confused, just simply remember it like this. A constant doesn't change, so when you differentiate, it becomes 0. Right? But I won't write plus 0 because it wouldn't make sense to write plus 0. Why would I write plus 0? 0 is nothing, so I could just leave out the 0. Right? So I'm gonna start to introduce negative powers and things. This is where I start to lose students. Right? So don't get scared. Let me take it one step at a time. So what if I had something like x to the power minus 3 plus 2x to the power minus 4 minus 3x to the power minus 1? How would I differentiate this? And I'm gonna add plus 10. How would I differentiate this?
Minus 3x to the power 4. And then you'd have to put it in the denominator for the power to become positive.
Right, but I'm gonna differentiate first, and then I'm gonna write it in that form you're talking about, right? Right?
All right, sir.
Okay. So the girl that was confused about differentiation. Kitiana, I wonder if you understand what I'm doing, right? So minus 3. The number here is understood to be 1. So minus,
sir.
is minus 3. Then I take away 1 from the power. So where's minus 3 minus 1? Minus 3 minus 1 is? Can I hear it?
Sir, what, sir? What did you say, sir?
Don't we take away 1 from the power?
Sir, you realize that you did that one on the board already. You have the negative 3x minus 4.
Right, but I want to make sure you understand how you get negative 4. Do you understand?
Yeah, you plus the 1 to the minus 3, and positive plus negative of it, you're going to get
No, that's not
negative.
how.
No, sorry, sir.
Negative.
It's going to be added to it.
No, you're minusing 1 from the power. So negative 3 minus 1, that's negative 4. That's how it works. You're taking away 1 from the power. I guess you could think of it like that. You're adding negativity, right? Let's do this one here. What is 2 by minus 4? Two by minus 4 is minus 8. You can plug that into your calculator. Then we're going to minus 1 from the power. So if I minus 1 from the power, it'll become minus what?
5.
Right? What is minus 3 by minus 1?
Positive 3.
Right? And if we take away 1 from this power, it'll become negative.
1.
So it's negative 1 minus 1. What is negative 1 minus 1? Negative 2, right? Plug that into your calculator. Negative 1 minus 1 is negative 2.
Yes, sir.
And when we differentiate the constant, it'll drop. So this is like level 2. I trust that everybody okay with level 2. If you're not, let me know. Right? Anybody don't understand level 2? And some people might say you could simplify this further, and you can. So let me recall back the rules for indices, right? If I have a negative power, let's just say I have x to the power minus, wait, I'm going to use numbers first. If I have 5 to the power minus 1, anytime you have a negative power, you need to send it to either the bottom or the top. So 5 to the power minus 1 is at the top and it's negative. So you'll take it and you'll bring it to the bottom. And when you carry it to the bottom, it's now going to become 5 to the power 1. So how does that fit in to these questions? Let me show you what I mean. So this over here, notice the x is raised to a negative power. If x is raised to a negative power, the x is not happy over here, the real vex. So it'll move to the denominator where it will become positive 4. So this will be negative 3 all over x to the power 4. Let's do the other one. So we have minus 8. X to the power minus 5 is negative at the numerator, so it'll become positive if it's at the denominator. Yes or no? Tell me if you understand that. Rules for indices.
So I understand this, but the top part is here. I know it's the same thing, but yeah.
Sometimes they ask for the answer like this, right? And plus 3 all over, we're moving down x to the power minus 2, so it now becomes x to the power 2. Cool. Is everybody okay? Kitiana, let me know if you're okay with that. Yes, no?
Yes, sir. I think so.
All right. So let me move on to level 3, where things start to get interesting. Right? So after level 3, we're going to look at some simple questions, right? And then we're going to look at product, quotient, and chain rule. All right. So a really hard example. Now, guys, just remind me, from the rules for indices, if I have the square root of x, what is the square root of x understood to be? X to what power?
X to the power minus 2. No, a half and the minus 2.
Right. If I have the cube root of x, what is that understood to be? X to what power? So if the square root of x is x to the power half, the cube. A third, right?
1/3.
So the general formula is that n square root of x is equal to x all over 1 over n. Right. If I have something like 1 over x to some power, if I take it and I bring it up, the power is going to become negative. So these are the rules for indices, right? If I have the same base and I am multiplying, what do I do with my powers? I have the same base.
Add them.
Right? If I have the same bases and I'm dividing, what do I do with the powers?
You minus power.
Right. So if I had x to the power n over x to the power m, I could write that as x to the power n minus m. Right. So you'll need to know these for the examples that we're about to do. So let me give you all a couple of questions. Let's find the square root of, no, let's find the derivative of the square root of x over, now let me just give all of that and x to the power and 1 over x squared. Right. So if we look at this example here, we can't differentiate just yet because we need x to be to some power. So remind me, the square root of x is x to what power again, guys?
Half.
X to the power of a half.
Now, x squared is in the denominator. If I want it to be on top, I'll need to bring it up. But if I bring up x to the power 2, it'll now become x to what power?
Negative 2.
Negative 2. And so now we could actually differentiate. So it's the same steps. It's the exact same steps, right? So I'm taking the power and I'm multiplying it by the number in front. This is understood to be 1x to the power half. So 1 by a half is a half. Then I'm going to subtract 1 from the power. What is a half minus 1?
Negative 1.5.
negative a half, right? And if I do this question, do this one now. I want somebody to help me. Kitiana, I want you to help me. What is the number understood to be in front? Plus what?
Once, sir.
So if I multiply plus 1 by minus 2, it'll now become?
2, sir.
It'll now become minus 2, right?
Yes, sir.
X to what power?
-3, sir.
Yeah, negative 3. So here what? If they ask you for the answer with no negative powers, you need to take all the negative powers and send it to the denominator. So let me explain something real quick. So you notice that x is negative in the numerator, so we'll send it by the 2 in the denominator. So that's now going to become 2x to the power a half.
Wait, excuse sir. When you had differentiated, right? The power to the half there, that is not supposed to be power to 3/2 because you're supposed to add 1.
No, watch. You have a half.
Right.
When you differentiate, you minus 1 from the power. What is a half minus 1?
Oh, okay. I thought it was minus half. Sorry, my bad.
Right? And over here, notice that the power is negative, so I'll send it to the denominator. So that'll be 2 all over x to the power 3. But you can go even further because we know that x to the power a half is the square root of x. Okay, did I lose anybody severely? Let me know. Did I lose anybody like real bad? No? Right. Kitchano, let me know if I lose you real bad. Oh, you're good.
Excuse me, the last part needed.
No, this is sufficient. This is sufficient. You can leave your answer like that, right? This is
No, sir, I mean like the last equation.
Oh, this over here?
Yeah.
All right, it's in third form. It's not necessary.
Yeah.
Not necessary. That's like extra. If you can do it, do it. If you don't know how to do it, then forget about it. Just do this. Just leave it at that. Right? So seeing somebody asks, explain the 2x to the power a half. Chance. By chance, you could unmute. Yeah.
Yes, sir.
Okay, Chance, as you talking there?
Yeah.
All right, so what confusing you?
How you get the 2x to the power of half?
Okay, so you understand that this is a negative power, right?
Yeah.
We're going to send it for it to become positive.
The denominator.
Wait, have any denominator?
Oh, I really didn't even see that. I can't lie.
Yeah, so I just send it there by 2. That's it. Light work.
Okay.
Right. So let me do some CSEC questions now. We can do some CSEC questions now. Right? So before we move on and we start the CSEC questions, just remember that when you find for dy dx, you are finding for the gradient of the what? The gradient of the?
Tangent.
Right, you're finding for the gradient of the tangent. And that being said, I think we can now do some questions. Just keep this in mind, right? Gradient of tangent. And I would also advise you all to keep in mind y is equal to mx plus c. All right, keep those things in mind. So let's do some past paper questions one time. Right. So I want you all to go through. I'm sure you guys have the past papers. Go through and see a simple question we could do before we do the really hard questions. Yeah. Okay, I didn't hear anybody give me a question, so we're gonna run through and check the questions out. Right. So
Everybody shutting off now, so you're gonna have to start pulling out questions you have in your bank.
Right. I think I see where you're trying to get at. You think I know what coming in the paper tomorrow?
No, not really. I just praying. I pray to God I do my best, get a good mark, and sleep good. And I have 2 exams tomorrow, so after I cut off 11, I'm going to start studying for geography at 12.
All right, well, let me move fast then. So the point P lies on the curve Y. Find equations for the tangent to the curve and the normal to the curve, right? So let me go. So remember what I said. When you find the first derivative, you are finding for the gradient of the tangent at the given point. So this would be at x is equal to some value. When you differentiate, you find the gradient of the tangent. Now, remind me, the normal and the tangent are related to each other through what relationship? How are the normal and tangent related to each other?
Perpendicular.
They're perpendicular.
Perpendicular.
So let me just say the gradient of the tangent is negative a half. What the gradient of the normal go be?
2.
2.
So all you're doing, you're finding the negative reciprocal. And there's a fancy way for saying flip it and change the sign. So if we flip this, it will be minus 2 over 1. And if we change the sign, it's just 2 over 1, which is just 2. Okay? So I think we okay. I think we're good. So let me do the question now. Right? So with what we did just now, we could get 5 marks. So let me go. So we have an equation y is equal to 3x squared plus 5x minus 12. Right? And they want me to find the equation of the tangent. I need only to recognize that the tangent is a line and the normal is a line. Now to find the equation of a line, what are the 2 things I need? I will start a little off. You need a gradient, and what else you need?
A point on the line.
Right, you need a gradient and a point on the line. Are they giving us a point on the line?
Yes, sir.
Yes.
And we know now that differentiation is gradient, so we could find the gradient by finding the first derivative. So dy dx will be equal to what? Somebody differentiate that from a fast.
6x
plus 5.
Right, 6x plus 5. Cool. And to find the gradient of the tangent, I'm going to plug x into that. Now, some of you all might see different notation, but this is how textbooks have it, and this is how I learned it. So a vertical line, and you put where you're going to plug in, and you plug it in. Right? So I'm going to plug in, what's in 1? X supposed to be equal to 2. Can somebody tell me why x has to be equal to 2? Why is x equal to 2?
Because it's the point P, and P is 2 times.
Right. So let me just explain that for everybody that confused. So when you want to find the gradient of a tangent, you're finding the first derivative, and you're plugging in the value for x given any point. So we have a point here, x is 2 and y is 10. So we want to find the gradient at x is equal to 2. So you're going to define the first derivative, and then you're going to plug 2 into that. Right. So we have it, guys, we have it. 6 by 2 is 12, 12 plus 5 is 17. So this is the gradient of the tangent, m subscript t is equal to 17. Right? So is everybody okay with that? Is anybody confused by how I got the gradient of the tangent? Yes or no? Anybody confused at all?
Wait, the gradient is 17, right?
Yeah, the gradient is 17. 6 by 2 is 12, 12 plus 5 is 17.
All right.
And that's the gradient for the tangent. When you find the first derivative, you're finding the gradient function for the tangent. Right? So we know what the gradient is. Do we have a point on the tangent? What is the point on the tangent?
2 times.
Right. And what is the equation of a line?
Y equals mx plus c.
Okay, so now I'm going to find for c. Finding for c is the next step. So my x value is 2 and my y value is 10. So I'm going to plug in 10 for y. So guys, this is more so maths than anything. The gradient is 17. My x value is 2 plus c. So 10 is equal to 34 plus c. So if I want to find for c, I move across 34. So c is equal to 10 minus 34. What is 10 minus 34?
24.
No, 10
Minus 24.
Negative 24.
Negative 24. For those who get confused by this line, this is what you could do, right? So you could actually flip it. So I could write 34 plus C is equal to 10. And I think this is in a format where most of you all could see it. So I will just move across the 34 and that'll be 10 minus 34. The C minus 24. So everybody okay with how we got the C value? Yes or no?
Yes, sir.
Right. So
Yes, sir.
now we recall that the formula for a line, or the equation of a line, is y is equal to mx plus c. So we know that the gradient is 17, and we know that the y-intercept is minus 24. And that's the answer. It was that simple. Easy? Easy 5 marks? Yes or no?
Yes, sir.
Yeah, easy 5 marks. So now we need to find the equation of the normal to the curve. So let me find the equation of the normal of the curve now. It's not much different. Right? Could somebody just tell me what they're saying in the chat? Is everybody understanding? In the chat? Does anybody have questions?
Doesn't look like, sir.
Say that again.
It doesn't look so.
Okay, it doesn't look so cool. So here what? Let me find the equation of the normal now. So here I'm saying that the equation of the normal is the negative reciprocal of the gradient of the tangent. So if the gradient of the tangent is 17, 17 is the same thing as 17 over 1. So flip that and change the sign. That'll be minus 1 over 17. Is anybody confused?
Yes, sir.
Wait, you can repeat that back, please?
Okay, so the tangent and normal, the gradients are the negative reciprocal of each other. Negative reciprocal of each other. So what does that mean? If the gradient of the tangent is 17, I want you to flip that and I want you to change the sign. So it's positive right now, so I'll apply a negative sign. Understand?
Yeah.
You sure? I'll note about it here. Right? I'll put it in brackets, negative reciprocal. All right, so guys, if all you could look in the diagram, I would see that the point that they gave us passes through the tangent and the normal. So I could just plug in that point and find for C and write my final equation. So the point again was 2, 10, x is 2, y is 10. So again, I say y is equal mx plus c. My y value is 10. My m value in this case is minus 1 over 17. My x value is 2 plus c. So I'm going to say 10 is equal to minus 2 over 17 plus c, right? So if anybody is confused, I'm going to flip it around, right? That'll be minus 2 over 17 plus c is equal to 10. To find for c, I have to move across the minus 2 over 17. So c is equal to 10 plus 2 over 17, which is 172 over 17. I think. Check that.
You say you could expand out a little bit, please, so I could see the top.
Yeah. Say no more.
Yes, sir. 117. 172 over 17.
Right. What is my final equation? Y is equal to? What was the gradient of the normal?
Negative 1 over 17 x plus 172 over 17.
Bam. Now, guys, if they ask for the answer in a form that does not have any fractions, what would I do? How would I get rid of the fractions here?
Multiply by 17.
Multiply by 17 throughout.
Right, so that will become 17y, which is equal to minus x plus 172. Right? So anytime you end up with an answer that's fractions, and they ask for the answer in a specific form, or they ask for the answer without fractions, you do that. You multiply by the common denominator. In this case, both of them are 17, so it makes our life very, very simple. Right? So take a screenshot of this, and we will keep figuring it out. All right, so that's an easy 5 marks, guys. And they don't bring anything hard to differentiate either. They're really easy to differentiate.
So just leave it at 17y?
17y is equal to minus x plus 172. If they ask,
That's the answer right there.
Yeah, if they ask for it in a specific form, sometimes they go ask for it in this form, right? Well, check it out. Sometimes they go ask for it in oh god, my Apple Pencil dead. That's crazy. I will call it out, right? While it charges. It's charged fast, don't worry. What if they wanted it in the form AY plus BX plus C is equal to 0? What would I do? If they want the answer in the form AY plus BX plus C is equal to 0, what do you think I ought to do with that? Tell me, guys.
So not just minus
You would have
EY.
to carry across the y and equate the entire thing to 0.
Right. Now, I was more so thinking to move across the minus x and the 172, but that's correct as well, right? So if you want to put it in the form ax plus by plus c is equal to 0, you would move across everything to one side after you multiply by the common denominator, right? So I want somebody to finish out the working and send it on the chat while my Apple Pencil charges. I don't know.
Awesome. Draw on the screen in the meantime.
Yeah, I could draw on the screen. Somebody do that. So what I would do is I would move across everything to the left-hand side. So that'll be 17y. If I move across negative x, that'll become plus x. If I move across the 172, that is minus 172. And that is equal to 0. Did anybody not understand what I did? And this is if they ask you for it in the form ay plus bx plus c is equal to 0. Let me know if I let go with that. Yeah or no? Anybody confused?
Sir,
Yeah, Talma?
I understand that part, sir, but when you go back over to the left, sir, at the end part
To find for c?
where, yes, sir,
Okay.
the last part. I don't know how I'm lost, but I know I'm lost.
All right, so which part are losing? Yeah, 1, 2, 3, 4, or 5?
Four.
Okay, so you understand how I invert the left hand side and right hand side, right? To get minus 2 over 7.
Yes. Yes, sir.
So I want to find for c. So if I want to find for c, I just want c on the left hand side. So I'll move across the minus 2 over 17.
Right? We also have a quotient rule that you need to be familiar with.
If I move across minus 2 over 17, what's that going to become?
Plus 2 over 17, sir.
Right, so you get 10 plus 2 over 17, right? And in the calculator, I want you to put 10 plus 2 over 17 and tell me what you get. You get 172 over 17.
Sir, something really wrong with my calculator.
That's
Hold
okay.
on.
If you have a sharp, you will not get the answer as 170. I'm not sure. I don't have a sharp, I can't see. But you have a Casio?
No, sir.
No?
Wait, what did you say?
You have a Casio calculator. Do you have a
Yes, sir.
Okay, when you plug it in, you're supposed to get this. If you're not getting this, press the S to D button. Press the S to D button. So get to the right, S to D. Press the S to D button.
Oh, okay, sir. I see.
Right? So everything is clear?
Yes, sir.
All right. Nice. Now, let me see what percentage my Apple Pencil reach. 28. Okay. Right. We could keep on moving. So I trust that everybody okay with this. All right. So this is how you handle any question like this. Cool. I'm going to move on now. All right, guys, do you all know first principles? Yes or no?
Yes, sir.
Okay.
Long formula. Let's make everything long.
Right. So
Long time.
It come in 2024, so I want to go over it in case, right? So let me do the question real quick. So use the definition of the derivative as a limit to find f prime x for the function f of x is equal to x squared minus 3. Now, if we had to differentiate that normally, wouldn't that be f prime x is equal to 2x? And yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Right. So what is the formula they're talking about? They're talking about this formula. The limit as x approaches h for f of x plus h minus f of x all over h. That's what they're talking about. If you never see this before, drop a 1 in the chat. Not much teachers as teachers. Right? How much shall they say in 1? Ooh, that's scary. Right, so I'm gonna run through this quick. Stay with me because it's very easy to get lost with this. So to find the limit, you first need to plug in, you need to find for f of x plus h. And to find for f of x plus h, that's something like you would do in maths. So recall that f of x is equal to x squared minus 3. So then f of x plus h would be equal to x plus h all squared minus 3. Now that would be equal to x plus h by x plus h minus 3. And so now we need to expand. So to expand that, I'm going to say x by x, that's x squared. X by h is xh. H by x is xh. And h by h is h squared minus 3. Okay, to simplify that, I'm seeing two xh's. So that'll be 2xh, right? Plus h squared minus 3. Right, so I know what f of x plus h is. I'm going to plug that in here. Wait, I made a little mistake here. It's supposed to be as h approaches 0. Right? H approaches 0. And so I'm going to replace the f of x plus h for what I just now found. So that's x squared plus 2xh plus h squared minus 3. Now we need to take away that from f of x. So that's going to be minus x squared minus 3 all over h. Right? So now we need to look to simplify. Are you seeing anything we can simplify on top? Well, before I do that, I should probably expand. So if you notice, we have a negative sign on the outside. So if I distribute the negative throughout the terms, that's going to be minus x squared plus 3. Let's look to see if we can simplify the top. So on top, you see x, you see in minus x squared. So those two terms will cancel off. Right? So x squared minus x squared is 0. Right?
Sir, and the 3.
Yeah, you see any 3 too? Right? And so we end up with 2xh plus h squared on top all over h. On top, you see anything that we could factor out on top?
H.
The h.
Right, so h. I would pull out 2x. I mean, if I pull in out h, I would be left with 2x on the inside and plus h on the inside, right? All over h. So now you can recognize that the h and the h would cancel off. And so I'm very close to my final answer here. So I'll have 2x plus h. And in this final line where you factored out and you canceled off, you can now plug in h is 0. So we're going to say that h is 0. And if h is 0, that's going to be 2x plus 0. So we get 2x. So did we get the correct answer? Because if we differentiate this normally, you get 2x. Did we get 2x?
Yes, sir.
Yeah, we got 2x. Somebody was saying something? Now, truth be told, I wouldn't focus on this too much because they brought it last year and a lot of teachers complained. But I'm teaching it just in case CXC notice and they bring it back again, right? And now we need to answer part 2. Hence, determine the value of f double derivative 5 or f second derivative 5. So you have to find the second derivative now. So in the previous part, we found that f prime x, or the first derivative, is equal to 2x. So now I need to differentiate a second time. So if I differentiate 2x, what am I going to get?
2.
No, let me ask you a question. 2 is our what?
Constant.
So no matter what I plug in into this function, it's going to remain. Since 2 is a constant, no matter what I plug in, it'll remain.
It's gonna remain 2.
It'll remain 2 because there's no x term for me to plug it into. And so that's why this question was a kind of stupid question, right? The answer is 2 because no matter what you plug in, there's no x here for you to plug it in into, so your answer remains as 2. A simpler way to look at it is 2 is a constant, so it will remain unchanged. So f double prime 5 is 2, and that's how you handle this question. So I want to take a screenshot of this. I doubt it's gonna come, but we do it just in case. So take a screenshot of this fast. Take a quick screenshot of that. Right, and send it on the chat. So I want
So
to
I have
know.
a question.
Yeah, Salma.
So I understand the entire process and everything, with what you did just now. So, but just a query. So why can't you just replace h with 0 from the get go? Like,
Why I could not replace h with 0 over here?
yes.
If I replace h with 0, I'm gonna get something divided by 0. Can we divide by 0?
Oh no.
That is why you see me try to factor out the h term so I could cancel it off, and then I could plug in 0. Yeah. So that's typically how these questions go. You need to simplify, factor out the h, cancel it off with the denominator, and then then substitute h for 0. Understand?
I said thanks, sir.
No problem. So take a screenshot of this, send it on the chat fast. I want to move on to product, quotient, and chain rule. All right, so I'm guessing somebody take a screenshot. Right? I'm gonna move on.
Yes, sir.
All right, let me get a question real quick. Okay. Questions here way too easy. All right, I'm gonna show you the product rule, and then I'm gonna show you the quotient rule, right? Quick. So anytime, so you typically don't use the product rule, right? We don't use the product rule, but the product rule is essentially how we would differentiate the product of two functions. So if I want to differentiate a function u by v, it's going to be equal to v du dx plus u dv dx. Now I know some of you all would have learned it the other way around, and both of them are equally correct because addition is commutative, right? So u dv dx plus v du dx means the exact same thing as v du dx plus u dv dx. You're probably wondering, well, okay, if that is the case, why am I learning it like this? Because when we do the quotient rule is in a very similar format. Can somebody tell me the formula for the quotient rule?
V du dx minus u dv dx over v squared.
So all you understand why I'm saying to remember the product rule like this, so that there's no room in your head to mix up this, because you can't mix up that because it's a minus sign, right? Cool. So that's the formula for the product rule and the quotient rule. Product and quotient. All right, so is everybody okay with that? Let me know.
Yes, sir.
Okay.
Yes, sir.
I'm going to do the chain rule real quick, and then we'll do a question involving everything. So how do we do the chain rule? The chain rule is actually quite a process. We use the chain rule whenever we have expressions raised to a very large power. So you would use the chain rule. Let me just say I have something like y is equal to x plus 5 to the power 8. Are you all going to go in the exam and go and multiply that by itself 8 times and then look to differentiate? Are you going to do that? Yes or no? No.
Nah, this is a let you equal situation.
Right. So you're not going to expand x plus 5 by itself 8 times. You're not going to do that. So in the chain rule, you let whatever is inside the bracket be equal to u. So I'm going to say let x plus 5, everybody is unmuted. If you're not talking, please mute your mic. Right? So we're going to say let x plus 5 be equal to u. Or I should write it like this. I'm going to say let u be equal to x plus 5. And if u is equal to x plus 5, what is y going to be equal to? So I'm saying that x plus 5 is u. So what is y now going to be equal to?
U to the power
Y is
e.
equal to u to the 8.
Right. So that being said, we now have two different rates of change. I promise it's not difficult. Let's do it. So over here we have u, and over here we have x. So this is going to be du dx. If I differentiate x, what am I going to get? 1, right?
1.
And over here, I'm going to differentiate y with respect to u. So that's going to be what?
8 u to the power 7.
Right. Again, it's the same concept. You're multiplying by the power, and then you're taking away 1 from the power. But our original expression had y and x in it. So we want to actually find dy dx. So on to the actual chain rule. The chain rule is used to link different rates of change together. So dy dx can be written as dy over du multiplied by du dx. Can you see it? Because the du and the du will cancel off, and that would give you dy dx. So do we know what dy du is?
Yes, sir.
Right? dy du is 8u to the power 7. And do we know what du dx is? What was du
It's
dx?
1, sir.
Du dx was 1. So our final answer, well, the second to last step, it would be 8u to the power 7. But I want somebody to remind me, what did we say u was? What was u equal to?
X plus 5.
U is equal to x plus 5.
My final answer then would be dy dx is equal to 8 by x plus 5 to the power 7. Is anybody confused by that?
So couldn't we also have just went about doing it as per usual? Couldn't we have just multiply the entire bracket by 8 and then say 8 minus 27?
Hold our thought. You're talking about the shortcut method. And you need to use the shortcut method whenever you have a question where it's product rule and chain rule. If they give you a question and it's strictly chain rule, you need to do the full working, otherwise you will not get your marks. So again, if the main focus of the question is chain rule, you do this. If the main focus is not this, then you do the shorthand version of the chain rule. So I'm going to run through the shortcuts. So the shortcut version of the chain rule is this. So to find for dy dx, you are going to take the power, bring it in front, you're going to differentiate the inside. If I differentiate the inside there, it's 1, right? Then I'm going to minus 1 from the power. And so I'll end up with 8 by x plus 5 to the power 7. Does anybody need me to run through back the shortcut method?
Yes, please.
Okay.
Yes, sir.
Right. So in the shortcut method, you're taking the power, bringing it in front. So I'm taking 8, I'm putting it in front, then I'm differentiating inside the brackets. If I differentiate x plus 5, what am I going to get?
One.
I'm going to get 1, right? And then I'm going to write back what was inside the brackets, and I'm going to subtract 1 from the power, so 7. If you simplify that, 8 by 1 is 8, and that's how I get my answer. Is everybody okay with that?
So why you write back the 1 from the bracket?
Say that again?
Why you put back the 1 from the bracket?
Talking about over here.
Yes, so like the x plus 5, why did you put it back if you already differentiated it?
Okay. So you see the long method? Check the long method, right? You understand the long method? Yes or no?
Yes, sir.
Okay, so the shortcut method, is just a long method, but summarized. And so when you do the long way, you get back x plus 5, but you minus 1 from the power. So that's just simply the process, right? That's just simply the process you have to follow. So I'll do another example, and I hope that clear up the confusion. So take a picture of this quickly. I'll take a picture of that quickly, and I'm going to move on. All right, as soon as the screenshot is taken, let me know so I can move on. Did you all take a screenshot?
Yes, so you could go ahead.
Okay, let me move on to some other examples. Let me just say we have a function y is equal to x plus 8. Now, let me change it up a little bit. 2x plus 8 to the power minus 3. So we're going to do the shortcut method, right? To differentiate this, I'm going to put the minus 3 in front, right? Put in minus 3. Then we're going to differentiate the inside. If I differentiate the inside, what am I going to have? If I differentiate 2x, right? Brackets, but I'm going to minus 1 from the power. What is minus 3 minus 1?
-4.
-4.
Right? So your final answer is minus 6 by 2x plus 8 to the power minus 4. And that's your final answer. If you wanted, you could write minus 6 all over 2x plus 8 to the power 4, but you don't need to. That's it. So since we are familiar with a shorthand version of the chain rule, product and quotient, let's do a past paper question now. Let's waste no time.
Sir, my question is, we won't lose mark if we do the shorthand?
Okay, let me tell you a little when you have to do the shorthand version. If the question is primarily asking you about chain rule, you'll need to do the full working. If the question is chain rule and product rule, you need to do the shortcut. So let me show you an instance where you would have to do the full working, right? Let me show you an instance. So in this instance, you need to do the full working. So in this instance, we have y is equal to the square root of 5x squared minus 4. First of all, let's rewrite it. So remind me, guys, square root is what power? If I see something in the square root, what is the of square root?
A half.
I can write that as 5x squared minus 4 to the power a half. Did I lose anybody? Yes or no?
No, sir.
No. In this question, can we recognize that the only thing we have to do is chain rule? If chain rule is the only thing you have to do for the entire question, you do the full working. So we'll have to do the full working over here. So the full working for this, we would say, let y, no, I cannot jump any line there. We would say u is equal to 5x squared minus 4. And if u is equal to 5x squared minus 4, what would y be equal to?
U to the power of a half.
Right. And we would find for du dx, to find for du dx, that would be equal to, you would take the 2 multiplied by the 5, and you get 10x minus 1 from the power y, we get 10x. Over here, we're going to differentiate y with respect to u. So we're going to multiply u by a half, and then we're going to minus 1 from the power. So if I minus 1 from a half minus 1 is negative a half. So that being said, now I could do the chain rule. So the chain rule says that if I want to get dy dx, I could multiply dy over du by du over dx. If you're confused and you're not seeing it, watch du and du will cancel off, and that would give us dy dx. Right. So we found dy du earlier, and that was a half u to the power minus a half. And we are multiplying that by du dx. What is du dx?
10x.
10x, right? So look at what's happening. We have a half by u to the power minus a half by 10x. So I'm going to say a half of 10x. What is a half of 10x?
5x.
Right? And I'm going to, so it's 5x multiplied by u to the power minus a half. Remind me, what was u? What did we say u was?
5x squared minus 4
Right? So that'll be 5x squared minus 4 to what power?
to the negative a half.
Yes, and that's the answer. So in this question, the only thing you had to do was do the chain rule. So you needed to do the full chain rule, right? Full chain rule. That's how you know. If we wanted to check if we're correct, we could do the shorthand version real fast. So I take the half, put it outside. If I differentiate the inside, it's gonna be 10x, and if I minus 1 from the power, I'll get negative a half. Is that the answer we got? Yes or no? Let me know if that's the answer we got.
Yes, sir.
Yes.
Right.
Yes.
Now I
So
wanna
just one question. If we solve it, like if we solve it later, would it be 5x over root 5x squared minus 4?
yeah, you take the words right out of my tongue, or out of my mouth. So they're saying simplify your answer, right? So that is not as simple as it gets, right? So you need to recall the rules for indices, like you said. So remember what I said. I say if you have a negative power, you need to send it to the denominator. So this will be written as 5x all over 5x squared minus 4 to the power of half. And if you have something to the power of half, you should know by now that that's square root. So the answer, as simple as possible, is 5x all over the square root of 5x squared minus 4. And that's your final answer. Right? So, nice. So take all the screenshots and we're going to move on. So we're going to do, the next question is going to be a question where it's a product and chain rule type question. Chance, if you know the shortcut and you can't remember the long method, do the shortcut, lose some marks, but at least you'll get some marks. I'm not saying that in a bad way. Honestly, just try to get marks. Try to get marks. Yeah. Right, so does somebody have a screenshot of this?
Yes, sir.
Okay.
Yes, sir.
Let's move straight on to our question where we need to do the product and the chain rule. Right, this is a question where you would need to use the chain rule and the product rule. All right. So in this question, you guys notice that is a product, right? And so you can see is a product. We have 1 plus 2x cubed by x plus 3. Yes or no?
Yes, sir.
So this is u and this is v. So u is equal to 1 plus 2x to the power 3, and v is equal to x plus 3. Now, guys, look at this question. The main focus is not chain rule, so you can't do the shortcut. Actually, you have to. Otherwise, you're going to take up way too much time. So to find for du dx, we're going to apply the shortcut method, right? So we're going to take the power, bring it in front, then we're going to differentiate the inside. If you differentiate 1 plus 2x, what are you going to get?
2.
2.
I'm going to write back 1 plus 2x, and I'm going to subtract 1 from the power. So that's going to be 2. So my final answer is 6 by 1 plus 2x to the power 2. That's my answer for du dx. Right, let's find for dv dx now. dv dx is quite simple. What would dv dx be equal to? Somebody tell me.
1.
1.
Well, you understand, right? Question is product and chain, you do the shorthand version. If the question is just chain rule, you do the long method. There's one other instance of chain rule. I need to show you sine a of x. I mean sine ax, right? Just remind me of that. You need to know sine ax, cos ax. Cool. So we're going to use the product rule. The product rule says that if you have the product of two functions, it's v du dx plus u dv dx. Some of you all might be asking, well, sir, in school, I learned u dv dx plus v du dx. Well, both methods are equally correct because addition is commutative, right? And you could flip the order. So somebody tell me, what is v? Fast, what is v?
X plus 3.
What is du dx?
6
By 1 plus 2x to the power of 2.
Right? What is u?
1 plus 2x to the power of 3.
Right? And what is dv dx?
1.
1. So if I expand this, I'm going to get 6x plus 18. And this is our part that's confused people real bad. So stay with me. Plus 1 plus 2x to the power 3. Guys, how much of you are confused by doing this? Come on now. Confuse anybody by that?
Sir,
Yeah, tell me.
I'm not confused by it, but before we could go to that step and we could factor out 1 plus 2x squared because both of them even there and that will make it easier to multiply out and get a better result.
Yeah, that's correct. So he saw it. You have 1 plus 2x squared there and you have 1 plus 2x cubed there, right? So that being said, the greatest common factor is 1 plus 2x squared because 1 plus 2x squared could go into both 1 plus 2x squared and 1 plus 2x cubed. So I'm going to factor out 1 plus 2x squared. If I factor out 1 plus 2x squared, what will I be left with on the inside?
One plus 2x.
No, I'm factoring out 1 plus 2x squared. So over here we had 6x plus 18 multiplied by 1 plus 2x squared. So in other words, what do I need to multiply by this to get back this whole thing?
6x plus 18.
Right, I would need to multiply by 6x plus 18. So if anybody confused, we're factoring out 1 plus 2x squared. If you factor out the 1 plus 2x squared, you'll be only left with 6x plus 18. Right? If I factor out 1 plus 2x squared from 1 plus 2x cubed, what will I be left with?
1 plus 2x squared.
No, not 1 plus 2x squared. Let me ask that a question. What would I have to multiply? 1 plus 2x squared?
Yes, sir, my bad.
Okay, would. See, you understand that. And on the inside, I could drop the brackets and simplify, right? So 6x plus 18 plus 1 plus 2x. So on the inside, we are seeing 6x and 2x, so that's 8x. 18 plus 1 is 19. Are you okay up to this point? Now, if you
Yes, sir.
if you want and you're crazy, this is acceptable. If you want and you're crazy, you could expand this out and then you could multiply it by 8x plus 18. Right? But this is acceptable. This is good. This is typically how they want the answer. Right? So if anybody is confused, let me know. Yes or no? Confused, yes or no? Have plenty places here to get confused. Plenty places.
So from the top of it, right, you could just explain everything over like in a short way.
Okay, so you're seeing that we have 1 plus 2x cubed by x plus 3, right? That's an example of a quotient, a product, a what?
Oh, sorry, yeah, there's a question we doing now.
No, this is a product. Watch.
A product, yeah, product.
A product means we're multiplying two things by each other. So we're multiplying 1 plus 2x cubed by x plus 3. So NT would say that it's any form u by v. So this is u and this is v. Because we're multiplying something by something. So we're multiplying u by v.
Yeah, I understand that.
So I say u is equal to 1 plus 2x cubed Now, enter can do the shorthand version of the chain rule.
Yeah, because you shorter.
So I take in the power, bringing it in front, I differentiate the inside, and I write back, and I take away 1 from the power. You good?
Right, yeah, good.
So I get 6 by 1 plus 2x squared, right? V is equal to x plus 3. So I differentiate down, I get 1. Because if I differentiate 1x, that's 1. Yes or no?
Yes.
Okay. And so now I'm going to do the product rule, right? So the product rule is v du dx plus u dv dx. So what is v? V is x plus 3 multiplied by du dx. Du dx is 6 by 1 plus 2x to the power 2. Yes or no?
Yeah, yes.
And then we're going to multiply that by u. U is 1 plus 2x to the power 3 by dv dx. dv dx is 1. 1 by anything itself, right? So we got back 1 plus 2x cubed here. Understand?
Yeah, understand.
So we have x plus 3 here multiplied by 6. So the 6 is going to distribute throughout all the terms. So 6x plus 18, right? And we have the 1 plus 2x squared in brackets plus 1 plus 2x cubed in brackets. And you notice that we have common factors here. Over there we have 1 plus 2x squared, and over there we have 1 plus 2x cubed.
Yeah.
So the greatest common factor we could pull out is 1 plus 2x squared. If I pull out 1 plus 2x squared from this, I will have 6x.
You get 6x plus 18, then you have the one other 1 plus 2x.
Right? And then on the inside, I drop the brackets and I simplify. And this is the answer.
Okay, I understand now.
Right. So guys are trusting that all you understand that. I trust him. I really trust him. Right, so now I'm going to show you how to differentiate something like sine AX and cos AX. Now, these questions typically come in a similar format where it's a product and a chain. So I'm going to show you the shorthand version, right? So let me show you what I'm talking about. So we have questions like watch, like this. Right. So guys, in this question, can you all see that we are multiplying this term by this term? Yes or no?
Yes, sir.
Right. So I want to show you quickly how you would find the derivative of sine 5x. I'm going to show you the full method and the shortcut method. Right? Very fast. And it's the same process for cos, so I'm not going to run through that. Later into the night, when I finish the session, I'll be awake. If any of y'all do questions, I want help, send it to me. I'll be going all out tonight. I'm going all out. How to get that 102. So if I want, just remind me, guys, if I find the derivative of sine x, what is the derivative of sine x?
Cos x.
Derivative of sine x is cos x. What is the derivative of cos x?
Minus sine x.
Minus sine x.
Right, so my question is, how would you differentiate something like y is equal to sine 5x? If you have to differentiate something like sine 5x, again, it's very similar to the last question we did. The full method is very similar to it. What do we have inside of the brackets, guys? Tell me, what do we have inside of the brackets?
5x.
Right, so we're going to say let u be equal to 5x, and then we're going to say v is equal to what? Sine what? If 5x is u, we're going to say y is equal to sine?
Sine u.
Right, because this whole thing going to become u. So now we need to find for du dx. What is the derivative of 5x?
5.
5. And the derivative of sine u is cos u, right? Cool. So again, we apply the full chain rule. The full chain rule is dy dx, right? dy dx is equal to dy du by du dx. Right? What is dy du? Wait, I made a little mistake. Actually, I didn't make a mistake. In this question, they said y was equal to sine 5x. If they are saying y is equal to sine 5x, okay, yeah, I did make a mistake. Where did I make a mistake? This is supposed to be, yeah, this is supposed to be y. I don't know why I put v there, right? So this is supposed to be dy du. Yeah, sorry about that, guys. So, minus that mistake. Everybody understanding everything so far? Everybody following? Let me know. Yes, no?
So
Yeah? Okay. So, somebody tell me fast. What is dy du? What is dy du? dy du is cos u, right?
Plus u.
And we're going to multiply, going to put that in brackets. And we're going to multiply that by du dx. What is du dx?
5.
5.
Right? So we're going to end up with 5 cos u. And what did we say u was?
5x.
5x.
Right. So if they bring a question and it's just differentiate cos 5x or sine 5x, this is how you do it. This is a full working. That being said, let me show you all the shortcut. The shortcut for this is you're going to differentiate inside the brackets. So if I differentiate inside the brackets, what is that going to be equal to?
5.
Right? 5. And then we're going to differentiate sine. If I differentiate sine, what am I going to get?
So cos.
Right? And all right, back to 5x. That's it. Let me do one with cos now. If I had cos 5x, take your time here, guys. Take your time. So if I differentiate the inside, that's 5. But this time, if I differentiate cos, what am I going to get?
Minus 9.
Right? And in the brackets, I'm going to put 5x. And so my final answer is minus 5 sine 5x. So what you have to do, you have to differentiate inside the brackets, multiply by that, differentiate the trig, and write back what was inside the brackets. So that's a shortcut method. Cool. So is everybody okay? I'm going to give you all the chance to take the screenshot of this, and we'll move on. All right, so take a screenshot of this real quick and send it on the chat. All right, guys, send it in the AdMass chats, right? Okay, so send that real quick into the chat. Somebody send that quick, so I can move on. Right. Anybody gonna send it?
So, do you have a next chat aside from Math Vibes? Or just Math Vibes?
AdMass Marathon chats. You
No,
know,
I'm not in that chat.
serious?
No, I just in the Math Vibes.
That's crazy. That's crazy. Let me add it real quick. I'll just send it on the chat. Yeah, just join that real quick and send it fast. So let me move on, right? Let me move on. So in this particular question, look at C, we have 2x squared plus 3 by sine 5x. So if I want to differentiate this, that's clearly a product of terms. So u is equal to 2x squared and v is equal to sine 5x. So somebody, tell me fast, how would I find for du dx? Du dx is what?
So
4x.
2x squared plus 3.
No. You confusing integration and differentiation. In differentiation,
Oh yeah. No sir, I mean you left out plus 3 when you put what you was.
I left out plus 3, which part? Oh, yeah, I know what you're talking about. I see that. Sorry. Right? If I differentiate that, what will I get?
4x.
Right? 4x. If I were to differentiate this, remind me, we know the shortcut now. So we're going to differentiate 5x. That's 5. Differential as sine as cos. We're going to write back the 5x. Cool. So remember that d dx uv is equal to v du dx plus u dv dx. So I will get v is sine 5x by du dx is 4x, right? Plus u is 2x squared plus 3 by dv dx. dv dx is 5 cos 5x. So that's going to work out to be 4x sine 5x, right? Plus, see this 5 here? That 5 is going to expand throughout this term. So that's going to be 10x squared plus 15, close bracket, cos 5x. That's how you handle a question like that. So, anybody is majorly confused?
So you can just go over how you expanded the 10x squared plus 15 cos 5x.
Sure, not a problem. So over here, I could write that whole thing as 2x squared plus 3 by 5 by cos 5x. Yes or no? Tell me if you understand that.
Yes.
So we're seeing a 5 on the outside. Anytime you have a term on the outside, whether it's here or here, doesn't that mean we have to distribute the 5 across all these terms?
Yes.
Right, so 5 by 2x squared is 10x squared, and 5 by 3 is 15. So yes, that's it.
Okay, thank you.
Right, I'll leave it there so nobody will be confused. Cool. Cool. So take a screenshot of this fast, and we're gonna move on to all you want to do a quotient rule question, yes or no? Or you want to move straight into stationary points? Let me know.
Stationary points, sir.
Stationary point.
Okay, let me dive straight into stationary points. No love for quotient rule. Yeah, nobody quotient rule don't really come. Or is it really don't come? So let me go straight into stationary points.
So you're saying I don't come, but watch and see it go and come.
Nah, it's not gonna come. I swear my life on it. I so sure I'm not gonna come. And if quotient rule come, you could convert quotient rule to chain rule and product rule. Watch. If I have something like, if I have 3x plus 1 all over 5x plus 3 to the power 5, if I wanted, I could write that as 3x plus 1 multiplied by 5x plus 3 to the power minus 5. So there's really no need to learn the quotient rule. None. Because I could take the quotient rule and convert it to the product rule and move from there. Yeah. Did any of you guys know you could do that? Yes or no?
So I know now.
I know now.
So you learn a new thing every second, yeah.
Yeah, so because I enter doing everything mathematically correct. Watch. I taking this, I bring it up to the top, I change the sign for the power, and bam. We know how to do that. That's real easy. Right? You use the chain rule, shorthand version of the chain rule for that. So when you're finding for U and V, U will be 3. Well, du dx will be 3. Somebody fast, tell me what dv dx could be if you do the shorthand version of the chain rule. That's gonna be minus 5 multiplied by
Minus 5.
minus 5 by 5. And then, right? I'll lose it. But the shorthand version of that would be minus 5 by 5x plus 3 to the power minus 6. So that'll be minus 25 by 5x plus 3 to the power minus 6. That's it. So guys, all you know how to do product, quotient, technically, chain rule, find tangent, and normal. So now we're gonna do stationary points. So, and the second derivative, right? So when we do in stationary points, let me draw a curve here. Somebody tell me, what's the gradient for this section? Positive or negative?
Positive.
Positive.
What's the gradient for this section?
0.
Section.
Negative.
So when we're talking about stationary point, we are saying that the gradient is 0. This is the stationary point. So at the stationary point, and all you should know by now that another word for gradient is dy dx. Right? So dy dx will be equal to 0. Yeah. And the other thing you need to know is, you need to know that when you find the second derivative, so d2y dx squared, so if you find the second derivative, so this would fall under nature of stationary points. Right? So this would fall under nature of stationary points. if you want to figure out the nature of the stationary points, you have to look at what d2y dx squared is. So if d2y dx squared is more than 0, meaning that it is positive, it's happy. You're happy. And if you're happy, you're smiling. And so that's a maximum or minimum?
Minimum.
Right.
Minimum.
Cool. If the second derivative, right, is less than 0, then that means negative, and it means a maximum. What? What do you mean, buddy? Yeah. Maximum. Okay, so with that being said, that's all you really need to know for stationary points. So now we can do past paper questions, right? And let me see how much all is math scholars, right? Does anybody know what would happen when the second derivative is equal to 0? What happens when the second derivative is equal to 0? You don't need to know it, but does anybody know it?
In the second, oh my gosh.
Yeah, you have a point of inflection. A point of inflection is where you have a change in gradient. So a point of inflection will be over here. This could be the maximum and this could be the minimum. Yeah. All right, so let me do past paper questions one time. Take a screenshot of this and let me go.
So when it is this the second derivative, right? You mean double differentiation?
Yeah, yeah. So you differentiate once,
Okay.
you differentiate twice, d2y dx squared. Or f double prime x.
Alright, no problem.
All right, so you could move on there.
All right, cool. So let me start some questions, right? So let me start off with this one. This is a nice one. So the person that was talking just now, let me do this question. So they want us to find the coordinates of all the stationary points for the curve y is equal to x cubed minus 5x squared plus 3x plus 1. So let me do part 1. So remind me, at the stationary point, what do we know? What is it that we know?
dy dx is equal to 0.
That being said, we would need to find for dy dx. So the derivative for that would be 3x squared. And tell me the rest. 3x squared
Minus 10x plus 3.
right. Okay. And we're going to put that equal to 0. So we're going to put that equal to 0. And somebody tell me, what is that in the form of? This is in the form of a what?
A quadratic.
Right. Plug that into the Casio and let me know what you're getting for x. Right? Just make
So again, 3 and a 2.
3 and a 2. Okay. So let me just factorize it real quick. To get 3x squared, that's 3x by x. To get 3, that is 1 by 3. And I want to get negative 10x, so that'll be negative there. Right? So if I work that out, 3x minus 1 is equal to 0. Right? X minus 3 is equal to 0. So x would be equal to a third, right? And x would be equal to 3. You get that, right? A third and a 3. Let me know.
Yes, sir.
If all you're having trouble with factorization, don't let that hold it back. Just plug it into your calculator and find for x, right? Yeah. Now they ask for a point. Guys, does a point have an x value alone? Yes or no?
No, sir, it also has a y.
No, sir.
So here what we're going to do, right? We're going to plug x into what equation to find for y?
Into the curve.
Right. So you're going to say y is equal to a third cube minus 5 by a third squared plus 3 by a third plus 1. Plug that into the calculator and let me know what you get. Right? And while somebody do that, I want somebody to do the other one. So y would be equal to 3 cubed minus 5 by 3 squared plus 3 by 3 plus 1. Let me know what again for that. Somebody say,
So when x equals 3, I got -8 for y.
oh, for 3, right? All right. -8 for y. I'm waiting for somebody to tell me what you're getting for the fraction.
So I got 40/27.
Let me just verify that real quick. One momento. So a third. You get 40/27?
Yes, sir.
Yeah, that's correct. So I'm gonna blow all your mind. I'm gonna show you like a real go-to trick. Like, let me just say in the exam, or you forget how to find the nature of stationary points. I have all your back, don't worry. I have all your backs. So that being said, I want to let you tell me the points. What are the points? Tell me the first point. Third,
A third and 40/7.
right? And tell me the other point.
3 and negative.
3 and
Right, so let me show you something real fast. So if I were to plot those points, I'm seeing that the y value for this point is positive. So what that means is that it's going up to a positive value and it's going up to 40/27. And then this one is going down to -8. So what do you think this is? A maximum or minimum? Without doing anything, that's a maximum or minimum.
A maximum.
And right, that's a minimum. Yeah, so that's a little trick. You just do like a really fast sketch, or you just, so guys, all you're doing, you're comparing this and this. Whichever one is bigger, whichever y value is bigger, that's the maximum. Whichever y value is smaller, that's the minimum. Cool. So I'm going to show you how to do the way they want, which is the, of course, is the second derivative. Right. Right, so to find the nature of each of the points, you need to find the second derivative, right? So you need to find for d2y dx squared. So what that means is we're going to differentiate dy dx. So locate dy dx. So I want somebody to differentiate that from again. So differentiate dy dx. What are you going to get?
6x minus 10.
Right? And so what I'm going to do is I'm going to plug in the values for x for the different points. So that's going to be d2y dx squared. I'm going to plug in, I take it into that. And so that'll be equal to 6 by a third minus 10. You should get 8, minus 8. Right? And for the other one, that's equal to when x is 3. Right? 6 when x is 3. That will be equal to 6 by 3 minus 10. And that should give you plus 8. And this should give you negative 8. Somebody just confirm that.
yes, sir.
Right, so we're going to say since d2y dx squared is less than 0 for a third, 40/27, the point is a maximum. Remember, if it's negative, you're sad. Right? And over here now, you're going to say the opposite thing. So I'm just going to copy and paste this real quick. So since d2y dx squared was more than 0, you're smiling, so it's a minimum. So I would say that this is another easy set of marks. This one easy. So this is like, it's easy. You'll get this marks for sure. Right? So take a screenshot of this fast, and we're going to move on. If you have any specific stationary point questions or you want me to do? Any specific ones?
So I just have a question, right? When you're doing it with the d2y dx squared, you still need to factorize the quadratic and get the x values.
What quadratic?
The 3x squared minus 10x plus 3.
Check this, right? If we are differentiating this a second time, differentiate that from a.
6x minus 10.
That is it, you know. That is it. And you're gonna plug in the values for x into that. That is it. Understand?
I know, but like, well, what I mean, like the values we have to plug in into the equation, we still need to factorize the quadratic to get them.
I hear you talk about factorize a quadratic, but I'm not sure what you're talking about. You're talking about like over here?
Like, yeah, to get the x values, like x equals a 2, then x equals 3.
Yeah, you have to factorize. So in the previous part, you'll have to find for the stationary points. And to find for the stationary points, you'll need to factorize, or you need to plug it into your calculator and get the values for x. Once you have the values for x, obviously you need to find the y value. You know how to find the y value?
Yes, sir.
Okay, and so from the previous part, we have the values for x. And so those same values for x is what we're going to use over here, right? So does that answer your question?
Yes, sir, thanks.
Okay, no problem. So take a quick screenshot of this. And yeah, all you have any specific questions, all you need me to do with all you?
Yes, sir, you could check out June 2019 5A.
Okay, no problem. All you go on like hold all your hair and like pull it real hard. That question not easy. Right? I knew it was gonna say 2019. I knew it was gonna say that. Could I
Have to check it out, yeah.
smell it from a mile away. Right? So let me do 2019 real quick. I like people like you know, you like some hard questions. Yeah, nice. Right? Okay, I selected 2018 by accident. Oof. We get 2019. 2019. Right. All right, so who is this? Who am I to do 2019 now?
Alexa, sir.
Alexa, turn on the lights.
I know you was gonna say that, you know.
Waiter. Alexa, turn off the lights. Oh, right. So let me proceed.
So my Alexa listening to you.
Say that again.
My Alexa device, she's like listening to you and doing your commands.
That's crazy.
That's happened to me too.
That's so infuriating. Imagine you have like a burglar system and somebody say, "Hey Alexa, activate the burglar system," and like a bunch of guns just start firing off and like you're dead.
Yeah.
Real. I went dark. But anyways, let me do this question here. So the stationary points of a curve are given by 5, 11, 2/3, and 3/15. Derive an expression for dy dx. Now, for this question, we need to work backwards. And so I'm going to pull a question from my question bank to explain this question. Right? So that would have been section 3. So favorites, maths. Section 3. Right, so I need to explain something very, very carefully so that I don't lose anybody because this question is hard. So we need to work in reverse here. Right. Was not a question. Okay, I want you to look at this question and then we'll appreciate the other question, right? So find the coordinates of the stationary points of x cubed minus 3x squared minus 9x plus 5. You understand how to do a question like this? You find the first derivative, you put it equal to 0, right? Yes or no?
Right.
Right. And so essentially in 2019, you have to work backwards. So notice something. We got 3x squared minus 6x minus 9 is equal to 0. Notice, what did I do?
You divided by 3.
Okay, and I get x squared minus 2x minus 3, and I factorize, right?
Right.
Okay. Hold that thought. I really want you to hold that thought. Right? So again, keep this step in mind. The fact that I'm dividing by 3. Yeah. All right. So in this question, they are giving us the stationary points. So from the stationary points, and I can figure out that x is equal to 5 and x is equal to 3.
Mm-hmm.
So guys, I need all you to understand that we're just working in reverse, right? So if given x is equal to minus 1 and x is equal to 3, and I would then proceed to go to this line, and then I would proceed to this line, and then I would proceed to go to this line. So it's from this line to this line that's going to lose plenty people. So let me do it. So x equals 5 is the same thing as x minus 5 is equal to 0, right? And x minus 3 is equal to 0. So that's going to be x minus 5 by x minus 3, and that's equal to 0. Right. So now we need to expand. If I expand that, what will I get? Tell me, if I expand that, what am I going to get? You have to expand that.
X squared.
Right, x squared. Tell me, x
Would
squared.
it be minus 3x?
Right, minus 3x. Then you multiply it minus 5.
Minus 5x plus 15.
All right, let's simplify this. So, what is minus 3x minus 5x?
Minus 8x.
Now, some of you might be very tempted to say, yes, this is dy dx, totally. This is definitely dy dx. But that's wrong. We left out a step. Look at this question, right? Look at this. Again, when we want to find dy dx, we find the first derivative and we put it equal to 0. But in that stage, hence we could divide throughout by a constant to simplify the expression.
Yes.
Right.
Yes, sir.
When we are doing this, we need to multiply by a constant to undo, like to go back in reverse now. So that will be ax squared minus 8ax plus 15a is equal to 0. Right. And that is dy dx. Yep, I know it's not easy. Let me know how.
Seriously,
Yeah, tell me.
how do you know when it's multiplied by a constant?
You don't know, but you need to cater for it. Hear what I'm saying? You don't know, but you need to cater for it. Why do you think when we do indefinite integration, we put plus c? The reason for that is because imagine you had an expression for y, right? And y was 5x plus 8. If you differentiate that, what's going to happen to the 8? Tell me, what's going to happen to the 8?
Oh, we cancel out. Like,
It will go away.
So now if I integrate that, if I integrate dy dx, right? If I integrate dy dx, which is integral of 5 dx, and integration is supposed to undo differentiation.
Yes, sir.
And then I'm supposed to get back 5x plus 8. They're going to notice something. I'm not going to get 5x plus 8. So the fact of the matter is, I need to put plus c in case you would have lost any constants in the process. So it's the same concept over here. If you look at the process in reverse, sometimes you could divide by a constant throughout to get your answer. To verify this, we'll need some conditions, right? And I'll get to the conditions. But let me know if you understand. We're catering for it in the event that it happened.
Yes, sir. I understand.
All right. Right. So, Alexa, did you understand this? Let me know.
Yes, sir. It was made clear. Thank you.
Okay, cool. So let's move on to the other question. So what do they want us to figure out in part 2?
The nature of the points.
How would we find the nature of the points?
The second derivative.
Find the second derivative, right? So let's find the second derivative. So what would d2y dx squared be? Somebody tell me, what would d2y dx squared be equal to?
2ax minus 8a.
2ax minus 8a, right? So let me hear some suggestions. What would you all do next? What would you guys do next? Alexa, what would you do next?
I would plug in one of the x points from the curve.
Right, so let's do that. So we have x is equal to 5 and we have x is equal to 3, right? So let's plug in x is equal to 5 into that. So if I plug 5 into that, that's going to be 2 by a by 5 minus 8a. What am I going to get? Tell me, what am I going to get? What is 2a by 5?
10a.
10a
Right?
minus 8.
And if we simplify that, what are we going to get?
2a.
2a. Now, guys, this is the part that, again, is going to confuse a lot of people. You have to make an assumption here. So, if you look at the word in reverse, right? Notice we divided by a what? What constant? Positive or negative?
Positive.
Negative. Positive.
Whoa, 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 whoa. You're thinking too negative. You have to be positive, right? So there are two cases for this answer. So you could say that if x is, okay, so guys, if x was a, right? So if x was a, I mean, what's saying? If a was a positive number, what would this case be? Right? If a, well, I have to say assuming a was more than 0, that would make the point 511 2/3 maximum or minimum?
Minimum.
Right.
Minimum.
Because if a is more than 0 by 2 is a positive number, and so this would be a minimum. Right, let's keep pushing. Okay. And so for the other one, I'm going to plug in, what was the other value for x? X was equal to 3, right?
3. Yeah.
Okay, so I'm going to plug in 3 into 2ax minus 8a. So that's going to be 2a by 3 minus 8a. 3 by 2 is 6a minus 8a. We're going to end up with what? What is 6a minus 8a?
Negative 2.
Negative 2a.
So guys, if we assumed that a was a positive number, for this case, we're going to get a negative, right? Because if a is a positive number by a negative number is a negative. So this point over here would be, we would assume it to be a negative. That's 3,15. Right? And that would be a what?
Maximum.
Right.
Maximum.
Now, all you want me to show you like a real goated hack? That's like insane.
Of course.
All right, let me show you this, right? Let me show you this. If I do a quick sketch of this, right? Remember, the y value tells us how high or how low the graph goes. That would make this point. So I'm going to do a quick sketch, right? I don't have any negative value, so I'm just considering that half of the quadrant. That's half of the graph. So let me just say that, let me just say x is 5 here. Let me just say this is 5. X is 3 over here. 11 and 2/3, let me just say 11 and 2/3 is over here. And 15 will be higher than that.
Yes, sir.
Yeah. So if I plot in 315, 315 will be over here. And if I plot in 511 2/3, that will be over here. So watch this. Watch this fast. I'll see what I'm talking about. Let me know if let's see what I'm talking about. Yeah or no?
Yes, sir.
Yes, sir.
So in doing this, you could know which one was the maximum and which one was the minimum. Right? And so you could all guys probably want to make all your answer like A plus. You could do a quick sketch and you could see as per the graph, you can clearly see that 15 is more than 11 over 11 2/3, and so that has to be the maximum. And you would say 11 and 2/3 is less than 15, so that has to be the minimum. So yeah, we good, we clutch, and we real good. No confusion at all, right?
No, sir, all good.
Okay, great. Nice. So now we need to figure out the equation of that curve. So let's do that real quick. Right. Okay, so let's move on. So guys, I kind of moving on to integration here, right? Truth be told, there's no more we can really do in differentiation. There's rates of change, but I doubt they're going to come tomorrow. Granted, I'll still do one question on it, but I'm going to start to go on to integration, right? How are we feeling, chat? Are they feeling good? Yes or no?
Yes, sir.
Let me know if we're cooking in the chat. Let me know. Cooking, are we dying? Right, so to figure out the equation of a curve. So guys, all you need to know that the integrating is the opposite of dy dx. So guys, if I wanted to undo the first derivative, what would I have to do with dy dx?
You'd have to.
Yes, so if I wanted to find back y, I would need to integrate dy dx because integrating would undo the dy dx and it would give me back y. So if you didn't know, now you know, right? So if you integrate dy dx, you'll get back y. Obviously plus c. But for simplistic sake, just know that if you integrate dy dx, you're gonna get y, right? So let me ask somebody, chat, do we have the equation for dy dx?
Yes,
Yeah.
yes, sir.
Right, we do have the equation for x, right? So to figure out the equation of the curve, I'll need to integrate dy dx. Recalling that dy dx is equal to ax squared minus 8ax plus 15a, right? So that's going to be, so I'm going to write the integral of dy dx here, dx. So I'm integrating both sides here, right? I'm integrating both sides. So integral of ax squared minus 8ax plus 15a dx. On the left-hand side, remind me, since I'm undoing dy dx, what will I have on the left-hand side?
Y.
I would have y, right? So y is going to be equal to what?
The integral.
So I'm going to start to integrate. I'm going to take my time. So guys, when we are integrating, you are adding 1 to the power, and then you're dividing by that new power. So over here, it's going to be ax to the power 3 divided by 3 minus 8a. The understood power of x is 1. So you're going to add 1 to the power. 1 plus 1 is 2, and you're going to divide by 2. Then we're going to have plus 15a. And since 15a is a constant, I'm going to slap on an x in. So in integration, if you have a constant, you put c on it. I mean, yeah, you slap on an x on it. So if we had to integrate something like 5 dx, that'll be equal to 5x. So 15a is a constant, so 15ax. If all you're confused, let me know. Because like we're going into like scary territory here. This is like scary territory. Yes or
Sir,
no?
I am confused.
The whole thing confusing, yeah. If the whole thing
What's that, sir?
tell me.
Sir, I didn't hear what you said.
Yeah, I was saying, sorry for cutting you off. Tell me what you were saying. Tell me what you were
I'm saying that you kind of lost me, like, at the beginning.
Yeah. This is like scary territory. This is not for the faint of heart. I'm praying to God this will come tomorrow. Because if it does, half all it cooked. And I mean that in the most sincerest way possible. I will send the notes and everything, but this is not easy. I myself, if I was in another situation, I would feel like I would have some trouble with this question. Right? So here what? Try not to stress yourself over this question. It's late in the night. If you're not understanding this particular question, don't hurt your head. Focus on other things. Right? Focus on other things. I pray to God this will come. I pray to God. And my prayers will come. So for those who do understand, let's proceed. But here I say, don't worry about it. We will focus on other things to get marks. So try to understand what we're doing here though. So you understand that the integral is the opposite of dy dx. Tell me if you know that.
Yes, sir.
So if I integrate dy dx, it comes like I undo the differentiation. So I'll get y. And how do we integrate? To integrate, you're adding 1 to the power and dividing by that new power. You understood everything I did here?
Yes, sir.
Okay, great. So don't worry. Don't worry. I will do some questions that will give you easy marks. This is not easy marks. You have to work for these marks. Right? So somebody that does understand this, let's proceed. So if I integrate this, since it's an indefinite integral, I will have to put plus c. Let me know if that makes sense. Yes or no?
Yes.
Yes, sir.
Yes, sir.
Okay, before I move on, I'm going to simplify this. So that's going to be ax cubed over 3, right? Minus 4ax squared plus 15ax plus c. Now, guys, I always tell my students, if you see two unknowns, what do I mean? What does two unknown means? Anytime you see two unknowns, what does that mean?
Quadratic.
Simultaneous.
Simultaneous.
Yeah, simultaneous equation. Some are probably thinking, well, and we have 1, 2, 3, 4 unknowns. No, that's not true. And we have points. Somebody tell me, and we have points?
Yeah.
We have points, and we know what x and y is for 2 points? Yeah. So that the only thing I really don't know what A and C is. So we need to find for that now. So we're gonna do that. Yeah. And it's not gonna be hard, right? It's gonna be easy. 5. Right, so let me go, guys. Let me go. So guys, I want to know the simultaneous equations in common, right? Simultaneous equations in common. So the unknowns here, for those not seeing it, is A. We have A and we have C. Right? So A and C. Are they seeing it, right? A and C.
Yes, sir.
How much marks this question was for? 4 marks is crazy. That 4 marks is absolutely crazy. You're wicked, real wicked. Nah. Whoever made this question was they wanted to see the children cry. They really wanted to see all they cry. They was plotting against all their downfall. That's what they was doing. Right? So I'm gonna move on to a new page where I have more space. But before I move on to a new page, let's plug in x and y. So guys, since we have 2 sets of information, how much equations do you think we can come up with?
2.
Right? So in this example, x and y is given and x and y is given here. So let's deal with this first. So 11 there, I'm gonna write that as a improper fraction. That should be 35 over 33. Just confirm that the math's correct. 35 over 33. And that's gonna be equal to a by 5 cubed over 3 minus 4.
So it would be 35 over 3.
Oh boy, why I say 33? What? Yeah, 35 over 3. Yeah, my bad. Minus 4a, 5 squared plus 15a by 5 plus c. You understood everything I did there? Yes or no?
Yes, sir.
Guys, if you're confused, don't worry about this. Relax and come back when things not so complicated. Because if you're not understanding this now, it's very, very hard to fully understand this no matter how much I try to teach it. But don't hurt your head about it. Try to focus on what you're good at, and you'll win. Don't worry. Don't worry. So let's proceed. So we're gonna simplify, right? So I have 35 over 3, and that's equal to 5 cubed is 125. So we have 125 over 3. 125 over 3. That remains as 125 over 3. So we have 125 over 3a, right? And then we have minus 4 by 25. 25 by 4 is 100. That's supposed to be minus 100a, right? And it's going to be 15 by 5. 15 by 5 is 75a plus c. Just make sure that our math's correct. Our math's correct, yes or no? Somebody unmuted and they have real noise. Real noise. All right, so guys, I believe what I did here was correct because 5 squared is 25. 25 by minus 4 is minus 100a. 15 by 5 is 75a. So cool. Now we need to simplify the left-hand side. I mean, your right-hand side, we have to simplify, right? So on your right-hand side, you need to recognize that you have 125 over 3a. You also have minus 100a, and you also have 75a. So what I would advise you all to do, in the calculator, I would put 125 over 3 minus 100 plus 75. So go to that and tell me what you're getting.
So I got 50 over 3.
50 over 3 is correct. Right, so you understand by doing that, I cut down a lot. So I cut down a lot on brain power. Right, plus C. Now, do we like working with fractions? Does any sane person like working with fractions unless you hate yourself?
I kind of hate myself, so yeah.
Nah, I don't hate myself, so I'm not going subject
You're
myself.
gonna multiply by 3?
I'm gonna multiply by 3 on both sides. So if I'm
So
yeah, tell me.
would it be 100 over 3?
100 over 3. For what?
125 minus 100 is 25 plus 75 is 100.
Wait, it needs to be to the same, it needs to have the same denominator. It needs to have the same denominator. Keep that in mind, same denominator, right? So
Okay.
Does minus 100 is minus 100 over 3?
No.
Nah, so I can't do anything for that. I can't do anything for that, right? I can't. So
Okay.
I'm gonna multiply both sides by 3. If I do that, it's gonna become 35, and 35 is equal to 50a plus 3c. So nice. Oh my God, this looks so refreshing. We don't have any fractions. So this is equation 1. Let's find for equation 2. Whoever create this question, real wicked boy. Wee. Nah. So let me keep pushing, right? They're not gonna get any better of us. We better than that. And the other point is 3, 15.
So you're posting this whole document in the advanced group chat in the morning?
I'm posting this right after. So when we finish the question I given earlier, like a 5 minutes break, then we're gonna move on to an integration fully. We're gonna move on to integration fully.
All right.
Right? So now I need to plug in 315 into y. Hey, what do you think the person that was doing this was thinking?
They hate trying
They were
to
trying.
my
life to do. They were trying a new method of torture.
I don't think it was torture, no. I think it was they wanted Ollie to commit suicide. I think like they wanted Ollie to kill herself. Because it's crazy. Telling Ollie this is genuinely crazy. 4 marks is ridiculous. I would leave out the question if I was in Ollie's position. Actually, no, I would do the question. But if Ollie stumble upon a question and it's too hard, don't waste your time on it. Do what you could and maximize the marks, right? So let me proceed. So I have 15 here. X is 3, so 3 cubed over 3 minus 4a 3 squared plus 15a by 3 plus c. So that's going to work out to be 15 is equal to 27 over 3 is 9a. That's gonna be 9, that'll be minus 36a. That'll be 45a plus c. Yes or no, just verify that you're getting that. 9a minus 36 is, God, I'm gonna write that a better. Yeah. So 9 minus 36 plus 45 minus 36.
So when they divide by 2. Oh, never mind.
You understand everything? Yeah or no? It was saying something.
Oh, yes, sir, my bad.
Okay, right? So when you work out this, so in the calculator, you're gonna put 9 minus 36 plus 45, right? Put 9 minus 36 plus 45, and you should get 18a. Yes or no? Let's verify that.
Yes, sir.
Okay, so we have two equations, so we need to solve them, right? How I would solve this, I would use elimination. Honestly, I would use elimination. So, I'm just gonna write the equations. I'm just gonna swap the left-hand side with the right-hand side to make it look simpler. So that being said, I'm gonna end up with 50a plus 3c is equal to 35. That's equation 1. And equation 2 was 18a plus c is equal to 15. Now, when we do an elimination, the aim of the game is to get rid of one of the unknowns. So what unknown looking like the easiest to get rid of here?
C.
It said you could do this on the Casio.
I believe you could. I believe you could. I'm not sure how to do. I don't think my one have that function. If you have the
Yes, sir. You have to do. You have to go into menu setup. When you go on 9, is the first one, option A is equation, right? And afterwards, you see something simultaneous equation and polynomial. You press 1, which is simultaneous equation. And then the highest one, you pick like is I think is 2. And then you put in like the numbers.
Oh, you have the FX991EX plus. That's like the shiny.
Yeah.
So which one you have?
I have the FX991ES plus. That one, this one don't have the function.
Yes, sir. Go to pull up menu, go to 5 for equation and 1. And just plug in your values.
Okay, well, Word. Well, Word, say no more. Big up on yourself. Right? Big up on yourself. Thank you for that. I'll show my other students that. Nice. So you could solve it, right? So in this case, you're gonna put 50. So let me repeat that process again, right? So you're gonna go, big up the fellas. You're gonna press mode setup. You're gonna press 5 for equation. Then you're gonna press 1. You're gonna see a and x plus b and x, whatever the case is. In this case, this is a, this is b, and this is c. Right? So you're gonna put 50 for a. You're gonna put 3 for b, and you're gonna put 35 for c. That's on top. In the bottom, you're gonna put 18 for a. You're gonna put 1 for b, and you're gonna put 15 for c. You should get x is equal to 5 over 2 and x is equal to 2. X is 5 over 2. Wait. X is 5 over 2 and the other
Yes, sir.
So they're getting true, right? Everybody.
And y is minus 30.
Right. So big up on yourself. Thank you so much. I must say.
Yeah, no sin, sir.
I must say,
no problem, sir.
Yes, I feel ashamed. But you learn everything. You learn something new every day. So let me show you how you would do this the long way. So I would multiply the second equation by 3. If I multiply the second equation by 3, I'm going to end up with 18 by 3. That should be 54, right? 54a. Just confirm if I did the maths correct. 54a, 18 by 3. 18 by 3. Is 18 by 3 54? I'm not hearing anybody.
Yes, sir, 54.
Right, and then 15 by 3 is 45. Granted, now that I know, by the way, we're going to call this equation 3, right? Now that I have 3c and 3c, what could do these two?
You're gonna subtract?
I'm going to subtract, right? So 50a minus 50 is minus 4a. So 3c minus 3c is 0. And 35 minus 45 is minus
10. Minus 10.
Oh my God. Yeah, minus 10. What's saying, boy? What the hell? Right?
We all tight.
And so minus 4a. Oh, I teaching since 9 o'clock this morning. Well, I was helping students
You
as
more so than me, sir.
I
You
start
more so than me.
I start class at 12 with my general class, and we went 12 to 3, past 3, and then I start this. So yeah. Right, so I have minus 4a is equal to minus 10. And so I want to find for 1a, so I will divide both sides by what? What am I going to divide both sides by?
Minus 4.
So a is going to be equal to minus 10 over minus 4. What's minus 10 over minus 4 in simplest form? I should get 2.5.
5 over 2, yeah.
Right, because 4 by 2 is 10, and then half of 4 is 2, 8 plus 2 is 10. Yeah, that's a quick. And since we know what a is, you can plug it into any equation to find for c. Now, which equation looking like is the easiest to find for c?
Equation 2.
Equation 2, right? So I would say 15 is equal to 18 by 2.5 plus c, right? So 18 by 2.5, that should be 36 plus 9 is 45. 45, right? And so when I move it across, the answer will be minus 30, right? So 15 minus 45 is equal to c. So c is equal to minus 30. Right. I'm going to follow you okay with everything that I did here. We good, gang? Let me know. Let me know if we're good.
Yes, sir.
And
Yes, sir.
so now that we know what A and C is, I could actually find for Y. Now, this question evil, boy. This is something that will come in like a pure maths paper, like a unit 1 pure maths paper. And so A would be equal to 2.5 x cubed all over 3, right? Minus 4 by 2.5 x squared plus 15 by 2.5 x, and C is minus 30, so I put minus 30 there. Do you understand what I do? I do that? Yes or no?
That's it.
All right, so now we need to simplify. What is 2.5 over 3? That's supposed to be 5 over 6. So 5 over 6 x cubed, right? 4 by 2.5 is 10, I believe. 15 by 2.5, 15 by 2 is 30. That should be 37, 37.5, I think. I'm gonna check. Yeah, 37.5, nice. How about 75. I'm gonna write it as 75 over 2, since we're working with fractions. Right? Minus 30. So that's your answer, guys. After trials and tribulations, that's your answer. That's the answer for Y. Bam. I'm gonna fully understand that.
So I could see the question again, please.
I like what this man asks if you can see the question again, right? Because there's so much thing we do, right? You're wondering what exactly we had to do in the first place. They said determine the equation of the curve.
And that is only 4 marks?
Yeah, that's only 4 marks. Ridiculous, sense? Ridiculous. This is absolutely ridiculous. Yeah. So here what? Take a 5 minutes break, come back, and we go do equal integration. Yeah, guys. See you in 5 minutes. Cool. All right, so I'll send any document one time, guys? One time. We don't stick. So we starting back at 10:45.
Yes, sir.
Chat, if all you posting any stories and thing, make sure and tag me, Rajiv Dwarka or Math Vibes, right? Big up all yourself one time. I'm trying to grow this thing. Let me send this one time. All right.